Welcome to AWS Full Course Part 2 by Simplilearn. In previous video, we covered various concepts of AWS like AWS Foundation Services, AWS Architecture, AWS Lambda. In this video, we will be learning about AWS Elastic Beanstalk, AWS Redshift, AWS versus Azure, AWS ELB, AWS EBS and more. So before we begin, consider subscribing to our channel and hit the bell icon to never miss any updates from Simplilearn.
So today's session is on AWS Elastic Beanstalk. So what's in it for you today? We'll be discussing about what is AWS, why we require AWS Elastic Beanstalk, what is AWS Elastic Beanstalk, the advantages, disadvantages, the components of Beanstalk, along with that, the architecture and the companies that are primarily using the AWS Beanstalk. So let's get started and first understand what is AWS. AWS stands for Amazon Web Services. It's a cloud provider and that offers a variety of services such as compute power, database storage, content delivery, and many other resources. So we know that AWS is the largest cloud provider in the market, and so many services are available in the AWS where you can apply the business logics and create the solutions using the cloud platforms. Now, why AWS Elastic Beanstalk? Now, what happened earlier and that whenever the developer used to create the software or the modules related to the softwares, it has to be joined together to create a big application. Now, one developer creates a module that has to be shared with another developer. And if the developers are geographically separated, then it has to be shared over a medium, probably an internet. So that is going to take some time. It would be a difficult process, and in return it makes the application or a software development a lengthier process, the building of the software development a lengthier process. So there were challenges which the developers were facing earlier, and to overcome that we have the Beanstalk as a service available in the AWS. So why AWS Elastic Beanstalk is required? AWS Elastic Beanstalk has made the life of the developers quite easy in terms of that they can share the applications across different devices at a shorter time duration. Now let's understand what is AWS Elastic Beanstalk. AWS Elastic Beanstalk is a service which is used to deploy and scale web applications by developers. Not only web application, any application that is being developed by the developers. This is a symbol representation of the AWS Elastic Beanstalk. Now, along with that, the AWS Elastic Beanstalk supports the programming language, the runtime environments that are Java, .NET, PHP, Node.js, Python, RubyGo, and Docker. And in case if you're looking for any other programming language or a runtime environment, then you can make a request with AWS to arrange that for you. Now, what are the advantages associated with the Elastic Beanstalk? First advantage is that it's a highly scalable service. Now, when we talk about the scalability, it means that whenever we require the resources in demand, we can scale up the resources or we can scale down the resources. So that is kind of a flexibility we get in terms of changing the type of resources whenever we need it. And in that case, the Elastic Beanstalk is a highly scalable service. Now that is something which is very difficult to achieve in case of an on-prem environments, because you have to plan for the infrastructure, and in case if you're short of the resources within that infrastructure, then you have to procure it again. The second advantage associated with the Beanstalk is that it's a fast and simple to begin. Now when we say it's fast and simple, that means that you just have to focus on the development of an application, building an application, and then you can just deploy the application directly using the Beanstalk. What the Beanstalk is going to do, that every networking aspect is being taken care by the Beanstalk. It deploys your application in the backend on the servers, and then you can directly access your application using the URL or through the IP address. The third advantage is that it offers the quick deployment. That is what we discussed in the fast and simple to begin as well. So why it offers a quick deployment? You don't have to bother about the networking concepts. You just have to focus on the application development, and then you can just upload your application, deploy that, and then you are good to go. The other advantage is that it supports multi-tenant architecture. When we talk about tenants or multi-tenants, that means we can have a virtual environments for separate organizations or the divisions within the organizations that will be virtually isolated. So likewise, you can have virtually isolated environments created on the Beanstalk and they can be separated, used as a separate entities or a separate divisions within the organization. And we know that it's a flexible service. Since it's a scalable, then it is a flexible also. Now coming to the simplifies operations as an advantage. Now once the application is deployed using the Beanstalk, then it becomes very easy to maintain and support that application using the Beanstalk services itself. And the last advantage that we can have from the Beanstalk is that it's a cost efficient service. The cost efficient, as we know that many of the AWS services are cost effective. The cost optimization can be better managed using the AWS Beanstalk as compared to if you are developing or if you are deploying any kind of an application or a solution on the on-prem servers. Now there are some components that are associated with the AWS Beanstalk, and it has to be created in the form of a sequence manner. So AWS Elastic Beanstalk consists of few important components which are required while developing an application. Now what are these components? These are 4 components. One is application, the second is application version, the third is environment, and the fourth one is the environment tier. And we have to progress while deploying our applications or the softwares using the same sequence. Now let's understand what are the different components of the Beanstalk are. The application. It refers to a unique label which is used as a deployable code for a web application. So generally you deploy your web application or you create your application, and that is something which is basically used as a unique label. Then the second component is application versions. So it resembles a folder which stores a collection of components such as environments, versions, and environment configurations. So all these components are being stored using the application version. The third most important component is the environment. In the environment, only the current versions of the applications runs. Now remember that Elastic Beanstalk supports multiple versions as well. And using the environment, you can only run the current version of the application. For if you wanted to have another version of an application to be running, then you have to create another environment for that. Then comes the environment tier. And in the environment tier, it designates the type of application that the environment runs on. Now generally there are 2 types of environment tier. One is the web and the other one is the worker node, and that's something which we'll be discussing later as well. Now let's understand how does Elastic Beanstalk in AWS works. So first we have to create an application, and this is a task that would be done by the developers. And for that you can actually select any runtime environment or a programming language like Java, Docker, Ruby, Go, Perl, or Python as well. And once you select that environment, you can develop your application using that runtime environments. Now after that, once the application is created, then you have to upload the version of an application on the AWS. And after that, once the version is uploaded, and then you have to launch your environment. So just have to click on the buttons, that's it, nothing more you have to do. Once the environment is launched, then you can actually view that environment using a web URL or using the IP address. Now what happens in that case is when you launch an environment in the backend, the Elastic Beanstalk automatically runs an EC2 instance. And using a metadata, the Beanstalk deploys your application within that EC2 instance. That is something which you can look into the EC2 dashboard as well. So you don't have to take care of the security groups, you don't have to take care of the IP addressing, and even you don't have to log in into the instance and deploy your application. It would be done automatically by the Beanstalk. It's just that you just have to monitor the environment, and the statistics will be available there itself in the Beanstalk dashboard. Otherwise, you can view those statistics in the CloudWatch logs as well. Now in case if you wanted to update any kind of a version, then you just upload a new version and then just deploy that and then monitor your environment. So these are the essentials to create a local applications for any platform, whether it's a Node.js, Python, etc. These are the things that you have to actually take care, and this is the sequence you have to follow while creating an environment. So you can say that it's a 4 steps creation of or deployment of your application. That's it. Now after users upload their versions, the configuration is automatically deployed with a load balancer. Yes, and with a load balancer, that means you can access the applications using the load balancer DNS also. And apart from load balancer, if you wanted to put any other feature that includes the auto scaling, for example, if you wanted to create your EC2 instances where the application will be deployed within the virtual private cloud or in a particular subnet within the VPC, all those features that are available, and you can select them using the Beanstalk itself. You don't have to move out to the VPC. You don't have to actually go to the EC2 dashboard and select all those separately. Everything would be available within the Beanstalk dashboard. So that's what it says in the presentation, that after creating an application, the deploy service can be specifically accessed using the URL. So once the environment is created, there will be a URL defined. Now you can put a URL name also. That is something which you wanted to put for your application. You can define that. You can check for the availability of that URL, and then you have to use that URL to access your application over the browser. Now, once it is done, then in the monitor environment, it says the environment is monitor, provided capacity provisioning, load balancing, autoscaling, and monitor features. All those features are available there itself in the Beanstalk. Now let's understand the architecture of AWS Elastic Beanstalk. Now there are two types of environments that you have to select. You can select. One is the web server environment and the other one is the worker environment. So based on the client requirement, Beanstalk gives you two different types of environment that you have to select. Generally, the web server environment is the front end facing. That means the client should be accessing this environment directly using a URL. So mostly web applications are deployed using that environment. The worker environment is the backend applications or the micro apps, which are basically required to support the running of the web applications. Now it depends on the client requirement what kind of an environment you wanted to select. Now in the web server environment, it only handles the HTTP request from the client. So that's why we use the web server environment mostly for the web applications or any application which works on the HTTP, HTTPS requests. So it's not only the HTTP, you can use the HTTPS as well. The worker environment, it processes background tasks and minimizes the consumption of resources. So again, it is just like a kind of a microservice or an application services that are running in the backend to support the web server environment. Now coming to the understanding of the AWS Beanstalk. So this is how the architecture of the AWS Beanstalk is designed, and you can refer to that image also. Now in the web server environment, let's say if we select a web server environment, and it says that if the application receives client requests, the Amazon Route 53 sends these requests to the Elastic Load Balancer. Now obviously we discussed here that the web server environment is primarily an environment which receives the HTTP requests. It's a kind of a client facing environment. Now if the application receives a client request from the Amazon Route 53, this Route 53 is a service which is primarily used for DNS mapping. It's a global service and you can route the traffic from the Route 53, matching your domains towards the load balancer. And from the load balancer, you can point that traffic to the web server environment. Obviously, the web server environment is nothing. It's just the EC2 instances that would be running in the backend. Now here in the diagram, you can see that there are two web server environments and they are created in the autoscaling group. That means there is some kind of scaling options that are defined as well. And these instances are created in an availability zone, or they can be created in a different availability zone also for the redundancy as well. And these web application servers are further connected to your databases, which primarily will be in a different security groups. Probably it can be an RDS database also. So all these functionalities, all these features are basically available on the Elastic Beanstalk dashboard itself. Now what happens in that case is if the application receives client requests, Amazon Route 53 send these requests to the load balancer. Later, the load balancer shares those requests among the EC2 instances. How does that happen? It happens using a predefined algorithm. The equal distribution of a load is distributed to both the EC2 instances or n number of EC2 instances running in the availability zone. Now in the availability zones, every EC2 instance would have its own security group. They can have a common security group also. They can have their own security group as well. Now, after the security group, the load balancer is then connected to the Amazon EC2 instance, which are part of the autoscaling group. So that's something which we have discussed already. Now, this autoscaling group would be defined from the Beanstalk itself, and there will be some scaling options that will be created. It could be a possibility that it might be the minimum number of instances that would be running as of now, and based on the threshold defined, it may increase the number of EC2 instances, and the load balancer will keep on distributing the load to as many instances that will be created inside the availability zones. Obviously, there will be an internal health check that the load balancer will be first doing before distributing the real-time traffic to these instances created by the Beanstalk. Now what does autoscaling group does? It automatically starts the additional EC2 instance to accommodate increasing load on your application. That's something which we know that. And also it monitors and scales instances based on the workload as well. So depends on what kind of a scaling threshold you have defined in the autoscaling groups. And when the load of an application decreases, the EC2 instance will also be decreased. So whenever we talk about the autoscaling, generally it comes in our mind is that we scale up the resources. That means it increases the EC2 instances. In the autoscaling, you might have the scale down option also, scale down policy also created, in which if the load minimizes, it can terminate the additional EC2 instances as well. So that is something which will be automatically managed. All these features can be achievable using the Elastic Beanstalk, and with this feature accommodated, it gives you the better cost optimization. in terms of managing your resources. Now it says that Elastic Beanstalk has a default security group, and the security group acts as a firewall for the instances. Now here in this diagram, it says about the security group, autoscaling also. You might create it in a default VPC also. You might create it in your custom VPC also, where you can have the additional level of security is also created. You can have the NACLs, NACLs also defined here before the security groups. So that would give you the additional filtering option or the firewall option. Now it says that with these groups, with these security groups, it allows establishing security groups to the database server as well. So every database would also have its own security group, and the connection can be created between the web servers environment that is created by the Beanstalk to the database security groups as well. Now let's discuss about the worker environment. Now, understanding the worker environment, what happens is that the client, the web server environment is the client facing. The client sends a request for an access to the web server. And in this diagram, the web server further sends it to the SQS, which is a simple queue service. And the queue service sends it to the worker environment. And then whatever the worker environment is created for doing some kind of a processing or some kind of an application that is running in the backend, that environment initiates and then send back the results to this SQS and vice versa. So let's understand the architecture of a AWS Elastic Beanstalk with the worker environment. So when a worker environment here is launched, AWS Elastic Beanstalk installs a server on every EC2 instance. So that is in the case of a web server environment also. And later the server passes the request to the simple queue service. Now this service is an asynchronous service. Instead of a simple queue service, you can have other services also. It is not necessary that you need to have the SQS also. This is an example that we are discussing about. And the SQS shares those messages via a post request to the HTTP path over the worker environment. And there are many case studies also with respect to this kind of an environment that is being created, that is being done on many customers. And you can search for these kind of a case studies available on the internet. Now the worker environment executes the task given by the SQS with the HTTP response after the operation is completed. Now here what happens is a quick recap. The client requests for an access of an application to a web server using an HTTP request. The web server passes that request to the queue service. The queue service shares the message with the worker. Probably a worker might be the manual worker, and generally it's an automated worker. So it would be shared via the worker environment only. And the worker sends back the response with the HTTP response back to the queue. That response can be viewed directly from the queue service by the client using the web server. So this is one of the examples. Likewise, as I said, that there can be many other examples also where you can have the worker environments defined. Now, what are the companies that are using the Elastic Beanstalk? These are few of the companies that are primarily using. One is Zillow, Jelly Button Games, then you have League of Women Voters, eBury. These are some of the few listed companies, and obviously you search on the AWS site and you'll find many more organizations that are using the Elastic Beanstalk primarily for deploying their applications. Now the next thing is to go with the practicals, that how actually we use the Elastic Beanstalk. So let's look into the demo using the AWS Elastic Beanstalk. Now first you have to log in into the AWS console, and I'm sure that you might be having the accounts created, or you can use the IAM credentials as well. And then you have to select the region also. Now I am in the North Virginia region. Likewise, you can select any of the regions that are listed here. Now click on the services and you have to search for the Elastic Beanstalk. You can find the Elastic Beanstalk under the compute section. So here itself, you'll find the Elastic Beanstalk as a service. Now open this service, and there it will give you an option to create an environment. You have to specifically select an environment, probably a worker environment or a web service environment. So let's wait for the service to open. So we have the dashboard now available with us. This is how the Elastic Beanstalk looks, and this is the symbol representation of a beanstalk. Now what we have to do is we have to click on Get Started, and that will load, and you have to create a web app. So instead of creating a web app, what we'll do, we'll create a new application. So just click on Create a New Application. Put an application name. Let's say we put something like XYZ. You can put any description to your application. Let's say it's a demo app, and click on Create. Now it says you have to select an environment. Now the environment, the application name XYZ is created. You just have to select an environment. So click on Create One now, and it is going to ask you that what kind of an environment tier you wanted to select. So as we discussed that there are two types of environments. One is the web server and the other one is the worker environment. Let's look into it. What is defined by the AWS? AWS says that it has two types of environment tiers to support different types of web applications. Web servers are standard applications that listen for and then process HTTP requests, typically over port number 80. Workers are specialized applications that have a background processing task that listens for message on an Amazon SQS queue. Workers application posts those messages to your application by using the HTTP response. So that's what we saw in the case of the Beanstalk slides also. Now the usability of a worker environment can be anything. Now we'll do a demo for creating a web server environment. So just click on select and we have the environment name created. Now we can define our own domain. It ends with the region.elasticbeanstalk.com. Let's say I look for a domain which is XYZ only. That's the environment name. Now I'll check for the availability whether that domain name is available with us or not. And it says we don't have that domain name. So probably I'll try to make it with some other name, and let's look for the availability. XYZ ABC, and it says yes, it is available. Now once I deploy my application, I would be able to access the application using this complete DNS. So you can put a description. It's a demo app that we are creating, and then you have to define a platform as well. Now these are the platforms that are supported by the AWS. Let's say I wanted to run a Node.js environment. So I'll just click on the Node.js platform. The application codes is something which is basically developed by the developers, and you can upload the application right now, or you can do that later as well once the environment is ready. Now either you can select to create an environment if you wanted to go with all the default settings. Otherwise, if you wanted to customize it more, you can click on configure more options. So let's click on configure more options. And here you would be able to define various different features like the type of an instance. For example, what kind of an EC2 instance or a server that should be running so that the Beanstalk can deploy your applications over it. If you wanted to modify, just click on a modify button, and here you can modify your instances with respect to the storage as well. Now apart from that, if you wanted to do some modification in the case of monitoring, in the case of databases, in the case of security, or in the case of a capacity, let's look into the capacity. So here you can actually do the modification. So in the capacity, you can select the instance type also. By default, it is t2.micro, but in case if your application requires a larger type of an instance, then you can actually go for the instance type as well. Similarly, you can define your AMI IDs also, because obviously for the application to run, you would require the operating system also. So you can select that particular AMI ID for your operating system as well. Let's cancel that. Likewise, you have many other features that you can actually define here from the dashboard, and you don't have to go to the EC2 dashboard to do the modifications. Now let's go and create an environment. Let's assume that we are going with the default configuration. So this is going to create our environment. The environment is being created, and you can get the environment and the logs defined in the dashboard itself. So you'll see that the Beanstalk environment is being initiated, the environment is being started, and in case if there would be any errors or if it is deployed correctly, you'll get all the logs here itself. Now the environments are basically color coded. So there are different color codings that are defined. If you get the environment in a green color, that means everything is good to go. So here you can see that it has created an Elastic IP. It has checked the health of the environment. Now it has created the security groups, and that would be an auto security groups created by the Beanstalk. And the environment creation has been started. You can see that Elastic Beanstalk as Amazon S3 storage bucket for your environment data as well. This is the URL through which you will be accessing the environment, but right now we cannot do that since the environment is being created. Let's click on the application name, and here you can see that it is in a gray color. That means right now the build is being done. It is being created. Once it will be successfully created, it should change to the green color, and then we will be able to access our environment using the URL. Now if I move to the EC2 instances and see in the EC2 dashboard, if I see whether the instance is being created by the Beanstalk or not. So let's see, and let's see what are the differences in terms of creating an instance manually and getting it created from the Beanstalk. So click on the EC2. Let's go to the old EC2 experience. That's what we are familiar with. And let's see what's there in the dashboard. So here you can see one running instance. Let's open that. And the XYZ environment, which was created from the Beanstalk, is being initiated. The instance is being initiated. And that is something which is being done by the Beanstalk itself. We have not gone to the dashboard and created it manually. Now, in the security groups, if you see that, here the AWS Beanstalk security groups are defined. It has the Elastic IPs also defined. So everything is being created by the Beanstalk itself. Right. Now, let's go back to the Beanstalk and let's look into the status of our environment, whether the color coding has been changed from gray to green or not. And here you can see the environment is successfully created and we have that environment colored in green. We'll access the environment and it says it's a web server environment. Its platform is Node.js running on 64-bit Amazon Linux AMI and it's a sample application. Health status is OK. Now the other thing is that if you do not want to use the web console, the management console to access the Beanstalk, then the Beanstalk offers you the Elastic Beanstalk CLI as well. So you can install the command line interface and then you have the command references, CLI command references that you can actually play with and get your applications deployed using the Beanstalk itself. So this is one of the sample CLI commands that you can actually look into. Now let's look into the environment. Let's click on the environment and we'll be represented with the URL. It says health is OK. These are the logs that you have to follow in case if there are any issues. The platform is Node.js. That is what we selected. Now the next thing is you just have to upload and deploy your applications. So just click on upload and deploy. Select the version label or the name. Select file, and wherever your application is hosted at, just select that, upload it and deploy your application. You'll see that like your environment is created, similarly your application will be deployed automatically on the instance, and from this URL you will be able to view the output. It is as simple as just like you have to follow these 4 steps. Now let's see whether the Node.js environment is running on our instance before deploying an application. So we'll just click on this URL. Since the Beanstalk has already opened up the security groups or HTTP port 80 for all, we can actually view that output directly from the URL. So we have the Node.js running, that's visible here, and after that you just have to upload and deploy your application, and then from that URL you can get the output. Now this URL you can map it with the Route 53 service. So using the Route 53 DNS services, the domain names can be pointed to the Elastic Beanstalk URL, and from there it can be pointed to the applications that are running on the EC2 instance. Whether you wanted to point it to the URL directly using the Beanstalk, you can do that. Otherwise, as we saw in the slides, you can use the Route 53, point it to the load balancer, and then point it to the instances directly also once it is created by the Beanstalk. So that was the demo, guys, with respect to the Beanstalk and how we can actually run the environments. Apart from that, the operational tasks like system operations, you can manage all these things from the environment dashboard itself. So you have the configurations, you have the logs, you can actually check the health status of your environment, you can do the monitoring, and you can actually get the alarms and the events here. So let's say if I wanted to see the logs, I can request for the logs here itself, and I'll be represented with the full log report, and I can now download that log file and I can view the logs. So it's in the, so we have this bundle logs in the zip file. All right, so if you want to see some kind of logs with respect to Elastic Beanstalk activity, it's in the form of a notepad, and here you can see what all configurations the Beanstalk has done on your environment, on your instance. Similarly, you can go for the health, monitoring, alarms, events, and all those things.
Video. Here we're going to talk about Amazon ECS, a service that's used to manage Docker containers. So without any further ado, let's get started. In this session, we would like to talk about some basics about AWS, and then we're going to immediately dive into why Amazon ECS and what is Amazon ECS in general, and then it uses a service called Docker, so we're going to understand what Docker is. And there are competitive services available for ECS. I mean, ECS is not the own and only service to manage Docker containers. But why ECS? Advantage of ECS. We will talk about that. And the architecture of ECS. So how it functions, what are the components present in it, and what are the functions that it does. I mean, each and every component, what are all the functions that it does. All those things will be discussed in the architecture of Amazon ECS, and how it works, how it all connects together. That's something we will discuss. And what are the companies that are using ECS? What were the challenge and how ECS helped to fix the challenge? That's something we will discuss. And finally, we have a wonderful lab that talks about how to deploy Docker containers on an Amazon ECS. So let's talk about what is AWS. Amazon Web Service, in short called as AWS, is an web service in the cloud that provides a variety of services such as compute power, database storage, content delivery, and a lot of other resources, so you can scale your business and grow, not focus more on your IT needs and the rest of the IT demands. Rather, you can focus on your business and let Amazon scale your IT, or let Amazon take care of your IT. So what is that you can do with AWS? With AWS, we can create, deploy any application in the cloud. So it's not just deploying, you can also create your application in the cloud. It has all the tools and services required, the tools and services that you would have installed in your laptop or you would have installed in your on-premises desktop machine for your development environment. The same thing can be installed and used from the cloud. So you can use cloud for creating, and not only that, you can use the same cloud for deploying and making your application available for your end user. The end user could be internal users, the end user could be in the internet, the end user could be kind of spread all around the world. It doesn't matter. So it can be used to create and deploy your applications in the cloud. And like you might have guessed, now it provides service over the internet. That's how your users worldwide would be able to use the service that you create and deploy, right? So it provides service over the internet. So that's for the end customer. And how will you access those services? That's again through the internet. It's like the extension of your data center in the internet. So it provides all the services in the internet. It provides compute service through the internet. So in other words, you access them through the internet. It provides database service through the internet, over the internet. In other words, you can securely access your database through the internet, and a lot more. And the best part is this is pay as you go, or pay only for what you use. There is no long-term or beforehand commitment. Here, most of the services does not have any commitment. So there is no long-term and beforehand commitment. You only pay exactly for what you use. There's no overage, there's no overpaying, right? There's no buying in advance, right? You only pay for what you use. Let's talk about what ECS is. So before ECS, before containers, right? ECS is a service that manages Docker containers, right? It's not a product or it's not a feature all by itself. It's a service that's dependent on Docker container. So before Docker containers, all the applications were running on VM or on a host or on a physical machine, right? And that's memory bound, that's latency bound. The server might have issues, on and on, right? So let's say this is Alice and she's trying to access her application, which is running somewhere in her on-premises, and the application isn't working. What could be the reason? Some of the reasons could be memory full, the server is currently down at the moment, we don't have another physical server to launch the application, a lot of other reasons. So a lot of reasons why the application wouldn't be working in on-premises. Some of them are memory full issue and server down issue, very less high availability, or in fact single point of failure and no high availability, if I need to tell it correctly. With ECS, the services can kind of breathe free, right? The services can run seamlessly. Now how is that possible? Now those things we will discuss in the upcoming sessions. So because of containers and ECS managing containers, the applications can run in a high available mode. They can run in a high available mode, meaning if something goes wrong, right, there's another container that gets spun up and your application runs in that particular container. Very less chances of your application going down. That's what I mean. This is not possible with a physical host. This is very less possible with a VM, or at least it's going to take some time for another VM to get spun up. So why ECS, or what is ECS? Amazon ECS maintains the availability of the application and allows every user to scale containers when necessary. So it not only meets the availability of the application, meaning one container running your application or one container hosting your application should be running all the time. So to meet that high availability, availability is making sure your service is running 24/7. So container makes sure that your services run 24/7. Not only that, suddenly if there is an increase in demand, how do you meet that demand? Right? Let's say you had like 1,000 users. Suddenly the next week there are like 2,000 users. Right. So how do you meet that demand? Container makes it very easy for you to meet that demand. In case of VM or in case of physical host, you literally will have to go buy another physical host, or add more RAM, add more memory, add more CPU power to it, right? Or kind of club 2-3 hosts together, clustering. You would be doing a lot of other things to meet that high availability and also to meet that demand. But in case of ECS, it automatically scales the number of containers. It automatically scales the number of containers needed, and it meets your demand for that particular hour. So what is Amazon ECS? The full form of ECS is Elastic Container Service, right? So it's basically a container management service which can quickly launch and exit and manage Docker containers on a cluster. So what's the function of ECS? It helps us to quickly launch and quickly exit and manage Docker containers. So it's kind of a management service for the Docker containers you will be running in Amazon or running in the AWS environment. So in addition to that, it helps to schedule the placement of container across your cluster. So it's like this. You have two physical hosts, joined together as a cluster, and ECS helps us to place your containers. Now, where should your container be placed? Should it be placed in host 1? Should it be placed in host 2? So that logic is defined in ECS. We can define it. You can also let ECS take control and define that logic. Most cases you will be defining it. So schedule the placement of containers across your cluster. Let's say two containers want to interact heavily. You really don't want to place them in two different hosts, right? You would want to place them in one single host so they can interact with each other. So that logic is defined by us. And these container services, you can launch containers using AWS Management Console, and also you can launch containers using SDK kits available from Amazon. You can launch through a Java program. You can launch container using an .NET program. You can launch container using an Node.js program, as in when the situation demands. So there are multiple ways you can launch containers through Management Console and also programmatically. And ECS also helps to migrate application to the cloud without changing the code. So anytime you think of migration, the first thing that comes to your mind is that how will that environment be? Based on that, I'll have to alter my code. What's the IP? What is the storage that's being used? What are the different parameters I'll have to include? The environment parameters of the new environment. With containers, now that worry is already taken away, because we can create an pretty exact environment. The one that you had on premises, the same environment gets created in the cloud. So no worries about changing the application parameter, no worries about changing the code in the application. Right? You can be like, if it ran in my laptop, a container that I was running in my laptop, it's definitely going to run in the cloud as well, because I'm going to use the same container in the laptop and also in the cloud. In fact, you're going to ship it. You're going to move the container from your laptop to Amazon ECS and make it run there. So it's like the very same image, the very same container that was running in your laptop will be running in the cloud or production environment. So what is Docker? We know that ECS helps to quickly launch, exit, and manage Docker containers. What is Docker? Let's answer that question. What is Docker? Now, Docker is a tool that helps to automate the development of an application as a lightweight container so that the application can work efficiently in different environments. This is pretty much what we discussed right before the slide. I can build an application in my laptop or in on-premises in a container environment, Docker container environment, and anytime I want to migrate, right, I don't have to kind of rewrite the code and then rerun the code in that new environment. I can simply create an image, a Docker image, and move that image to that production or the new cloud environment and simply launch it there. Right, so no compiling again, no relaunching the application. Simply pack all your code in a Docker container image and ship it to the new environment and launch the container there. That's all. So Docker container is a lightweight package of software that contains all the dependencies. So because, when packing, you'll be packing all the dependencies. You'll be packing the code. You'll be packing the framework. You'll be packing the libraries that are required to run the application. So in the new environment, you can be pretty sure, you can be guaranteed that it's going to run because it's the very same code, it's the very same framework, it's the very same libraries that you have shipped, right? There's nothing new in that new environment. It's the very same thing that's going to run in that container. So you can be rest assured that they are going to run in that new environment. And these Docker containers are highly scalable and they are very efficient. Suddenly you wanted like 20 more Docker containers to run the application. Think of adding 20 more hosts, 20 more VMs, right? How much time would it take? And compared to that time, the amount of time that Docker containers would require to kind of scale to that amount, like 20 more containers, it's very less, or it's minimal or negligible. So it's a highly scalable and it's a very efficient service. You can suddenly scale number of Docker containers to meet any additional demand. Very short boot up time because it takes it's not going to load the whole operating system. And these Docker containers, they use the Linux kernel and features of the kernel like C groups and namespaces to kind of segregate the processors so they can run independently any environment, and it takes very less time to boot up. And the data that are stored in the containers are kind of reusable. So you can have an external data volume and I can map it to the container, and whatever the space that's occupied by the container and the data that the container puts in that volume, they are kind of reusable. You can simply remap it to another application. You can kind of remap it to the next successive container. You can kind of remap it to the next version of the container, next version of the application you'll be launching, and you don't have to go through building the data again from the scratch. Whatever data the container was using previously or the previous container was using, that data is available for the next container as well. So the volumes that the containers uses are very reusable volumes. And like I said, it's isolated application, so it kind of isolates by its nature. It kind of, by the way it's designed, by the way it is created, it isolates one container from another container, meaning anytime you run applications on different containers, you can be rest assured that they are very much isolated. Though they are running on the same host, though they are running on the same laptop, let's say, though they are running on the same physical machine, let's say, running 10 containers, 10 different applications, you can be sure that they are well disconnected or well isolated applications. Now let's talk about the advantages of ECS. The advantage of ECS is improved security. Its security is inbuilt in ECS. With ECS, we have something called as a container registry. That's where all your images are stored, and those images are accessed only through HTTPS. Not only that, those images are actually encrypted, and access to those images are allowed and denied through identity and access management policies, IAM. And in other words, let's say two containers running on the same instance. Now one container can have access to S3 and the others, or the rest of the others, are denied access to S3. So that kind of granular security can be achieved through containers when we mix and match the other security products available in Amazon, like IAM, encryption, accessing it using HTTPS. These containers are very cost efficient. Like I've already said, these are lightweight processes, right? We can schedule multiple containers on the same node, and this actually allows us to achieve high density on an EC2 instance. Imagine an EC2 instance that's very less utilized. That's not possible with a container, because you can actually dense or crowd an EC2 instance with more container in it. So to best use those resources in EC2, straightforward, you can just launch one application. But when we use containers, you can launch like 10 different applications on the same EC2 server. That means 10 different applications can actually feed on those resources available and can benefit the application. And ECS not only deploys the container, it also maintains the state of the containers, and it makes sure that the minimum set of containers are always running based on the requirement. That's another cost efficient way of using it, right? And anytime an application fails, and that has a direct impact on the revenue of the company, and ECS makes sure that you're not losing any revenue because your application has failed. And ECS is a pretty extensible services. It's like this: in many organizations, there are majority of unplanned work because of environment variation. A lot of firefighting happens when we kind of deploy the code from one, or kind of move the code or redeploy the code in a new environment. A lot of firefighting happens there, right? This Docker containers are pretty extensible. Like we discussed already, environment is not a concern for containers, because it's going to kind of shut itself inside a Docker container, and anywhere the Docker container can run, the application will run exactly the way it performed in the past. So environment is not a concern for the Docker containers. In addition to that, ECS is easily scalable. We have discussed this already, and it has improved compatibility. We have discussed this already. Let's talk about the architecture of ECS. Like you know now, the architecture of ECS is the ECS cluster itself. That's group of servers running the ECS service, and it integrates with Docker, right? So we have a Docker registry. Docker registry is a repository where we store all the Docker images or the container images. So it's like three components. ECS is of three components. One is the ECS cluster itself. Right? When I say ECS itself, I'm referring to ECS cluster of servers that will run the containers, and then the repository where the images will be stored, right? The repository where the images will be stored, and the image itself. So container image is the template of instructions which is used to create a container, right? So it's like, what's the OS? What is the version of node that should be running? And any additional software do we need? So those questions gets answered here. So it's the template of instructions which is used to create the containers. And then the registry is the service where the Docker images are stored and shared. So many people can store there, and many people can access, or if there's another group that wants to access, they can access the image from there, or one person can store the image and rest of the team can access, and the rest of the team can store image, and this one person can pick the image from there and kind of ship it to the customer or ship it to the production environment. All that's possible in this container registry. And Amazon's version of the container registry is ECR. And there's a third party. Docker itself has a container registry, that's Docker Hub. ECS itself, which is the group of servers that runs those containers. So these two, the container image and the container registry, they kind of handle Docker in an image format, just an image format. And in ECS is where the container gets live, and then it becomes an compute resource and starts to handle requests, starts to serve the page and starts to do the batch job, whatever your plan is with that container. So the cluster of servers, ECS, integrates well with the familiar services like VPC. VPC is known for securing. VPC is known for isolating the whole environment from rest of the customers, or isolating the whole environment or the whole infrastructure from the rest of the clients in your account, or from the rest of the applications in your account, on and on. So VPC is a service that provides or gives you the network isolation ECS integrates well with VPC. And this VPC enables us to launch AWS resources such as Amazon EC2 instance in a virtual private network that we specify. This is basically what we just discussed. Now let's take a closer look at the ECS. How does ECS work? Let's find answer for this question. How does ECS work? ECS has got a couple of components within itself. So these ECS servers can run across availability zone. As you can see, there are two availability zones here. They can actually run across availability zones. And ECS has got two modes, Fargate mode and the EC2 mode. Right here we're seeing Fargate mode, and then here we're seeing nothing. That means it's an EC2 mode. And then it has got different network interfaces attached to it because they need to be running in an isolated fashion, right? So anytime you want network isolation, you need separate IP, and if you want separate IP, you need separate network interface card, and that's what you have, Elastic Network Interface Card, separate Elastic Network Interface Card for all those tasks and services. And this runs within an VPC. Let's talk about the Fargate service. Tasks are launched using the Fargate service. So we will discuss about tasks. What is Fargate? Now, Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the cluster. ECS is a service that manages the containers for you, right? Otherwise, managing containers will be a full-time job. So ECS manages it for you, and you get to manage ECS. That's the basic service. But if you want Amazon to manage ECS and the containers for you, we can go for Fargate. So Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the ECS cluster. And the tasks that we discussed, the tasks has two components. You see task right here. So they have two components. We have ECS container instance and then the container agent. So like you might have guessed right now, ECS container instance is actually an EC2 instance, right, capable of running containers. Not all EC2 instances can run containers. So these are like specific EC2 instances that can run containers. They are ECS container instances. And then we have container agent, which is the agent that actually binds those clusters together, and it does a lot of other housekeeping work, right? Kind of connects clusters, makes sure that the version needed is present. So it's all part of that agent, or it's all job of that agent. Container instances is part of Amazon EC2 instance, which run Amazon ECS container agent. Pretty straightforward definition. And then a container agent is responsible for communication between ECS and the instance, and it also provides the status of the running containers. Kind of monitors the container, monitors the state of the container, make sure that the container is up and running, and if there's anything wrong, it kind of reports it to the appropriate service to fix the container, on and on. Right? So container agent, when we don't manage container agent, it runs by itself, and you really don't have to do anything to make the container agent better. It's already better. You really won't be configuring anything in the agent. And then Elastic Network Interface Card is a virtual interface network that can be connected to an instance in VPC. So in other words, Elastic Network Interface is how the container interacts with another container, and that's how the container interacts with the EC2 host, and that's how the container interacts with the internet, external world. And a cluster is a set of ECS container instances. It's not something that's very difficult to understand. It's simply a group of EC2 instances that runs that ECS agent. And this cluster handles the process of scheduling, monitoring, and scaling the request. We know that ECS can scale, the containers can scale. How does it scale? That's all monitored and managed by this ECS cluster. Let's talk about the companies that are using Amazon ECS. There are a variety of companies that use ECS clusters. To name a few, Okta uses ECS cluster, and Okta is a product that uses identity information to grant people access to applications on multiple devices at any given point of time. they make sure that they have a very strong security protection. So Okta uses Amazon ECS to run their Okta application and serve their customers. And Abima is an TV channel, and they chose to use microservices and Docker containers. They already had microservices and Docker containers, and when they thought about a service that they can use in AWS, ECS was the only service that they can immediately adapt to. And because in Abima TV the engineers have already been using Docker and Docker containers, it was kind of easy for them to adapt themselves to ECS and start using it, along with the benefits that ECS provides. Previously they had to do a lot of work, but now ECS does it for them. Right. Similarly, Remind and Ubisoft, GoPro are some of the famous companies that use Amazon ECS and get benefited from its scalability, get benefited from its cost, gets benefited from its Amazon managed services, get benefited from the portability that ECS and the migration option that ECS provides. Let's talk about how to deploy a Docker container on Amazon ECS. The way to deploy Docker container on ECS is, first we need to have an AWS account and then set up and run our first ECS cluster. So in our lab we're going to use the launch wizard to run an ECS cluster and run containers in them. And then task definition. Task definition tells the size of the container, the number of the container. And when we talk about size, it tells how much of CPU do you need, how much of memory do you need. And talking about numbers, it requires how many numbers of container you're going to launch. Is it 5, is it 10, or is it just 1 running all the time? Now those kind of information goes in the task definition file. And then we can do some advanced configuration on ECS, like load balancers and what port number you want to allow and you don't want to allow, who gets access, who shouldn't get access, and what's the IP that you want to allow and deny requests from, on and on. And this is where we would also mention the name of the container, so to differentiate one container from the other, and the name of the service. Is it an backup job? Is it a web application? Is it an data container? Is it going to take care of your data backend? And the desired number of tasks that you want to be running all the time. Those details go in when we try to configure the ECS service, right? And then you configure your cluster. You put in all the security in the configure your cluster step or configure cluster stage. And finally, we will have an instance and a bunch of containers running in that instance. All right, let's do a demo. So here I have logged in to my Amazon portal, and let me switch to the appropriate region. I'm going to pick North Virginia. North Virginia, look for ECS. And it tells ECS is a service that helps to run and manage Docker containers. Well and good. Click on it. I'm in North Virginia. Just want to make sure that I'm in the right region. And go to clusters. And here we can create cluster. This is our Fargate, and this is our EC2 type launching for Linux and Windows environment. But I'm going to launch through this walkthrough portal. Right? This gives a lot of information here. So the different steps involved here is creating a container definition, which is what we're going to do right now, and then a task definition, and then service, and finally the cluster. It's a 4-step process. So in container definition, we define the image, the base image we are going to use. Now here I'm going to launch an HTTPD or a simple HTTP web page, right? So a simple HTTPD 2.4 image is fair enough for me, and it's not a heavy application, so 0.5 gigabit of memory is enough. And again, it's not a heavy application, so 0.25 virtual CPU is enough in our case, right? You can edit it based on the requirement. You can always edit it, and because I'm using HTTPD, the port mapping is already port 80. That's how the container is going to receive the request. And there's no health check as of now. When we want to design critical and complicated environments, we can include health check, right? And this is the CPU that we have chosen. We can edit it, and I'm going to use some bash commands to create an HTML page. Right? This page says that Amazon ECS sample app, right? And then it says Amazon ECS sample app. Your application is running on a container in Amazon ECS. So that's the page, the HTML page that I'm going to create. Right, index.html. So I'm going to create and put it in an appropriate location so those pages can be served from the container. Right? If you replace this with any of your own content, then it's going to be your own content. ECS comes with some basic logs, and these are the places where they get stored. That's not the focus as of now. Right, so I was just saying that you can edit it and customize it to your needs. We're not going to do any customization now. We're just getting familiar with ECS now. And the task definition, name of the task definition is first run task definition, and then we are running it in a VPC. And then this is an Fargate mode, meaning the servers are completely handled by Amazon, and the task memory is 0.5 gigabit. And the task CPU is 0.25 virtual CPU. Name of the service. Is it a batch job? Is it an a front end? Is it a back end? Or is it a simple copy job? What's the service? Name of the service goes here. Again, this you can edit it. And here's our security group. As of now, I'm allowing port 80 to the whole world. If I want to restrict to a certain IP, I can do that. The default option for load balancing is no load balancer, but I can also choose to have a load balancer and use port 80 to map that port 80 to the container port 80. Right? I can do that. The default is no load balancer. All right, let's do one thing. Let's use load balancer. Let's use load balancer and port 80 receives information on port 80 HTTP. What's going to be the cluster name? We're in the last step. What is the cluster name? Cluster name can be Simplilearn ECS Demo. Next, we're done and we can create. So it's launching a cluster, as you can see, and it's picking the task definition file that we've created, and it's using that to launch an service. And then these are the log groups that we discussed, and it's creating a VPC. Remember, ECS clubs well with the VPC. It's creating a VPC, and it's creating two subnets here for high availability. It's creating that security group, port 80, allowed to the whole world, and then it's putting it behind an load balancer. It generally would take like 5 to 10 minutes, so we just need to be patient and let it complete its creation. And once this is complete, we can simply access these servers using the load balancer URL. And when this is running, let me actually take you to the other products or the other services that are integrated with ECS. It's getting created. Our service is getting created as of now. ECR repository. This is where all our images are stored. Now, as of now, I'm not pulling my image from ECR. I'm pulling it directly from the internet, Docker Hub. But all custom images, they are stored in this repository. So you can create a repository, call it app1, create a repository. So here's my repository. So any image that I create locally, or any Docker image that I create locally, I can actually push those images using these commands right here, and they get stored here. And I can make my ECS connect with ECR and pull images from here. So they would be my custom images. And as of now, because I'm using a default image, it's directly pulling it from the internet. Let's go to EC2 and look for a load balancer, because we wanted to access the application from behind a load balancer, right? So here is a load balancer created for us, and anytime I put the URL, so a cluster is now created. You see there's one service running. All right, let's click on that cluster. Here is the name of our application, and here is the tasks, the different containers that we are running. And if you click on it, we have an IP, right? IP of that container, right? And it says it's running, it was created at such and such time and started at such and such time. And this is the task definition file that this container uses, meaning the template, the details, all the version details, they all come from here, and it belongs to the cluster called Simplilearn ECS Demo, right? And you can also get some logs, container logs from here. So let's go back. And there are no ECS instances here, because remember, this is Fargate. you're not managing any ECS instance. Right, so that's why you're not seeing any ECS instance here. So let's go back to tasks and go back to the same page where we found the IP. Pick that IP, put it in the browser, and you have this sample HTML page running from an container. So let me go back to load balancer, EC2, and then under EC2 I'll be able to find a load balancer, find that load balancer, pick that DNS name, put it in the browser, and now it's accessible through the load balancer URL. Right, now this URL can be mapped to other services like DNS. This URL can be embedded. Hi there, I'm Sam from Simplilearn, and I'm very glad to walk you through this lesson about Route 53. So in this section, we are going to talk about basics of AWS, and then we're going to immediately dive into why we need Amazon Route 53. And then we're going to expand and talk about the details of Amazon Route 53, the benefits it provides over its competitors, and the different types of routing policy it has, and some of Amazon Route 53's key features. And we're going to talk about how to access Route 53, the different ways, the different methods you can access Route 53, and finally we're going to end with a wonderful demo in Route 53. So let's talk about what is AWS. Amazon Web Services, or AWS in short, is a cloud provider that offers a variety of services such as a variety of IT services or infrastructure services such as compute power, database, content delivery, and other resources that helps us to scale and grow our business. And AWS is hot, AWS is picking up, AWS is being adapted by a lot of customers. That's because AWS is easy to use even for a beginner. And talking about safety, the AWS infrastructure is designed to keep the data safe irrespective of the size of the data. Be it small data, be it very minimal data, be it all the data that you have in terabytes and in petabytes, Amazon can keep it safe in their environment. And the wonderful thing and the most important reason why a lot of customers move into the cloud is that the pay-as-you-go pricing. There is no long-term commitment and it's very cost effective. What this means is that you're not paying for a resource that you're not using. In on-premises, you do pay for resources you're not using a lot. Meaning, you go and buy a server, you do the estimate for the next 5 years, and only after like 3 or 4 years you'll be hitting the peak capacity, but still you would be buying that capacity before 4 years. Right, and then you will gradually be, utilizing it from, 40%, 60%, 70, 80, and then 100. So what you have done is that even though you're not using the full capacity, you still have bought it and are paying for it from day one. But in the cloud, it's not like that. You only pay for the resources that you use. Anytime you want more, you scale up the resource and you pay for the scaled up resource. And anytime you want less, you scale down the resource and you pay less for that scaled down resource. Let's talk about why Amazon Route 53. Let's take this scenario where Rachel is trying to open her web browser and the URL that she hit isn't working. A lot of reasons behind why the URL isn't working. It could be the server utilization that went high. It could be the memory usage that went high. A lot of reasons. And she starts to think, is there an efficient way to scale resources according to the user requirements? Or is there an efficient way to kind of mask all those failures and kind of divert the traffic to the appropriate active resource or active service that's running our application? You always want to hide the failures, right? In IT, kind of mask the failure and direct the customer to another healthy service that's running, right? None of your customers would want to see a server not available, or none of your customers would want to see your service not working. Not impressive to them. And this is Tom. Tom is an IT guy and he comes up with an idea and he's answering Rachel, yes, we can scale resources efficiently using Amazon Route 53. In a sense, he's saying that yes, we can mask the failure and we can keep the services up and running, meaning we can provide more high availability to our customers with the use of Route 53. And then he goes on and explains Amazon Route 53 is a DNS service that gives developers an efficient way to connect users to internet applications without any downtime. Now, downtime is the key. Amazon Route 53 helps us to avoid any downtime that customers would experience. You still will have downtime in your server, in your application, but your customers will not be made aware of it. And then Rachel is kind of interested and she's like, yeah, that sounds interesting. I want to learn more about it. And Tom goes on and explains the important concepts of Amazon Route 53. That's everything that I'm going to explain it to you as well. All right, so what is Amazon Route 53? Amazon Route 53 is a highly scalable DNS or domain name system web service. This service, this Amazon Route 53, it functions three main things, or it has three main functions. So the first thing is, if a website needs a name, Route 53 registers the name for the website domain. Let's say you want to buy google.com, you want to buy the domain name. Let's say you want to buy that domain name. You buy that through Route 53. Secondly, Route 53 is the service that actually connects your server, which is running your application or which is serving your web page. So that's the service that actually, Route 53 is the service that connects the user to your server when they hit google.com in the browser or whatever domain name that you have purchased. So you bought a domain name and the user types in your domain name.com, and then Route 53 is a service that helps the user to connect their browser to the application that's running in an EC2 instance or any other server that you are using to serve that content. Now, not only that, Route 53 checks health of the resource by sending automated requests over the internet to a resource. So that's how it identifies if there is any resource that has failed. When I say resource, I'm referring to any infrastructure failure, any application level failure. So it kind of keeps checking. So it understands it first before the customer notices it, and then it does the magic, kind of shifts the connection from one server to the other server. We call it routing. We will talk about that as we progress. So the benefits of using Route 53. It's highly scalable, meaning suddenly, let's say, the number of requests, the number of people trying to access your website through that domain name that you have bought, let's say it has increased. Route 53 is highly scalable, right? It can handle even millions and millions of requests because it's highly scalable and it's managed by Amazon. The same thing, it's reliable, it's highly scalable, it can handle large queries without you interacting, without the user who bought it interact with it. You don't have to scale up. When you're expecting more requests, it automatically scales. And it is very reliable in a sense that it's very consistent. It has the ability to route the users to the appropriate application through the logic that it has. It's very easy to use. When we do the lab, you're going to see that. It's very easy to use. You buy the domain name and then you simply map it to the application. You simply map it to the server by putting in the IP, or if you can simply map it to another load balancer by putting in the load balancer URL. You can simply map it to another S3 bucket by simply putting the S3 bucket name or the S3 bucket URL. It's pretty straightforward, easy to set up. And it's very cost effective in a way that we only pay for the service that we have used. So no wastage of money here. So the billing is set up in such a way that you are paying only for the amount of requests that you have received, right? The amount of traffic, the amount of requests that you have received, and a couple of other things. The number of hosted zones that you have created, right? And a couple of other things. It's very cost effective in such a way that you only pay for the service that you are using. And it's secure in a way that access to Route 53 is integrated with the Identity and Access Management, IAM. So you only have authorized users gain access to Route 53. The trainee who just joined yesterday won't get access. And the contractor or the consultant, the third-party consultant you have given access or who is using your environment, you can block access to that a particular person because he's not the admin or he's not a privileged user in your account. So only privileged users and admin gain access to Route 53 through IAM. Now let's talk about the routing policies. So when you create a record in Route 53, record is nothing but an entry. So when you do that, you choose a routing policy. Right? Routing policy is nothing but it determines how Route 53 responds to your queries, how the DNS queries are being responded. Right? That's a record, or that's a routing policy. So the first one is a simple routing policy. So we use simple routing policy for a single resource. In other words, simple routing allows to configure DNS with no special Route 53 routing. It's kind of one-to-one. You use a single resource that performs a given function to your domain. For example, if you want to simply map an URL to a web server, that's pretty straightforward, simple routing. So it routes traffic to a single resource, example, web server, to a website. And with simple routing, multiple records with the same name cannot be created, but multiple values can be created in the same record. The second type of routing policy is failover routing. So we would be using failover routing when we want to configure active, passive failover. If something failed, right, you want to fail over to the next resource, which was previously the backup resource, now the active resource, or which was previously the backup server, now it's an active server. So you would be failing over to that particular resource or that particular IP. If you want to do that, we use failover routing. So failover routing routes traffic to a resource when the resource is healthy, or to a different resource when the previous resource is unhealthy. In other words, anytime a resource goes unhealthy, it does all that's needed to shift the traffic from the primary resource to the secondary resource. In other words, from the unhealthy resource to the healthy resource. And this records can route traffic to anything from an Amazon S3 bucket, or you can also configure a complex tree of records. Now, when we configure the records, it will be more clear to you. So as of now, just understand that Route 53 can route, or this routing policy, the failover routing policy, can route traffic to Amazon S3 bucket or to a website that has complex tree of records. Geolocation routing policy. Now, geolocation routing, just like the name says, it takes that routing decision based on the geographic location of the user. In other words, when you want to route traffic based on the location of the user, that's your primary criteria for sending that request to the appropriate server, we would be using geolocation routing. So it localizes the content and presents a part or the entire website in the language of the user. For example, a user from US, you would want to direct them to an English website, and a user from German, if you want to send them to the German website, and a user from France, you want to send those requests, or you want to show content specific to a customer who lives in France, a French website. So this is, if that's your condition, this is the routing policy we would be using. And the geographic locations are specified by either continent or by country or by state in the United States. So only in the United States you can actually split it to state level, and for the rest of the countries you can do it on a country level. On a high level, you can also do it on a continent level. The next type of routing policy would be geo-proximity routing. Geo-proximity routing policy, when we want to route traffic based on the location of our resource and optimally shift traffic from resources in one location to resource in another location, we would be using geo-proximity routing. So geo-proximity routing routes traffic to the resources based on the geographic location of the user and the resources they want to access. And it also has an option to route more traffic or less to a given resource by specifying a value known as a bias. Kind of weight, but we also have weighted routing, that's different. So we've chosen different name, bias. You can send more traffic to a particular resource by having a bias on that particular routing condition. And a bias expands or shrinks the size of the geographic region from which traffic is routed to a resource. And then we have latency-based routing. Just like the name says, we use latency-based routing if we have resources in multiple AWS regions, and if you want to route traffic to the region that provides the best latency at any given point of time. So let's say if one single website needs to be installed and hosted on multiple AWS regions, then latency routing policy is what is being used. It improves the performance of the users by serving the request from the AWS region that provides the lowest latency. So at any given point, if performance is your criteria, and at any given point of time, irrespective of what happens in Amazon infrastructure, irrespective of what happens in the internet, if you want to route your users to the best performing website, best performing region, then we would be using latency based routing. And for using latency based routing, we should create latency records for the resources in multiple AWS regions. And then the other type of a routing policy is multi-value routing policy, where we can make Route 53 to respond to DNS queries with up to 8 healthy records selected at random. So you're not kind of loading one particular server. We can define 8 records, and on a random basis, Route 53 will respond to queries from these 8 records. So it's not one server that gets all the requests, but 8 servers gets the request in a random fashion. So it's multi-value routing policy, and what we get by this is that we are distributing the traffic to many servers instead of just one server. So multi-value routing configures Route 53 to return multiple values in response to a single or multiple DNS queries. It also checks the health of odd resources and returns the multiple values only for the healthy resources. Let's say out of the 8 servers we have defined, one server is not doing healthy, it will not respond to the query with the details of the unhealthy server, right? So now it's going to treat it as only 7 servers in the list because one server is unhealthy. And it has the ability to return multiple health checkable IP addresses to improve availability and load balancing. The other type of routing policy is weighted routing policy, and in here we use to route traffic, or this is used to route traffic to multiple resources in a proportion that we specify. So this is an weighted routing, and weighted routing routes multiple resources to a single domain name or a subdomain and control the traffic that's routed to each resources. So this is very useful when you're doing load balancing and testing new versions of the software. So when you have a new version of the software, you really don't want to send 100% of the traffic to it. So you want to get customers' feedback about the new software that you've launched, new version or new application that you've launched. So you would kind of send only 20% of the traffic to that application, get customer feedback, and if all is good, then we would move the rest of the traffic to that new application. So any software launches, application launches will be using weighted routing. Now let's talk about the key benefits or key features of Route 53. Some of the key features of Route 53 are traffic flow. It routes end users to the endpoint that should provide the best user experience. That's what we discussed in the routing policies, right? It uses a routing policy, a latency-based routing policy, and geo-based routing policy, and then failover routing policy. So it kind of improves the user experience. And the other key feature of Route 53 is we can buy domain names using Route 53 console. We can buy it from here and use it in Route 53. Previously it was not the case, but now we can buy it directly from Amazon through Route 53, and we can assign it to any resources that we want. So anybody browsing that URL, the connection will be directed to the server in AWS that runs our website. Health checks. It monitors health and performance of the application. So it comes with an health check attached to it. Health check are useful to make sure that the unhealthy resources are retired, right? The unhealthy resources are taken away, or your customers are not kind of hitting the unhealthy resources and they see an service down page or something like that. We can have weighted round robin load balancing. That's helpful in spreading traffic between several services or servers via a round robin algorithm. So no one server is fully hit, or no one server kind of fully absorbs all the traffic. You can split and shift the traffic to different servers based on the weight that you would be configuring. And also weighted routing also helps with soft launch of your new application or the new version of your website. There are different ways we can access Amazon Route 53. So you can access Amazon Route 53 through AWS console. You can also access Amazon Route 53 using AWS SDKs, and we can configure it using the APIs. And we can also do it through the command line interface. That's Linux type, Linux flavor, AWS command line interface. We can also do that using Windows command line, Windows PowerShell flavored command line interface as well. Now let's look at some of the companies that are using Route 53. So some of the famous companies that use Route 53 are Medium. Medium is an online publishing platform, and it's more like a social journalism. It's kind of having hybrid collection of professionals, people and publications, or exclusive blogs or publishers on Medium. It's kind of an blog website, and that uses Route 53 for the DNS service. Reddit is an social news aggregation or web content rating and discussion website that uses Route 53. So these are some websites that are accessed throughout the world, and they are using Route 53, and it's highly scalable. Suddenly if there is a new news, right, their website will be accessed a lot, and they need to keep their service up and running all the time, more availability, otherwise customers will end up in a broken page, and the number of customers who will be using the website will come down. So it's very critical. Now these companies are very critical, they being highly available, their site being highly available, and the internet is very critical and crucial for them, and they rely and use Route 53 to meet that particular demand. And Airbnb is another company, Instacart, Coursera is another company, Stripe is another company that uses Route 53 as their DNS provider for their DNS service. They use Route 53 so their customers get best performance. They use Route 53 so their website is highly available. They use Route 53 to kind of shift the traffic between the resources, so their resources are properly used with all the weighted routing. Their resources are properly used. Now let's quickly look at a demo. I'm in my AWS console and I'm in Route 53. So let me click on Route 53. So in this lab, we're actually going to simulate buying a domain name, and then we're going to create an S3 static website, and we're going to map that website to this DNS name, right? So the procedure is the same for mapping load balancer. The procedure is the same for mapping CloudFront. The procedure is the same for mapping EC2 instances as well. We're picking S3 for simplicity, right? But our focus is actually on Route 53. So let's go in here and we'll see if we can, we'll buy a domain name here. So let's first check the availability of a domain name called Simplilearn-demo-Route 53. Let's check its availability. It is available for $12, so let me add it to cart and then come back here. And then once you continue, it'll ask for personal information. Once you give the personal information, you finally check out, and then it gets added to your shopping list. Once you pay for it, Amazon takes like 24 to 48 hours to make that DNS name available. So the next stage would be contact details, and then the third stage would be verify and purchase. So once we have bought the domain name, it will become available in our DNS portal, and I do have a domain name which I bought some time back, and it's now available for me to use. So I can go to hosted zone and simply start creating. I can go to hosted zone, and then here it's going to list all the domain names for me, right? Click on the domain name and then click on the record set, and here I can actually map Elastic Load Balancer, S3 website, VPC endpoint, API gateway, and CloudFront, Elastic Beanstalk domain names, right? All that gets mapped through this portal. Quite simple, like 4 or 5 step button clicks, and then it'll be done. So I have an domain name bought, and then I'm going to go to S3 and I'll show you what I've done in S3. So I've created a bucket name called as DNS name. Let me clear the content in them. So I've created a bucket, and then permissions, I've turned off public access blocking, and then I've created a bucket policy. So this bucket is now publicly accessible. And then I went on to properties and created the static website hosting. Right? And I've pointed that this is the file, that's my index file that I'm going to put, or name of the file that's going to be my index file that I'm going to put in this S3 bucket. So I've put the index file.html, saved it, and we're going to create a file now. We're going to create an index file. So this is a sample code. It says Amazon Route 53 getting started, routing internet traffic to S3 bucket for your website, and then a couple of other information. So I've saved it as an index.html file in my desktop. So let me upload that from my desktop into this bucket. So that's index.html, and it's in capital I. So let me go to properties and go to static website hosting and make sure that I spell it properly, right? It's case sensitive, and then save it. So now this means that my website should be running through this URL, and it does. It's running through the static website URL. We're halfway through. So now let me go back to Route 53. Go back to Route 53, go back to hosted zones, go into the domain name, and then create a record set. And it's going to be an alias record. And I see my S3 static website endpoint there. Right, so click on it and create. It has now created an record that's pointing my domain name to the S3 endpoint that I have created, and my static website is running from it. So let me test it. Right, so let me go to the browser, put the domain name in there, and sure enough, the domain name, when my browser queried for the domain name, Route 53 returned a response saying this domain name is actually mapped to the S3 bucket, static website hosting enabled S3 bucket, and this is the URL for that static website hosting. And then my browser was able to connect to that S3 bucket and download the details and show it in my browser. Right, so it's that simple.
Hi guys, this is Akhil, and today we are going to discuss about Amazon Redshift, which is one of the data warehouse service on the AWS. But before starting up with the Amazon Redshift, I would request you guys to subscribe our channel. You can find the link just below this video at the right side. So let's begin with Amazon Redshift, and let's see what we have for today's session. So what's in it for you today? We'll see what is AWS, why we require Amazon Redshift. What do we mean by Amazon Redshift? The advantages of Amazon Redshift, the architecture of Amazon Redshift, some of the additional concepts associated with the Redshift, and the companies that are using the Amazon Redshift. And finally, we'll cover up one demo which will show you the practical example that how you can actually use the Redshift service. Now, what is AWS? As we know that AWS stands for Amazon Web Service. It's one of the largest cloud providers in the market, and it's basically a secure cloud service platform provided from the Amazon. Also, on the AWS, you can create and deploy the applications using the AWS service. Along with that, you can access the services provided by the AWS over the public network, that is, over the internet. They are accessible. Plus, you pay only whatever the service you use for. Now let's understand why we require Amazon Redshift. So earlier, before Amazon Redshift, what used to happen that the people used to, or the developers used to fetch the data from the data warehouse. So data warehouse is basically a terminology which is basically represents the collection of the data. So a repository where the data is stored is generally called as a data warehouse. Now, fetching data from the data warehouse was a complicated task because might be a possibility that the developer is located at a different geography and the data warehouse is at a different location, and probably there is not that much network connectivity or some networking challenges, internet connectivity challenges, security challenges might be, and a lot of maintenance was required to manage the data warehouses. So what were the cons of the traditional data warehouse services? It was time consuming to download or get the data from the data warehouse. Maintenance cost was high, and there was the possibility of loss of information in between the downloading of the data, and the data rigidity was an issue. Now, how these problems could overcome, and this was basically solved with the introduction of Amazon Redshift over the cloud platform. Now, we say that Amazon Redshift has solved traditional data warehouse problems that the developers were facing, but how? What is Amazon Redshift actually is? So what is Amazon Redshift? It is one of the services over the AWS, Amazon Web Services, which is called as a data warehouse service. So Amazon Redshift is a cloud-based service or a data warehouse service that is primarily used for collecting and storing the large chunk of data. So it also helps you to get or extract the data, analyze the data using some of the BI tools. So business intelligence tools you can use and get the data from the Redshift and process that. And hence it simplifies the process of handling the large scale data sets. So this is the symbol for the Amazon Redshift over the AWS. Now let's discuss about one of the use case. So DNA is basically a telecommunication company, and they were facing an issue with managing their website and also the Amazon S3 data, which led down to slow process of their applications. Now, how could they overcome this problem? Let's see that. So they overcome this issue by using the Amazon Redshift, and all the company noticed that there was a 52% increase in the application performance. Now, did you know that Amazon Redshift is basically cost less to operate than any other cloud data warehouse service available on the cloud computing platforms? And also the performance of an Amazon Redshift is the fastest data warehouse, we can say that is available as of now. So in both cases, one is that it saves the cost as compared to the traditional data warehouses, and also the performance of this Redshift service or a data warehouse service, the fastest available on the cloud platforms. And more than 15,000 customers presently they are using the Amazon Redshift service. Now let's understand some of the advantages of Amazon Redshift. First of all, as we saw that it is one of the fastest available data warehouse service, so it has the high performance. Second is, it is a low cost service. So you can have a large scale of data warehouse or the databases combined in a data warehouse at a very low cost. So whatever you use, you pay for that only. Scalability. Now, in case if you wanted to increase the nodes of the databases in your Redshift, you can actually increase that based on your requirement, and that is on the fly. So you don't have to wait for the procurement of any kind of a hardware or the infrastructure. It is whenever you require, you can scale up or scale down the resources. So the scalability is again one of the advantage of the Amazon Redshift. Availability, since it's available across multiple availability zones, so it makes this service as a highly available service. Security. So whenever you access Redshift, you create a clusters in the Redshift, and the clusters are created you can define a specific virtual private cloud for your cluster, and you can create your own security groups and attach it to your cluster. So you can design the security parameters based on your requirement, and you can get your data warehouse or the data items in a secured place. Flexibility, and you can remove the clusters, you can create another clusters. If you are deleting a cluster, you can take a snapshot of it and you can move those snapshots to different regions. So that much flexibility is available on the AWS for the service. And the other advantage is that it is basically a very simple way to do a database migration. So if you're planning that you wanted to migrate your databases from the traditional data center over the cloud on the Redshift, it is basically very simple to do a database migration. You can have some of the inbuilt tools available on the AWS, you can connect them with your traditional data center and get that data migrated directly to the Redshift. Now let's understand the architecture of the Amazon Redshift. So architecture of an Amazon Redshift is basically it combines of a cluster, and that we call it as a data warehouse cluster. In this picture, you can see that this is a data warehouse cluster and this is a representation of a Amazon Redshift. So it has some of the compute nodes which does the data processing, and a leader node which gives the instructions to these compute nodes. And also the leader node basically manages the client applications that require the data from the Redshift. So let's understand about the components of the Redshift. The client application of Amazon Redshift basically interact with the leader node using JDBC or the ODBC. Now what is JDBC? It's a Java database connectivity, and the ODBC stands for Open Database Connectivity. The Amazon Redshift service using a JDBC connector can monitor the connections from the other client applications. So the leader node can actually have a check on the client applications using the JDBC connections. Whereas the ODBC allows a leader node to have a direct interaction or to have a live interaction with the Amazon Redshift. So ODBC allows a user to interact with live data of Amazon Redshift. So it has a direct connectivity, direct access of the applications, as well as the leader node can get the information from the compute nodes. Now, what are these compute nodes? These are basically kind of a databases which does the processing. So Amazon Redshift has a set of computing resources which we call it as a nodes, and the nodes, when they are combined together, they are called it as a clusters. Now, a cluster, a set of computing resources which are called as nodes, and this gathers into a group which we call it as a data warehouse cluster. So you can have a compute node starting from 1 to n number of nodes, and that's why we call that the Redshift is a scalable service, because we can scale up the compute nodes whenever we require. Now, the data warehouse cluster, or each cluster, has one or more databases in the form of a nodes. Now, what is a leader node? This node basically manages the interaction between the client application and the compute node. So it acts as a bridge between the client application and the compute nodes. Also, it analyzes and develops designs in order to carry out any kind of a database operations. So leader node basically sends out the instructions to the compute nodes, basically perform or execute that instruction and give that output to the leader node. So that is what we are going to see in the next slide, that the leader node runs the program and assign the code to individual compute nodes, and the compute nodes execute the program and share the result back to the leader node for the final aggregation, and then it is delivered to the client application for analytics or whatever the client application is created for. So compute nodes are basically categorized into slices, and each node slice is allotted with specific memory space, or you can say a storage space, where the data is processed. These node slices works in parallel in order to finish their work, and hence when we talk about a Redshift as a faster processing capability as compared to other data warehouses or traditional data warehouses, this is because that these node slices work in a parallel operation that makes it more faster. Now, the additional concept associated with Amazon Redshift is there are two additional concepts associated with the Redshift. One is called as the column storage and the other one is called as the compression. Let's see what is the column storage. As the name suggests, column storage is basically kind of a data storage in the form of a column, so that whenever we run a query, it becomes easier to pull out the data from the columns. So column storage is an essential factor in optimizing query performance and resulting in quicker output. So one of the examples are mentioned here. So below example show how database tables store record into disk block by row. So here you can see that if we wanted to pull out some kind of an information based on the city, address, age, we can basically create a filter, and from there we can put out the details that we require, and that is going to fetch out the details based on the column storage. So that makes data more structured, more streamlined, and it becomes very easier to run a query and get that output. Now the compression is basically to save the column storage, we can use a compression as an attribute. So compression is a column level operation which decreases the storage requirement, and hence it improves the query performance. And this is one of the syntax for the column compression. Now the companies that are using Amazon Redshift, one is LYA, the other one is Equinox, the third one is the Pfizer, which is one of the famous pharmaceuticals company, McDonald's, one of the burger chains across the globe, and Philips, it's an electronic company. So these are one of the biggest companies that are basically relying and they are putting their data on the Redshift data warehouse service. Now in another video, we'll see the demo for using the Amazon Redshift. Let's look into the Amazon Redshift demo. So these are the steps that we need to follow for creating the Amazon Redshift cluster. And in this demo, what we'll be doing is that we'll be creating an IAM role for the Redshift so that the Redshift can call the services, and specifically we'll be using the S3 service. So the role that we'll be creating, we'll be giving the permission to Redshift to have an access of an S3 in the read-only format. So in the step one, what we require, we'll check the prerequisites, and what you need to have is the AWS credentials. If you don't have that, you need to create your own credentials, and you can use your credit and the debit card. And then in the step two, we'll proceed with the IAM role for the Amazon Redshift. Once the role is created, we'll launch a sample Amazon Redshift cluster mentioned in the step 3, and then we'll assign a VPC security groups to our cluster. Now you can create it in the default VPC also, you can create a default security groups also, otherwise you can customize the security groups based on your requirement. Now to connect to the sample cluster, you need to run the queries. And you can connect to your cluster and run queries on the AWS Management Console query editor, which you will find it in the Redshift only. Or if you use the query editor, you don't have to download and set up a SQL client application separately. And in the step 6, what you can do is you can copy the data from the S3 and upload that in the Redshift, because the Redshift would have an access, a read-only access for the S3, as that will be created in the IAM role. So let's see how we can actually use the Redshift on the AWS. So I am already logged in into my account. I am in North Virginia region. I'll search for Redshift service, and here I find Amazon Redshift. So just click on it. Let's wait for the Redshift to come. Now this is a Redshift dashboard, and from here itself you have to run the cluster. So to launch a cluster, you just have to click on this launch cluster, and once the cluster is created, and if you wanted to run queries, you can open query editor, or you can basically create queries and access the data from the Redshift. So that's what it was mentioned in the steps also, that you don't require a separate SQL client application to get the queries run on the data warehouse. Now, before creating a cluster, we need to create the role. So what we'll do is we'll click on the services and we'll move to IAM role section. So IAM role I can find here under the security, identity and compliance. So just click on the identity access management and then click on create roles. So let's wait for IAM page to open. So here in the IAM dashboard, you just have to click on the roles. I already have the role created. So what I'll do is I'll delete this role and I'll create it separately. So just click on a create role, and under the AWS services, you have to select for the Redshift, because now the Redshift will be calling the other services, and that's why we are creating the role. Now, which other services that the Redshift will be having an access of? S3. Why? Because we'll be putting up the data on the S3, and that is something which needs to be uploaded on the Redshift. So we'll just search for the Redshift service, and we can find it here. So just click on it and then click on Redshift customizable in the use case. Now click on next permissions, and here in the permissions, give the access to this role, assign the permissions to this role in the form of an S3 read-only access. So you can search here for the S3 also. Let's wait for the policies to come in. Here it is. Let's type S3. And here we can find Amazon S3 read-only access. So just click on it and assign the permissions to this role. Tags, you can leave them blank. Click on next review. Put a name to your role. Let's put my Redshift role and click on a create role. Now you can see that your role has been created. Now the next step is that we'll move to Redshift service and we'll create one cluster. So click on the services. Click on Amazon Redshift. You can find that in the history section since we browsed it just now. And from here, we are going to create a sample cluster. Now to launch a cluster, you just have to click on launch this cluster. Whatever the uncompressed data size you want in the form of a gigabyte, terabyte or petabyte, you can select that. And let's say if you select in the form of GB, how much GB memory you want, you can define it here itself. This also gives you the information about the costing. On demand is basically pay as you use. So they are going to charge you $0.5 per hour for using the 2-node slices. So let's click on launch this cluster, and this will be a dc2.large kind of an instance that will be given to you. It would be in the form of a solid state drive, SSDs, which is one of the fastest way of storing the information. And the nodes 2 are mentioned by default. That means there will be 2 node slices that will be created in a cluster. You can increase them also. Let's say if I put 3 node slices, so it is going to give us 3 into 0.16 TB per node storage. Now here you have to define the master username password for your Redshift cluster, and you have to follow the password instructions. So I would put a password to this cluster, and if it accepts, that means it does not give you any kind of a warning. Otherwise it is going to tell you about you have to use the ASCII characters and all. And here you have to assign this cluster the role that we created recently. So in the available IAM roles, you just have to click on my Redshift role, and then you have to launch the cluster. If you wanted to change something with respect to the default settings, let's say if you wanted to change the VPC from default VPC to your custom VPC, and you wanted to change the default security groups to your own security groups, so you can switch to advanced settings and do that modification. Now let's launch the cluster, and here you can see the Redshift cluster is being created. Now if you wanted to run queries on this Redshift cluster, so you don't require a separate SQL client, you just have to follow the simple steps to run a query editor. and the query editor, you will find it on the dashboard. So let's click on the cluster, and here you would see that the Redshift cluster would be created with the 3 nodes in the US East 1B availability zone. So we have created the Redshift cluster in the Ohio region, and now what we'll do is we'll see how we can create the tables inside the Redshift, and we'll see how we can use the copy command so that we can directly move the data uploaded on the S3 bucket to the Redshift database tables. And then we'll query the results of a table as well. So how we can do that? First of all, after creating the Redshift cluster, we have to install SQL Workbench /J. This is not a MySQL, which is managed by Oracle, and you can find this on the Google. You can download it from there. And then you have to connect this client with the Redshift database. How you can do? Click on File, click on Connect Window, and after connecting a window, you have to paste the URL, which is a JDBC driver. This driver link, you can find it onto the AWS console. So if you open up a Redshift cluster, there you would find the JDBC driver link. Let's wait for it. So this is our cluster created. Let's open it. And here you can find this JDBC URL. And also make sure that in the security groups of a Redshift, you have the port 5439 open for the traffic, incoming traffic. You also need to have the Amazon Redshift driver, and this is the link where you can download the driver and specify the path. Once you are done with that, you provide the username and the password that you created while creating the Redshift cluster. Click on OK. So this connects with the database, and now the database connection is almost completed. Now what we will be doing in the SQL Workbench, we'll be first creating the sales table, and then in the sales table we'll be adding up the entries copied from the S3 bucket and then move it to the Redshift database, and after that we'll query the results in the sales table. Now whatever the values you are creating in the table, the same values needs to be in the data file, and I have taken up this sample data file from this link, which is docs.aws.amazon.com Redshift sample database creation. And here you can find a download file, ticketdb.zip file. This folder has basically multiple data files, sample data files, which you can actually use it to practice uploading the data on the Redshift cluster. So I have extracted one of the files from this folder, and then I have uploaded that file in the S3 bucket. Now we'll move into the S3 bucket. Let's look for the file that has been uploaded on the S3 bucket. So this is the bucket sample, and sales_tab.txt is the file that I have uploaded. This has the entries, data entries that will be uploaded using a copy command onto the Redshift cluster. Now after putting up the command for creating up the table, then we'll use a copy command, and copy command, we have to define the table name. The table name is sales, and we have to define the path from where the data would be copied over to the sales table in the Redshift. Now path is the S3 bucket, and this is the Redshift bucket sample, and it has to look for the data inside the sales_tab.txt file. Also, we have to define the role ARN that was created previously, and once it is done, then the third step is to query the results inside the sales table to check whether our data has been uploaded correctly on the table or not. Now what we'll do is we'll execute all these three syntax. It gives us the error because we have to connect it again to the database. Let's wait for it. Execute it. It again gives us the error. Let's look into the name of the bucket. It's Redshift bucket sample. So we have 2 T's mentioned here. Right. Let's connect with the database again and now execute it. So table sales created, and we got the error. The specified bucket does not exist. Redshift bucket sample. Let's view the bucket name, Redshift bucket sample. Let's copy that, put it here, connect to the window, connect back to the database. Right, and now execute it. So table sales created. The data in the table has been copied from the S3 bucket to sales_tab.txt to the Redshift, and then the query of the results. The results from the.
In this section, we're going to take a look at Amazon DynamoDB. Amazon DynamoDB is a fast, flexible NoSQL database service for all applications that need consistent single-digit millisecond latency at any scale. So basically, it's a fully managed NoSQL database that's suitable for document and key value store models. It's perfect for mobile, web, gaming, ad tech, etc. Let's take a look at some of the benefits of DynamoDB. Firstly, it's always stored on SSD storage, so you get great disk throughput. It's also spread across 3 geographically distinct data centers, so you get high availability built in. It's fast and flexible, and it's suited for read-heavy applications. And it's worth remembering that, because you might see questions saying, I have a read-intensive application with a database, what should I use? And DynamoDB would be the answer. DynamoDB offers 2 different read consistency types. The first is eventually consistent reads, which is the default, and then there's strongly consistent reads. So what does this mean? Well, when you write something to your DynamoDB, the changes have to be replicated to the 3 geographically distinct data centers on which DynamoDB is being stored. And obviously this isn't instant. I mean, it takes a couple of seconds or less, but it takes some time. So you can choose your read consistency depending on whether you want users to be guaranteed to have the correct data, or whether on occasions when they run a query they might not get the latest up-to-date version. Eventually consistent reads, which is the default, means that consistency is usually reached within 1 second, and repeating a read after a short time should return the correct data, and it gives the best read performance. But there is the danger of something called dirty reads, which is where you might request a read and you might not get the latest up-to-date data. If it's essential that your application gets the latest and correct data, then you can enable strongly consistent reads, and this guarantees that all writes have committed prior to the read taking place, so it could result in a delay to your results being returned. DynamoDB is charged using something called provisioned throughput capacity. When you create a DynamoDB table, you define the capacity that you want to reserve for reads and writes. For write throughput, there's a charge per hour for every 10 units of write capacity, and this equates to 36,000 writes per hour. For read throughput, there's a charge per hour for every 50 units of read capacity, and this equates to 180,000 strongly consistent reads or 360,000 eventually consistent reads. What this shows is that DynamoDB can be expensive for writes, but cheap for reads. So if your application has lots of reads, little writes, and wants to be scalable, then you should be looking at DynamoDB rather than RDS. There's also a storage cost per gigabyte for the amount of data you use with DynamoDB. And here's a very brief real-life case study. Duolingo, the online language learning site, uses DynamoDB to store 31 billion items for their online learning site, and they deliver lessons in 80 different languages. And their application hits 24,000 read units per second and 3,300 write units per second. So you can see this is a very read-heavy application and is perfect for DynamoDB. In this demonstration, we're going to take a very quick look at DynamoDB. So we go to the database section and we'll find DynamoDB, which is the managed NoSQL database provided by AWS. So we'll click on that. We're taken to the dashboard. I have no DynamoDB tables, so we need to create a new table. And we need to give it a name. So let's call this Simplilearn _users. That's going to be the name of our table. And we have to give it a key. So a primary key. So I'm going to put in last name, as that's going to be the primary key for this particular table, and that's going to be a string. Now down here we have table settings, so we can use the default settings, and it says no secondary indexes. Its provision capacity is set to 5 reads and 5 writes, and has basic alarms with 80% upper thresholds. So if one of your read or write capacities is greater than 80% of what you've set, then you'll get an alert. So if we untick this, you can see we're not going to take a look at secondary indexes, but the thing that's important is here we can change to read and write capacity units. So if we set it both to 1, we'll get an estimated cost of just 59 cents a month there. Conversely, if we push this way up, let's push it up to 1,000, then you see it's $580 a month. So it's fully scalable and you just sort of pay for what you need. So let's just set this to 1 and 1 because this is just a demonstration. And we'll click on Create Table. Okay, so the table has been created. Okay, so our table has been created. So here we can see the details of it and its creation date. So what we now need to do is we can add items to our table. So we click on the Items tab. Okay, and we need to create an item. So you see, this should look familiar to you because we're basically doing JSON code, which is the same as for the policies in the IAM lesson. So we get to stick in a last name. So let's put me in. So we'll stick Weaver, and then we can add more values. So append, let's append a string, and we'll put a first name, and we'll put my name in there. And we could put more information if we wanted, but we're just going to leave it as that. So we click on Save, and there we are. So now I'm in there. So I'll click on Create Item, and let's add a new user in here. So we'll call the last name Smith. Let's add another string. So we'll have a new field called first name. And we'll call this person Wendy. And we'll add another row. Let's put a string in there and we'll call this position. So this shows what you can do with NoSQL. You can basically just keep changing things and each row can be different. So we've entered the position of manager and we'll click save. So now we can see that it's different. So you can do whatever you want, basically. You can add as much or as little information to each row as you wanted. Now you can also do a search. So if we wanted to add a filter, we could say search for last name with a string that equals, and there we are. So we have Weaver Mark. And just to clear that, we just remove that and click on Start Search again. So that gives you a very basic overview of what you can do with NoSQL. It's unstructured data and you can add as much or as little as you want. Some other things to look at, the Metrics tab. Here you can see your read and write capacity, what's actually happening. So you can see whether you're paying too much or if you need to be paying too much more. There's the alarms that we talked about, so they were set up for us. Some basic alarms if the threshold goes over 0.08 reads or writes for a 12-minute period, we'll get notified. And here's the capacity. So this is the thing that you'll see in the exam, is that DynamoDB, you can just change your capacity and as and when you want on the fly. So our table's up and running, but we could just say we want 5 read capacity units and 5 write capacity units, click save, and we're done. It's up and running straight away. And if you knew how much you wanted and you had a table that you were going to be using for a prolonged period, like a couple of years, you can click on Reserve Capacity on the left-hand side, and you can purchase Reserve Capacity, and you'll get some significant discounts by doing that. So if you know you have a table that's going to have some heavy reads and writes going forward, you would purchase Reserve Capacity. Okay, so that's a very basic overview of DynamoDB. You just need to remember that it's instantly scalable, and it's a NoSQL database.
Hi guys, I'm Rahul from Simplilearn, and today I'd like to welcome you all to the greatest debate of the century. Today, I'm joined by two giants of the cloud computing industry. They'll be going head to head with each other to decide who amongst them is better. It's going to be one hell of a fight. Now, let's meet our candidates. On my left, we have AWS, who's voiced by Apeksha.
Hi guys.
And on my right, we have Microsoft Azure, who's voiced by Anjali.
Hey there.
So today, we'll be deciding who's better on the basis of their origin and the features they provide, their performance in the present day, and comparing them on the basis of pricing, market share and options, free tier, and instance configuration. Now, let's listen to their opening statements. Let's start with AWS.
Launched in 2006, AWS is one of the most commonly used cloud computing platforms across the world. Companies like Adobe, Netflix, Airbnb, HTC, Pinterest, and Spotify have put their faith in AWS for their proper functioning. It also dominates the cloud computing domain with almost 40% of the entire market share. So far, nobody's even gotten close to beating that number. AWS also provides a wide range of services that covers a great number of domains. Domains like compute, networking, storage, migration, and so much more.
Now, let's see what Azure has to say about that.
Azure was launched in 2010 and is trusted by almost 80% of all Fortune 500 companies. The best of the best companies in the world choose to work only with Azure. Azure also provides its services to more regions than any other cloud service provider in the world. Azure covers 42 regions already, and 12 more are being planned to be made. Azure also provides more than 100 services spanning a variety of domains.
Now that the opening statements are done, let's have a look at the current market status of each of our competitors. This is the performance round. Here we have the stats for the market share of AWS, Azure, and other cloud service providers. This is for the early 2018 period. Amazon Web Services takes up a whopping 40% of the market share, closely followed by Azure at 30% and other cloud services adding 30%.
This 40% indicates most organizations' clear interest in using AWS. We are number one because of our years of experience and trust we've created among our users.
Sure, you're the market leader, but we are not very far behind. Let me remind you, more than 80% of the Fortune 500 companies trust Azure with their cloud computing needs. So it's only a matter of time before Azure takes the lead.
The rest of the 30% that is in AWS or Azure accounts to the other cloud service providers like Google Cloud Platform, Rackspace, IBM SoftLayer, and so on. Now for our next round, the comparison round. First, we'll be comparing pricing. We'll be looking at the cost of a very basic instance, which is a virtual machine of 2 virtual CPUs and 8 GBs of RAM. For AWS, this will cost you approximately $0.0928 per hour. And for the same instance in Azure, it'll cost you approximately $0.096 per hour. Next up, let's compare market share and options.
As I mentioned before, AWS is the undisputed market leader when it comes to the cloud computing domain, taking up 40% of the market share. By 2020, AWS is also expected to produce twice its current revenue, which comes close to $44 billion. Not to mention, AWS is constantly expanding its already strong roster of more than 100 services to fulfill the shifting business requirements of organizations.
All that is great, really, good for you. But the research company Gartner has released a magic quadrant that you have to see. You see, the competition is now neck to neck between Azure and AWS. It's only a matter of time before Azure can increase from its 30% market share and surpass AWS. This becomes more likely considering how all companies are migrating from AWS to Azure to help satisfy their business needs. Azure is not far behind AWS when this comes to services as well. Azure's service offerings are constantly updated and improved on to help users satisfy their cloud computing requirements.
Now, let's compare AWS and Azure's free offerings.
AWS provides a significant number of its services for free, helping users get hands-on experience with the platform, products, and services. The free tier services fall under 2 categories: services that will remain free forever and the others that are valid only for 1 year. The always free category offers more than 20 services, for example Amazon SNS, SQS, CloudWatch, etc. And the valid for a year category offers approximately 20 services, for example Amazon S3, EC2, Elasticache, etc. Both types of services have limits on their usage, for example storage, number of requests, compute time, etc. But users are only charged for using services that fall under the valid for a year category after a year of their usage.
Azure provides a free tier as well. It also provides services that belong to the categories of free for a year and always free. There are about 25 plus always free services provided by Azure. These include App Service, Functions, Container Service, Active Directory, and lots more. And as of the valid for a year, there are 8 services offered. There's Linux or Windows virtual machines, blob storage, SQL database, and few more. Azure also provides the users with credits of $200 to access all their services for 30 days. Now this is a unique feature that Azure provides, where its users can use their credits to utilize any service of a choice for the entire month.
Now let's compare instance configuration. The largest instance that AWS offers is that of a whopping 256 GBs of RAM and 16 virtual CPUs. The largest that Azure offers isn't very far behind either, 224 GBs of RAM and 16 virtual CPUs. And now for the final round. Now each of our contestants will be shown facts and they have to give explanations for these facts. We call it the rapid fire round. First, we have features in which AWS is good and Azure is better.
AWS does not cut down on the features it offers its users. However, it requires slightly more management on the user's part.
Azure goes slightly deeper with the services that fall under certain categories like platform as a service and infrastructure as a service.
Next, we have hybrid cloud, where AWS is good and Azure is better.
Okay, although AWS did not emphasize on hybrid cloud earlier, they are focusing more on technology now.
Azure has always emphasized on hybrid cloud and has features supporting it since the days of its inception.
For developers, AWS is better and Azure is good.
Of course it's better, because AWS supports integration with third-party applications.
Well, Azure provides access to data centers that provide a scalable architecture.
For pricing, both AWS and Azure are at the same level.
It's good for AWS because it provides a competitive and constantly decreasing pricing model.
And in the case of Azure, it provides offers that are constantly experimented upon to provide its users with the best experience.
And that's it. Our contestants have finished giving their statements. Now, let's see who won. Surprisingly, nobody. Each cloud computing platform has its own pros and cons. Choosing the right one is based entirely on your organization. Hi guys, today we've got something very special in store for you. We're going to talk about the best cloud computing platform available, Amazon Web Services.
Rahul, I think you said something wrong here. The best cloud computing platform is obviously Google Cloud Platform.
No, it isn't. AWS has more than 100 services that span a variety of domains.
Alright, but Google Cloud Platform has cheaper instances. What do you have to say about that?
Well, I guess there's only one place we can actually discuss this. A boxing ring.
So guys, I'm Apeksha and I will be Google Cloud Platform.
And I'm Rahul, I'll be AWS.
So welcome to Fight Night.
This is AWS versus GCP. The winner will be chosen on the basis of their origin and the features they provide, their performance in the present day, and comparing them on the basis of pricing, market share and options, the things they give you for free, and instance configuration. Now first let's talk about AWS. AWS was launched in 2004 and is a cloud service platform that helps businesses grow and scale by providing them services in a number of different domains. These domains include compute, database, storage, migration, networking, and so on. A very important aspect about AWS is its years of experience. Now, AWS has been in the market a lot longer than any other cloud service platform, which means they know how businesses work and how they can contribute to the business growing. Also, AWS has over $5.1 billion of revenue in the last quarter. This is a clear indication of how much faith and trust people have in AWS. They occupy more than 40% of the market, which is a significant chunk of the cloud computing market. They have at least 100 services that are available at the moment, which means just about every issue that you have can be solved with an AWS service.
Now that was great, but now can we talk about GCP? I hope you know that GCP was launched very recently in 2011 and it is already helping businesses significantly with a suite of intelligent, secure and flexible cloud computing services. It lets you build, deploy and scale applications, websites, services on the same infrastructure as Google. The intuitive user experience that GCP provides with dashboards, wizards is way better in all the aspects. GCP has just stepped in the market and it is already offering a modest number of services. And the number is rapidly increasing. And the cost for a CPU instance or regional storage that GCP provides is a whole lot cheaper. And you also get a multi-regional cloud storage. Now what do you have to say on that?
I'm so glad you asked. Let's look at present day. In fact, let's look at the cloud market share of the fourth quarter of 2017. This will tell you once and for all that AWS is the leader when it comes to cloud computing. Amazon Web Services contributes 47% of the market share. Others like Rackspace or Verizon Cloud contribute 36%, Microsoft Azure contributes 10%, the Google Cloud Platform contributes 4%, and IBM Software contributes 3%. 47% of the market share is contributed by AWS. Do you need me to convince you any more?
Wait. All that is fine, but we only started a few years back and have already grown so much in such a less span of time. Haven't you heard the latest news? Our revenue is already $1 billion per quarter. Wait for a few more years and the world shall see.
And AWS makes $5.3 billion per quarter. It's going to take a good long time before you can even get close to us.
Yes, we'll see.
Now, let's compare a few things. For starters, let's compare pricing. For AWS, a compute instance of 2 CPUs and 8 GB RAM costs approximately $68. Now, a compute instance is a virtual machine in which you can specify what operating system, RAM, or storage you want to have. For cloud storage, it costs 2.3 cents per GB per month with AWS.
You really want to do that? Because GCP wins this hands down. Let's take the same compute instance of 2 CPUs with 8 GB RAM. It will cost approximately $50 per month with GCP. And as per my calculations, that's a 25% annual cost reduction when compared to AWS. Talking about cloud storage costs, it is only 2 cents per GB per month with GCP. What else do you want me to say?
Let's talk about market share and options. Now, AWS is the current market leader when it comes to cloud computing. Now, as you remember, we contribute at least 47% of the entire market share. AWS also has at least 100 services available at the moment, which is a clear indication of how well AWS understands businesses and helps them grow.
Yeah, that's true, but you should also know that GCP is steadily growing. We have over 60 services that are up and running, as you can see here, and a lot more to come. It's only a matter of time when we will have as many services as you do. Many companies have already started adopting GCP as their cloud service provider.
Now, let's talk about things you get for free. With AWS, you get access to almost all the services for an entire year with usage limits. Now, these limits include an hourly or by-the-minute basis. For example, with Amazon EC2, you get 750 hours per month. You also have limits on the number of requests to services. For example, with AWS Lambda, you have 1 million requests per month. Now, after these limits are crossed, you get charged standard rates.
With GCP, you get access to all cloud platform products like Firebase, the Google Maps API, and so on. You also get $300 in credit to spend over a 12-month period on all the cloud platform products. And interestingly, after the free trial ends, you won't be charged unless you manually upgrade to a paid account. Now, there is also the always free version for which you will need an upgraded billing account. Here, you get to use a small instance for free and 5 GB of cloud storage. Any usage above this always free usage limits will be automatically billed at standard rates.
Now let's talk about how you can configure instances. With AWS, the largest instance that's offered is of 128 CPUs and 4 TBs of RAM. Now, other than the on-demand method, like I mentioned before, you can also use spot instances. Now, these are for situations where your application is more fault tolerant and can handle an interruption. Now, you pay for the spot price, which is effective at a particular hour. Now, these spot prices do fluctuate, but are adjusted over a period of time.
The largest instance offered with Google Cloud is 160 CPUs and 3.75 TBs RAM. Like spot instances of AWS, Google Cloud offers short-lived compute instances suitable for batch jobs and fault-tolerant workloads. They are called as preemptible instances. So these instances are available at 80% off on-demand price. Hence, they reduce your compute engine costs significantly. And unlike AWS, these come at a fixed price. Google Cloud Platform is a lot more flexible when it comes to instance configuration. You simply choose your CPU and RAM combination. Of course, you can even create your own instance types this way. Before we wrap it up, let's compare on some other things as well. Telemetry. It's a process of automatically collecting periodic measurements from remote devices. For example, GPS. GCP is obviously better because they have superior telemetry tools which help in analyzing services and providing more opportunities for improvement.
When it comes to application support, AWS is obviously better since they have years of experience under their belt. AWS provides the best support that can be given to the customers.
Containers are better with GCP. A container is a virtual process running in user space. As Kubernetes was originally developed by Google, GCP has full native support for the tool. Other cloud services are just fine-tuning a way to provide Kubernetes as a service. Also, the containers help with abstracting applications from their environment they originally run in. The applications can be deployed easily regardless of their environment.
When it comes to geographies, AWS is better since they have a head start of a few years. AWS in this span of time has been able to cover a larger market share and geographical locations. Now, it's time for the big decision. So, who's it going to be?
Yeah, who is it going to be? GCP or AWS?
I think I'm going to go for choosing the right cloud computing platform is a decision that's made on the basis of the user or the organization's requirement. On that note, I believe it's time for us to wrap this video up.
We hope you guys enjoyed this video and learned something new.
That AWS is better, right?
No, that choosing a platform entirely depends on you and your organization's requirement. If you're interested, you could also go through the AWS versus Azure video. Thank you for watching.
AWS, Azure and GCP are three of the world's largest cloud service providers. But how are they different from each other? Let's find out. Hey guys, I'm Rahul and I'll be representing Amazon Web Services.
I'm Chinmayi and I'll be representing Microsoft Azure.
And I'm Shruti and I'll be representing Google Cloud Platform. So welcome to this video on AWS versus Azure versus GCP.
Talking about market share, Amazon Web Services leads with around 32% of the worldwide public cloud share.
Azure owns up to 16% of the worldwide market share.
And GCP owns around 9% of the world's market share.
Let's talk about each of these service providers in detail. AWS provides services that enable users to create and deploy applications over the cloud. These services are accessible via the internet. AWS, being the oldest of the lot, was launched in the year 2006.
Azure, launched in 2010, is a computing platform that offers a wide range of services to build, manage and deploy applications on the network using tools and frameworks.
Launched in the year 2008, GCP offers application development and integration services for its end users. In addition to cloud management, it also offers services for big data, machine learning and IoT.
Now let's talk about availability zones. These are isolated locations within data center regions from which public cloud services originate and operate. Talking about AWS, they have 69 availability zones within 22 geographical regions. This includes regions in the United States, South America, Europe, and Asia Pacific. They are also predicted to have 12 more additions in the future.
Azure, available in 140 countries, has over 54 regions worldwide grouped into 6 geographies. These geographical locations have more than 100 data centers.
GCP is available in 200 plus countries across the world. As of today, GCP is present in 61 zones and 20 regions, with Osaka and Zurich being the newly added regions.
Now let's talk about pricing. These services follow the pay-as-you-go approach. You pay only for the individual services you need for as long as you use them without requiring long-term contracts or complex licensing. Now on screen, you can see the pricing for each of these cloud service providers with respect to various instances like general purpose, compute optimized, memory optimized, and GPU. Now let's talk about the compute services offered. First off, we have virtual servers. For AWS, we have EC2. It is a web service which eliminates the need to invest in hardware so that you can develop and deploy applications in a faster manner. It provides virtual machines in which you can run your applications.
Azure's virtual machines is one of the several types of computing resources that Azure offers. Azure gives the user the flexibility to deploy and manage a virtual environment inside a virtual network.
GCP's VM service enables users to build, deploy, and manage virtual machines to run workloads on the cloud.
Now let's talk about the pricing of each of these services. AWS EC2 is free to try. It is packaged as part of AWS's free tier that lasts for 12 months and provides 750 hours per month of both Linux and Windows virtual machines.
Azure Virtual Machine Service is a part of the free tier that offers this service for about 750 hours per month for a year. The user gets access to Windows and Linux virtual machines.
GCP's VM service is a part of a free tier that includes micro-instance per month for up to 12 months.
Now let's talk about Platform as a Service or PaaS services. For AWS, Elastic Beanstalk is an easy-to-use service for deploying and scaling web applications and services developed with Java, .NET, Node.js, Python, and much more. It is used for maintaining capacity, provisioning, load balancing, auto-scaling, and application health monitoring.
The PaaS backbone utilizes virtualization techniques where the virtual machine is independent of the actual hardware that hosts it. Hence, the user can write application code without worrying about the underlying hardware.
Google App Engine is a cloud computing platform as a service which is used by developers for hosting and building apps in Google data centers. The App Engine requires the apps to be written in Java or Python and store data in Google Bigtable and use the Google query language for this.
Next, let's talk about virtual private server services. AWS provides Lightsail. It provides everything you need to build an application or a website along with the cost-effective monthly plan and minimum number of configurations.
In simple words, VM image is a more comprehensive image for Microsoft Azure virtual machines. It helps the user create many identical virtual machines in a matter of minutes.
Unfortunately, GCP does not offer any similar service.
Next up, we have serverless computing services. AWS has Lambda. It is a serverless compute service that lets you run your code without facilitating and managing servers. You only pay for the compute time you use. It is used to execute backend code and scales automatically when required.
Azure Functions is a serverless compute service that lets you run event-triggered code without having to explicitly provision or manage infrastructure. This allows the users to build applications using serverless simple functions with the programming language of their choice.
GCP Cloud Functions make it easy for developers to run and scale code in the cloud and build event-driven serverless applications. It is highly available and fault-tolerant.
Now let's talk about storage services offered by each of these service providers. First off, we have object storage. AWS provides S3. It is an object storage that provides industry standard scalability, data availability, and performance. It is extremely durable and can be used for storing as well as recovering information or data from anywhere over the internet.
Blob storage is an Azure feature that lets developers store unstructured data in Microsoft's cloud platform. Along with storage, it also offers scalability. It stores the data in the form of tiers depending on how often data is being accessed.
Google Cloud Storage is an online storage web service for storing and accessing data on Google Cloud Platform infrastructure. Unlike the Google Drive, Google Cloud Storage is more suitable for enterprises. It also stores objects that are organized into buckets.
Amazon provides EBS or Elastic Block Store. It provides high-performance block storage and is used along with EC2 instances for workloads that are transaction or throughput intensive.
Azure Managed Disk is a virtual hard disk. You can think of it like a physical disk in an on-premises server but virtualized. These managed disks allow the users to create up to 10,000 VM disks in a single subscription.
Persistent storage is a data storage device that retains data after power to the device is shut off. Google Persistent Disk is durable and high-performance block storage for GCP. Persistent Disk provides storage which can be attached to instances running in either Google Compute Engine or Kubernetes Engine.
Next up, we have disaster recovery services. AWS provides a cloud-based recovery service that ensures that your IT infrastructure and data are recovered while minimizing the amount of downtime that could be experienced.
Site recovery helps ensure business continuity by keeping business apps and workloads running during outages. It allows recovery by orchestrating and automating the replication process of Azure virtual machines between regions.
Unfortunately, GCP has no disaster recovery service.
Next, let's talk about database services. First off, for AWS, we have RDS or Relational Database Service. It is a web service that's cost-effective and automates administration tasks. Basically, it simplifies the setup, operation, and scaling of a relational database.
Microsoft Azure SQL Database is a software-as-a-service platform that includes built-in intelligence that learns app patterns and adapts to maximize performance, reliability, and data protection. It also eases the migration of SQL Server databases without changing the user's applications.
Cloud SQL is a fully managed database service which is easy to set up, maintain, and administer relational PostgreSQL, MySQL, and SQL Server databases in the cloud. Hosted on GCP, Cloud SQL provides a database infrastructure for applications running anywhere.
Next, we have NoSQL database services. AWS provides DynamoDB, which is a managed, durable database that provides security, backup and restore, and in-memory caching for applications. It is well known for its low latency and scalable performance.
Azure Cosmos DB is Microsoft's globally distributed multi-model database service. It natively supports NoSQL created for low latency and scalable applications.
GCP Cloud Data Store is a NoSQL database service offered by Google on the GCP. It handles replication and scales automatically to your application's load. With Cloud Data Store's interface, data can easily be accessed by any deployment target.
Now let's talk about the key cloud tools for each of these service providers. For AWS, in networking and content delivery, we have AWS Route 53 and AWS CloudFront. For management, we have AWS CloudWatch and AWS CloudFormation. For development, we have AWS CodeStar and AWS CodeBuild. For security, we have IAM and Key Management Service.
For Microsoft Azure, networking and content delivery, we have Content Delivery Network and ExpressRoute. For management tools, we have Azure Advisor and Network Watcher. For development tools, for management, we have Azure Advisor and Network Watcher. For development, we have Visual Studio IDE and Azure Blob Studio. For security, we have Azure Security Center and Azure Active Directory.
For GCP, we have the following tools. For networking and content delivery, we have Cloud CDN and Cloud DNS. For management, we have Stack Driver and GCP Monitoring. For development, we have Cloud Build and Cloud SDK. And finally, for security, we have Google Cloud IAM and Google and Cloud Security Scanner.
Now let's talk about the companies using these cloud providers. For AWS, we have Netflix, Unilever, Kellogg's, NASA, Nokia, and Adobe.
Pixar, Samsung, eBay, Fujitsu, EMC, and BMW, among others, use Microsoft Azure.
So as seen on your screens, the companies that use GCP are Spotify, HSBC, Snapchat, Twitter, PayPal, and 20th Century Fox.
Let's talk about the advantages of each of these services. Amazon provides enterprise-friendly services. You can leverage Amazon's 15 years of experience delivering large-scale global infrastructure, and it still continues to hone and innovate its infrastructure management skills and capabilities. Secondly, it provides instant access to resources. AWS is designed to allow application providers, ISVs, and vendors to quickly and securely host your applications, whether an existing application or a new SaaS-based application. Speed and agility. AWS provides you access to its services within minutes. All you need to select is what you require and you can proceed. You can access each of these applications anytime you need them. And finally, it's secure and reliable. Amazon enables you to innovate and scale your application in a secure environment. It secures and hardens your infrastructure. More importantly, it provides security at a cheaper cost than on-premise environments.
Now talking about some of the advantages of Azure. Microsoft Azure offers better development operations. It also provides strong security profile. Azure has a strong focus on security, following the standard security model of detect, assess, diagnose, stabilize, and close. Azure also provides a cost-effective solution. The cloud environment allows businesses to launch both customer applications and internal apps in the cloud, which saves on IT infrastructure costs. Hence, it's OpEx friendly.
Let's now look at the advantages of GCP. Google bills in minute-level increments, so you only pay for the compute time you use. They also provide discounted prices for long-running workloads. For example, you use the VM for a month and get a discount. GCP also provides live migration of virtual machines. Live migration is the process of moving a running VM from one physical server to another without disrupting its availability to the users. This is a very important differentiator for Google Cloud compared to other cloud providers. GCP provides automatic scalability. This allows a site's container scale to as many CPUs as needed. Google Cloud Storage is designed for 99.9% durability. It creates server backup and stores them in a user-configured location.
Let's talk about the disadvantages of each of these services. For AWS, there's a limitation of the EC2 service. AWS provides limitations on resources that vary from region to region. There may be a limit to the number of instances that can be created. However, you can request for these limits to be increased. Secondly, they have a technical support fee. AWS charges you for immediate support, and you can opt for any of these packages. Developer, which costs $29 per month, Business, which costs more than $100, and Enterprise, that costs more than $15,000. It has certain network connectivity issues. It also has general issues when you move to the cloud, like downtime, limited control, backup protection, and so on. However, most of these are temporary issues and can be handled over time.
Talking about some of the disadvantages of Microsoft Azure. Codebase is different when working offline, and it requires modification when working on the cloud. PaaS ecosystem is not as efficient as IaaS. Azure Management Console is frustrating to work with. It is slow to respond and update and requires far too many clicks to achieve simple tasks. Azure Backup is intended for backing up and restoring data located on your on-premises servers to the cloud. That's a great feature, but it's not really useful for doing bare metal restores of servers in a remote data center.
Let's now look into the disadvantages of GCP. So when it comes to cloud providers, the support fee is very minimal, but in the case of GCP, it is quite costly. It is around $150 per month for the most basic service. Similar to AWS S3, GCP has a complex pricing schema. Also, it is not very budget friendly when it comes to downloading data from Google Cloud Storage.
Hi there. Now that you've learnt about the products and services offered by AWS, let us talk about designing cloud architecture. Designing IT infrastructure for the cloud is completely different than for traditional on-premise data centers. Before the advent of cloud computing, planning your infrastructure involved making a series of estimates and educated guesses to determine the capacity requirements of your products and applications. This often resulted in serious over- or underestimations. With AWS, you get to rethink your approach to architecting an IT environment so you can take full advantage of cloud computing. This lesson covers how cloud has brought in an entirely new way to build IT environments and how one can achieve it using the AWS recommended best practices.
In this lesson, you'll learn why building cloud services requires a different mindset to that of traditional on-premise infrastructure. You'll be able to define the key points in the AWS well-architected framework and understand the 4 pillars that make up this framework. You'll learn about the key principles involved in planning and designing cloud infrastructure. You'll have an understanding of the tools available to enable AWS monitoring and logging. And you'll also have knowledge on the tools and functionality available to run hybrid cloud infrastructure. This is the How to Design Cloud Services section, where we'll take an overview of the AWS Cloud Design Principles. In the topic How to Design Cloud Services, we will take a look at the AWS well-architected framework. And we'll take a deeper look at the 4 pillars which make up the framework, and these are security, reliability, performance efficiency, and cost optimization. We'll then take a look at where you can find more information about designing cloud services for Amazon. And we will look at the AWS Quick Start reference deployments, and where you can find out real-life examples about how real businesses are using Amazon Web Services. So let's start by looking at the AWS well-architected framework. Now this was introduced because building cloud infrastructure services is vastly different to what you're used to with on-premise infrastructure. So AWS created this framework to help you understand the pros and cons of decisions you make while building systems on AWS. The AWS framework documents a set of foundation questions that allow you to understand if a specific architecture aligns well with cloud best practices. And there's 5 principles it helps you with. The first of which is stop guessing your capacity needs, test systems at production scale, lower the risk of architecture change, automate to make architecture experimentation easier, and allow for evolutionary architectures. And we'll take a look at each of these in greater detail. So firstly, let's take a look at stop guessing your capacity needs. Now imagine you're designing a brand new application for your business. All the infrastructure decisions you will make are made using estimates, which are basically guesses. If you overestimate, you might end up buying too much hardware and have a fleet of expensive idle resources. Conversely, you might underestimate and have to deal with the performance implications of limited capacity. With cloud computing, these problems go away, as AWS helps you eliminate the guesswork in your infrastructure capacity needs. You can use as much or as little capacity as you need and scale up and down automatically depending on your demand. The cloud allows you to test systems at production scale. Traditionally, in a non-cloud environment, it's usually very difficult to fully test new products or services in development, as it's cost prohibitive to have like-for-like environments, or you just don't have the resources available. Personally, I've lost count how many projects I've worked on when things have gone wrong as soon as the product's gone live due to insufficient testing. With the cloud, you can duplicate environments on demand, and when you've completed your testing, just shut them down, and you only have to pay for the time the test environment was up and running. So you can test fully before you go live in production. AWS allows you to lower the risk of architecture change, as you can automate the creation of test environments. So you can emulate your production configurations and carry out testing against comparable environments. You can also remove testing bottlenecks where various teams are lining up to use your test environments. As with AWS, you can cheaply spin up as many test environments as you need and ensure that all the production changes have been sufficiently tested. You can automate to make architecture experimentation easier. If you need to make a change to production but not sure what the impact will be, well, you can automate the creation and replication of your systems at low cost and low effort to test these changes. You can then audit the impact, and then, if necessary, you can revert the changes and try again. With AWS, you can allow for evolutionary architectures. In a traditional environment, architecture decisions are often implemented as a static, one-time event that you have to live with during the lifetime of a system. But with the cloud, the capability exists to automate and test on demand to lower the risk of design changes. so you can implement new innovations and features easily. What this means is you aren't stuck with last year's technology, and you can implement new technology as soon as it comes out. As mentioned earlier, the well-architected framework is based on 4 pillars: security, reliability, performance efficiency, and cost optimization. So in the coming slides, we're going to take a further look at these 4 pillars, starting with security. So Amazon defines security as the ability to protect information, systems, and assets while delivering businesses value through risk assessments and mitigation strategies. What this means is you can apply security at all layers. So rather than just running minimal security, like firewalls, at the edge of your infrastructure, you can use firewalls and other security controls on all of your resources. For example, security groups on EC2 instances allow you to define who and what can access that specific resource, rather than just defining it at a global infrastructure level. You can enable traceability, so you can log and audit all changes to your environment. You can automate responses to security events, so you can monitor and automatically trigger alerts depending on your needs. You can focus on sharing your system. The AWS Shared Responsibility model allows you to focus on securing your application, data, and operating systems, whilst AWS secures your infrastructure and services. And you can automate security best practices. AWS allows you to create and save a custom baseline image of a virtual server, and then you can use that image to automatically launch new servers. This way you can ensure that all new resources adhere to your security standards. So I just briefly mentioned the AWS Shared Responsibility model. Now we take a look at this in more depth in a later lesson. But what it means is that the AWS Shared Responsibility model allows AWS customers to focus on using services to accomplish their security and compliance goals, because AWS physically secures the infrastructure that supports your cloud services. So if you look at this diagram, you can see it split into 2. Security measures that the cloud service provider implements and operates is the security of the cloud, and that's the responsibility of AWS. Then there's the security measures that the customer implements and operates, and this is related to the security of customer content and applications that make use of the AWS services. And this is security in the cloud, and this is the responsibility of you. So let's take a look at security in the cloud, and this is composed of 4 areas: data protection, privilege management, infrastructure protection, and detective controls. Let's start with data protection. Before architecting any system, practices that ensure security should be in place. With data protection, these are categorizing data based on levels of sensitivity, granting least privilege while still allowing users to perform their work, and encryption to protect your sensitive data. If you're storing customer credit card data, obviously this needs to be categorized as sensitive and it needs to be encrypted. But log files from a daily maintenance task wouldn't need this level of security. Now there's a number of tools AWS offers to assist you with this. AWS makes it easy to encrypt data and manage keys and key rotation using IAM and Key Management Service. You can perform detailed logging using CloudTrail, and AWS offers resilient storage systems like Amazon S3, which has 11 nines of durability. Now 11 nines of durability means that if you store 10,000 objects with Amazon S3, on average you can expect to incur a loss of a single object once every 10 million years. So in other words, you're not going to lose many files. And finally, AWS offers versioning and lifecycle management, again with S3, so you can protect against accidental deletes or file overwrites. Now, a central part of any information security program is privilege management, so that you can ensure that only authorized and authenticated users are able to access your resources, and that they can only access them in a way that is acceptable. For example, if a user needs access to a resource, don't just give them admin or read-write permissions by default, because they might actually only need read-only access. Now, to control your privilege management, you need to have a few things in place. The first of which is an access control list, and this is a document that needs to be maintained which lists access permissions attached to an object. So if you have some particular documents, you need to define what access is allowed to it. Then you have role-based access controls, and this defines the permissions for a particular end user's role or function. So an administrator would obviously need administrator access to various resources, but a regular end user might only need read-only access. So you need to define which roles have which permissions. Then there's password management, and this includes complexity requirements and change intervals. So you define how often people need to change their passwords and how complex they need to be. Now Amazon helps you with all this with the Identity and Access Management, or IAM, service. And this is the primary service used to control access to AWS services and resources. We cover IAM in huge detail in a later lesson, but briefly, it allows you to apply granular policies which assign permissions to users, groups, roles or resources, and you can also control the password strength using this, as well as federation with your existing directory services, such as Microsoft Active Directory. You also need to protect your infrastructure, and to do this it's recommended to have multiple layers of defense and also multi-factor authentication to meet best practices with industry or regulatory obligations. Now, Amazon allows you to do this by implementing stateful or stateless packet inspection, either using AWS native technologies or by using partner products and services available through the AWS Marketplace. Amazon Virtual Cloud, VPC, enforces boundary protection and monitoring points of ingress and egress, and then there's CloudTrail and CloudWatch, which provides comprehensive logging, monitoring and alerting. You should always have detective controls in place so you can detect or identify security breaches. This needs to happen so you can provide both a quality support process and meet compliance obligation. And by a quality support process, I mean one in which when you have a problem, you're committed to finding out the root cause and actually resolving the issue rather than just saying, oh, we think it was that, let's hope it doesn't happen again. I mean, I know I've worked for some places like that, and it's certainly not a quality support process. AWS helps you with your detective controls by providing these services. AWS CloudTrail is a service that logs API calls, so you can find out the identity of callers, the time of calls, source IP addresses, and things like that, so you can find out who is doing what and when. Amazon CloudWatch is a monitoring service for AWS resources, so you can log EC2 CPU usage or network activity, and you can use CloudWatch with many different services like RDS, EBS and more. You can also set up alarms so you can be notified when certain things happen. AWS Config is an inventory and configuration history service that provides information about the configurations and changes in infrastructure over time. With Amazon S3, you can see data access auditing, so you can find out who's been accessing your S3 data and when they did it and when. And Amazon Glacier, you can use the Vault Lock feature to preserve mission-critical data with compliance controls that are designed to be auditable for long-term retention. The next pillar is reliability, and Amazon defines this as the ability of a system to recover from infrastructure or service failures, dynamically acquire computing resources to meet demand, and mitigate disruptions such as misconfigurations or transient network issues. With reliability in the cloud, there's a number of things to look at. Firstly, you can test recovery procedures. Cloud infrastructure means you can test how your system fails, and you can validate your recovery strategy. Places I've worked at in the past, disaster recovery was a big event. It was only done annually, it took months of preparation, it involved working a whole weekend and then some, and was also incredibly disruptive to the business. Imagine being able to duplicate your production environment and test failure and failover whenever you want. You can automatically recover from failure with the cloud. Monitoring a system for a key performance indicator, or KPI, you can automatically trigger automated recovery processes when a threshold is breached. You can scale horizontally to increase aggregate system availability. Using multiple small resources instead of one large resource will reduce your single points of failure. And also, you can stop guessing capacity. Gone are the days of using lack of memory or not enough CPU as a failure for a resource. With the cloud, you can scale as and when you need to, so you can't blame badly estimated capacity as the reason for reliability issues. Now, reliability in the cloud is composed of three areas. These are foundations, change management, and failure management. To achieve reliability, a system must have a well-planned foundation and monitoring in place, plus systems for handling changes in demand or requirements is also required. In an ideal world, your system would be designed to detect failure and automatically heal itself. Before architecting any system, you should have foundations in place so that your reliability is not impacted. You should have sufficient network bandwidth to your data center. You should have sufficient compute capacity. Your staff should be trained in the areas they need to be, and you should have support contracts with your vendors. With AWS, network bandwidth and compute capacity is already taken care of. AWS also offers a range of support contracts to help you with issues and a range of training courses for your staff. Change management is a critical part. Being aware of how a change affects the system allows you to plan proactively, and monitoring allows you to quickly identify trends that could lead to capacity issues or SLA breaches. With AWS, you can monitor the behavior of a system and automate the response to KPIs. For example, you can add additional servers as a system gains more users. So you can control who has permissions to make system changes and audit the history of these changes. Unfortunately, it's a given that failures will occur, so you need to have some failure management in place. It's good practice to understand why things failed so you can prevent it from happening again. No one wants to work for a company that, when things go wrong, they just get it working again with no understanding of why. A key to managing failure is frequent and automated testing of systems to failure and through recovery. Ideally, you do this on a regular schedule and also after you've made significant system changes. Now, Amazon allows you to do this with a few products. Firstly, AWS CloudFormation. This allows you to launch temporary copies of whole systems at very low cost, so you can use automated testing to verify your recovery processes. You can use CloudWatch to set up automation to react to monitoring data that indicates a failure. And you can store all your data on Amazon S3 buckets for future use. The next pillar is performance efficiency, and Amazon defines this as the ability to use computing resources efficiently to meet system requirements and to maintain that efficiency as demand changes and technologies evolve. So what does this mean? Well, performance efficiency in the cloud means you can democratize advanced technologies. AWS provides products such as NoSQL or media transcoding or even machine learning as a service. So rather than your IT team having to learn how to host and run these new technologies, AWS does it for you. You can go global in minutes. AWS allows you to easily deploy your systems in multiple regions around the world with just a few clicks of your mouse. So this leads to lower latency for your customers. You can use serverless architectures in the cloud, which remove the need for you to run and maintain servers to carry out traditional compute activities. For example, storage services can act as static websites, which remove the need for web servers. And you can also use serverless technologies such as Lambda or Elastic Beanstalk. And you can also experiment more often. With virtual and automatable resources, you can quickly carry out comparative testing using different types of instances, storage, or configuration. So performance efficiency in the cloud is composed of four areas: compute, storage, database, and something called space-time trade-off. And let's take a look at each of these. With the cloud, finding the optimal server configuration for a product will vary based on application design, usage patterns, and configuration settings. Traditional IT infrastructure requires making estimates in advance, which can lead to incorrect server configurations and lower performance efficiency. AWS is virtualized, so you can quickly change the EC2 server configuration to increase its performance efficiency. It may be optimal to run serverless computing. For example, AWS Lambda allows you to execute code without running an instance, and Elastic Beanstalk allows you to run web applications in a similar manner. From an operational standpoint, you should have monitoring in place to notify you of any degradation in performance. The optimal storage solution for a particular system will vary based on whether you need block, file, or object storage, the type of throughput required, frequency of access, and availability and durability constraints. Well-architected systems use multiple storage solutions and enable different features to improve performance. In AWS, storage is virtualized and is available in a number of different types. This makes it easier to match your storage methods more closely with your needs, and also offers storage options that are not easily achievable with on-premise infrastructure. For example, Amazon S3 is designed for 11.9's durability and provides a variety of storage classes for your different data categories, like Glacier for archived data. EBS and EFS offer numerous options for your EC2 instances based on the level of performance you require from your storage. The optimal database solution for a particular system can vary based on requirements for consistency, availability, partition tolerance, and latency. Many systems use different database solutions for various subsystems and enable different features to improve performance. Selecting the wrong database solution and features for a system can lead to much lower performance efficiency. Now, for database usage, you need to be able to monitor them, test them, and also you need to have some database platform knowledge. But Amazon makes this much easier for you, as it provides a suite of Amazon relational database services, which are fully managed relational databases. For example, Amazon DynamoDB is a fully managed NoSQL database that provides single-digit millisecond latency at any scale. Amazon Redshift is a managed petabyte-scale data warehouse that allows you to change the number or type of nodes as your performance or capacity needs change. You can also make use of Aurora or AMIs, where you install your own databases from templates. So what is the space-time trade-off? Well, you can think of space as memory or storage, and you can think of time as the processing time or the compute time to complete a task. So when you're architecting solutions, there's always a series of trade-offs, where it might be better to have more memory or storage to reduce the processing time, or maybe you're happy to sacrifice the processing time in order to reduce your memory or storage requirements. AWS gives you the option to maximize one or the other. For example, you could launch your systems globally, so you're increasing space and memory, so that they're closer to the end users in order to reduce latency, or the time. But whatever resource you use, you need to have monitoring in place to notify you of any degradation in performance. And the final pillar of the well-architected framework is cost optimization. This is defined as the ability to avoid or eliminate unneeded cost or suboptimal resources. AWS Cloud has a number of ways you can provide cost optimization. Firstly, you can transparently attribute expenditure, as the cloud makes it easy to identify the costs of a system and attribute IT costs of individual business owners, so those owners will have an incentive to optimize their resources and reduce costs. You can use managed services to remove the operational burden of maintaining servers for tasks such as sending email or managing databases. You can trade capital expense for operating expense. Instead of investing heavily in data centers and servers before you know how you're going to use them, with AWS, you pay only for the computing resources you consume when you consume them. Also, AWS allows you to achieve higher economies of scale because they can buy way more servers and hardware than you could ever imagine, so it's much cheaper to use their hardware than buy your own. You should also stop spending money on data center operations. AWS has the heavy lifting of racking, stacking, and powering servers, so you can focus on your customers and business projects rather than on your IT infrastructure. Cost optimization in the cloud is composed of 4 areas: match supply and demand, cost-effective resources, expenditure awareness, and optimizing over time. Matching supply to demand will deliver the lowest costs for a system, but you'll need to be able to provide sufficient extra capacity to cope with demand and failures. In AWS, you can automatically provision resources to match demand. Autoscaling, time-based and event-driven and queue-based approaches allow you to add and remove resources as needed. Monitoring tools and regular benchmarking can help you achieve much greater utilization of your resources. Using the appropriate instances and resources for your system is key to cost savings. For example, a reporting process might take 5 hours to run on a smaller server, but a larger server that is twice as expensive might be able to do it in just 1 hour. Both jobs give you the same outcome, but the smaller server will incur more costs over time. But to be able to find out these things, you need to have monitoring of expenditure in place and also regular benchmarking. AWS helps you with this. AWS Trusted Advisor goes through your resources and tells you where you can make savings. You can use on-demand instances, so you only pay for compute capacity by the hour with no minimum commitments required. Or you could use reserved instances, which allow you to reserve capacity and offer savings of up to 75% off on-demand pricing. And with spot instances, you can bid on unused EC2 capacity at significant discounts. You can also take advantage of managed AWS services, such as RDS or DynamoDB, which can also lower your costs. AWS and its virtually unlimited on-demand capacity requires a new way of thinking about expenditures. So you need to have a different way of budgeting, and you need to understand your business unit's usage. To do this, you can use cost allocation tags to categorize and track your AWS costs for AWS resources, such as EC2 or Amazon S3. And AWS generates a cost allocation report with your usage and costs aggregated by your tags. So you can set up tags for each of your business categories and units. This increased visibility of costs makes it easier to identify resources or projects that are no longer generating value and should be decommissioned. Billing alerts can be set up to notify you of predicted overspend, and the AWS Simple Monthly Calculator allows you to calculate data transfer costs. And you can set up SNS alerts so you can be notified when certain resources or cost breaches occur. Optimizing over time is an important strategy to reduce your costs associated with your cloud environment. AWS is always releasing new products and services. As such, you need to reassess your existing setup to see if it's the most cost effective. For example, rather than running a database on an EC2 instance, it might be cheaper to run an Amazon RDS database. Or Lambda might be more cost effective than EC2. But where do you find out more information about these new products and services from Amazon? Well, the first place to look for any new architecture guide is the AWS Architecture Center. This is a resource that provides you with the guidance and application architecture best practices to build highly scalable and reliable applications in the cloud. Here you'll find the AWS Reference Architectures. The AWS Reference Architecture datasheets provide architectural guidance to help you build an application on the AWS cloud. You'll find datasheets that include a description of how each service is used, plus visual representations of the application architecture. For example, web application hosting, or large-scale processing and huge datasets, or even building elastic web front ends for an e-commerce website. AWS white papers provide a comprehensive list of technical AWS white papers that cover all Amazon-related topics, such as architecture, security, and economics. There are new white papers being released all the time and are written by some of the most knowledgeable AWS people around. AWS Quick Start reference deployments use AWS CloudFormation templates to rapidly deploy a fully functional environment for a variety of enterprise software applications. Supplementary deployment guides describe the architecture and implementation in detail. In this course, we'll deploy things manually, step by step, so you can see how it works. But with CloudFormation templates, you can do several hours work with just the click of a button. Examples of CloudFormation templates are SharePoint, RD Gateway, or even SQL Server on Windows Server failover clusters. And finally, case studies. AWS maintains a large list of case studies and success stories from their clients. You can check to see how some of the largest and most successful companies on the planet use AWS for their business. In the Planning and Designing section, we'll take a look at the principles involved in planning and designing cloud infrastructure. You'll learn
how the AWS well-architected framework is used in planning and designing. We'll take a look at scaling and all the different versions. We'll look at the importance of loose coupling, how you can build redundancy into your cloud infrastructure, how you can save money by cost optimization. We'll look at automation and how it can make management of an IT environment easier. And also we'll take a look at security and how you can secure your cloud resources. So let's start with scalability. In the past, you would have to estimate the peak load of your systems and purchase your hardware accordingly. So perhaps you were setting up a new website and you were estimating that you're going to get 1 million people per month hitting your website. So you buy the hardware accordingly. But then you find out that only 50,000 people are hitting it, or 10 million people are hitting it. So your hardware is inappropriate for the work. Cloud computing provides virtually unlimited on-demand capacity, so you can scale whenever you need to. To do this, your designs need to be able to seamlessly take advantage of these resources. And there are 2 ways to scale, vertically and horizontally. Vertical scaling means increasing the specifications of an individual resource. For example, increasing the memory or the number of CPUs on a server. With AWS, this is easily achieved with a restart of your virtual server, so that it resizes to a larger or smaller instance type. The advantage of this approach is that it's very easy and requires little thought in the short term. However, this type of scaling can eventually hit a limit and sometimes be cost inefficient, especially if you scale up to some very, very large instances. Horizontal scaling means increasing the number of resources rather than the specifications of each individual resource. For example, adding additional web servers to help spread the load of traffic hitting your application. This is a great way to build applications that leverage the elasticity of cloud computing. However, not all architectures can distribute their workload to multiple resources. A stateless application is one that needs no knowledge of previous interaction and stores no session information. An example of this would be a web server that provides the same web page to any end user. A stateless application can scale horizontally as any request from any end user can be serviced by any of the available compute resources. You can add more resources as required and then remove them when the capacity is no longer available. Stateless applications do not need to be aware of their peers. All that is required is a way to distribute the end user sessions to them. And there are 2 ways to distribute load to multiple nodes. The first of these is the push model. A load balancer, such as the AWS Elastic Load Balancer, is a popular way to distribute a workload across multiple resources. An alternative, but less recommended approach, is to implement a DNS round robin using Amazon Route 53, where DNS responses return an IP address from a list of valid hosts in a round robin fashion. This is an easy to set up option, but it can cause issues if DNS records are cached. The alternative to the push model is the pull model. Tasks that need to be performed can be stored as messages in a queue, and multiple compute resources can pull and process the messages in a distributed fashion. Examples of this are big data processing scenarios, where many servers work to analyze data and return results, or media file conversion processes, where multiple servers convert the files as they arrive. Amazon SQS or Amazon Kinesis are services that can provide pull model load balancing. Most applications need to maintain some kind of state information. For example, an automated multi-step process will also need to track previous activity to decide what its next action should be. You can make components in your architecture stateless by not storing anything on the local file system, and instead storing user or session-based information in a database, like DynamoDB or MySQL, or on shared storage, like Amazon S3 or EFS. Additionally, Amazon SWF can be used to centrally store execution history and make your workload stateless. So the opposite of stateless applications are stateful applications, as it's not possible to turn some layers of your architecture into stateless components. For example, databases, which are stateful by definition, or applications that were designed to run on a single server. Providing multiple users a consistent view of the database or application is much simpler when your components are not distributed. Distributing the load is possible though through session affinity. This means that all transactions of a session are bound to a specific compute resource. However, this means that existing sessions would not be able to utilize newly introduced compute nodes. And also, if a node is shut down or becomes unavailable, users bound to that session will be disconnected. For situations when you need to process large amounts of data, it's always beneficial to see if a distributed processing approach can be used. Imagine a task that requires a huge amount of data processing. If it was to run on a single compute resource, it would max out the resources and take a long time to complete. If you can divide the task into smaller fragments of work, then each of the tasks can be executed across a larger set of compute resources. Examples of this are the AWS Elastic MapReduce service, which allows you to run Hadoop workloads across multiple EC2 instances, or Amazon Kinesis allows you to run multiple shards of data on EC2 or Lambda resources for real-time processing of streaming data. The concept of disposable resources is completely new with cloud computing, as cloud computing completely changes the mindset of an IT infrastructure environment. Traditional environments involved purchasing hardware up front and required manual configuration of the software, network, etc. Whereas with cloud computing, all infrastructure is temporary or disposable. You can launch new instances when you need them and get rid of them when you are done. Automate compute resource initiation is a way to speed up the creation of new environments. AWS has plenty of features to make new environment creation an automated and repeatable process. And there's 3 options available which we'll look at in the coming slides: bootstrapping, golden images, and a hybrid approach. Bootstrapping means you can take a newly launched AWS resource with its default configuration and then execute automated scripts to install software or copy data to bring that resource to a required state. So you could launch an EC2 instance and copy data on so that it becomes a web server. Scripts can be parameterized so that different environments, production or development, can be initiated easily. With AWS, bootstrapping can be achieved with your own scripts, Chef or Puppet, OpsWork, lifecycle events, or CloudFormation. Golden images mean you take snapshots of your EC2 instances or RDS instances or even EBS volumes, and they can be used to launch new instances. These EC2 instances can also be customized and saved as AMIs, Amazon Machine Images, and then you can launch as many instances as you want from this template. If you have an on-premise virtualized environment, you can also use AWS VM Import-Export to create your own AWS AMIs. The hybrid approach makes use of both bootstrapping and golden images. You can launch new instances from a golden image, but then bootstrap to configure other actions. Basically, with AWS, you are only restricted by your imagination or coding skills. AWS assets are programmable, so you can apply all these techniques and principles that we've just talked about to entire environments and not just individual resources, so you can completely rethink the way you work your IT infrastructure. Automation is a big part of planning and designing cloud infrastructure. AWS allows you to reduce the level of manual interaction in your environment. Using automation, you can react to a variety of events without having to do anything. Let's take a look at some examples. AWS Elastic Beanstalk. Developers can upload their code and the Beanstalk service automatically handles resource provisioning, auto-scaling, load balancing, and monitoring. EC2 Auto Recovery. In some situations, you can use auto recovery to automatically recover an EC2 instance if it becomes impaired. The recovered instance is identical to the original, instance name, IP address, metadata, etc. Auto-scaling. You can automatically add resources to cope with demand spikes and decrease again during quiet times. CloudWatch alarms and events. CloudWatch can send SNS notifications to alert when a particular event occurs. For example, CPU usage is too high. The notifications can be used to perform follow-up actions, like run a Lambda function. OpsWorks lifecycle events
you can continually update your instance's configuration to adapt to environment changes. For example, if a new database instance is added to your environment, then an event can automatically trigger a chef recipe that points existing applications to the new server. Loose coupling is an important concept. Applications should be designed so that they're broken into smaller, loosely coupled components. The desired outcome is that a failure in one component should not cause other components to fail. This is achieved through a variety of measures. Firstly, well-defined interfaces. By ensuring that all components only interact with each other through specific technology-agnostic interfaces, for example RESTful APIs, will result in being able to modify resources without affecting other components. Amazon API Gateway is a fully managed service for APIs, which you can do this with. Loose coupling needs services to be able to interact with each other without having any prior knowledge of their existence. For example, imagine two servers communicating on hard-coded IP addresses. Then the addition or modification of resources will result in manual interaction to update the configuration. However, loosely coupled infrastructure is an essential ingredient in making the most of cloud computing elasticity. The easiest way to achieve this is to use an elastic load balancer service to provide a stable endpoint for all your services. This way, they don't have to worry about each other, the elastic load balancer does that for them. Rather than use synchronous integration, where server A completes an action and passes it to server B, which then passes it to server C, asynchronous integration involves the use of an intermediate storage area, like an SQS queue. This approach means that when a server A completes its action, it sends a notification to SQS. This way the compute resources are decoupled and not directly linked to each other. This means you can easily add or remove resources without having to update the configuration of the existing compute resources. Designing applications to fail gracefully allows other resources to continue a service without causing a complete outage. Examples of this would be if your primary website fails, the Route 53 DNS failover feature points your users to a backup site hosted on a static website on Amazon S3. The idea is to continue to provide a service, even if it isn't the full experience. Traditional IT infrastructure involves developing, managing, and operating applications with a wide variety of underlying technology components. AWS isn't just about EC2 instances. There are a suite of products to do everything mentioned and a lot more besides, to help you lower your IT costs and allow you to move faster as an organization. For example, managed services. AWS provides many services that are fully managed: databases, machine learning, analytics, search, email, etc. This lessens the burden on your IT infrastructure department. RDS databases mean you don't have to worry about backups, fault tolerance for your simple databases. S3 allows you to store as much data as you need without having to concern yourself with capacity management. Serverless architectures. You can reduce operational complexity of your applications through the use of serverless architectures. Tools such as the Internet of Things, Lambda, S3, Beanstalk all allow you to run your applications without paying for any server infrastructure. In a traditional IT environment, the type of database in use is typically restricted by constraints on licensing, support capabilities, hardware availability, and things like that. AWS provides you with multiple managed database server options that remove these constraints, meaning that you can choose exactly the right database for your needs rather than making use of what is available to you. AWS offers fully managed, easy scalable services for relational databases, NoSQL, data warehouses, and search functions that provide fully managed, easily scalable services that can create synchronously replicated standby instances in different availability zones. And they'll also automatically fail over without the need for manual intervention. We'll cover databases in a whole lesson later on in this course. Now we'll take a look at redundancy. Introducing redundancy will ensure your systems are highly available so they can withstand the failure of individual or multiple components, for example hard disks, servers, or network links.
Introducing redundancy will remove single points of failure from your systems. This is achieved by having multiple resources for the same tasks in either standby or active mode. Standby redundancy is often used for stateful components like databases. The standby resource becomes the primary resource by it failing over to it. The standby resource can be brought online only when required to save cost, or it can already be running to speed up the failover process and minimize the outage. Active redundancy is where multiple redundant compute resources share requests and are able to absorb the loss of one or more of the instances failing. Examples of this would be multiple web servers sitting behind a load balancer. Automatic failure detection allows you to react to an outage automatically without the need for manual intervention. Services like Elastic Load Balancer and Route 53 let you configure health checks so you can automatically route traffic to healthy resources. For example, setting up a health check to test for a HTTP 200 response, which means OK, would allow AWS to know if a node is healthy or not. Services such as OpsWorks, Elastic Load Balancer and EC2 Auto Recovery will let you replace unhealthy resources with brand new healthy ones. Durable data storage is an important part of planning your cloud resources. Replicating your data to other sites or resources will protect its availability and integrity. There's 3 ways you can replicate your data: synchronously, asynchronously, or quorum-based. Synchronous replication ensures that your data has been durably stored on both the primary and replication locations. Any write operation will only be acknowledged as complete when this has taken place. This should only be used on low latency network connections where absolutely necessary to try to ensure maximum performance. Asynchronous replication decouples the primary node from the replica so that a write operation doesn't have to wait for any acknowledgement. This can introduce a replication lag but does not impact performance. And from personal experience, I've seen the difference between synchronous and asynchronous replication changing performance as much as 100%. Quorum-based replication is a mix of both synchronous and asynchronous replication. Replication to multiple nodes is controlled by defining the minimum number of nodes that must participate in a successful write operation. So if you have a cluster of 4 replicas, you can say, I need confirmation from at least 2 of them before the acknowledgement is sent back to the end user. A traditional data center failover scenario involves failing over all your resources to a secondary distant data center. Because of the long distances between the 2 data centers, synchronous replication is often impractical, slow, and usually involves data loss and isn't tested very often. However, it does protect against low probability scenarios such as a natural disaster. So if your main data center was in New York and your secondary was in, say, Washington, if New York had a massive outage, you could fail over to Washington, but it's going to be slow and practical and take some time. A more likely scenario is a shorter interruption in your data center, which isn't predicted to be too long. In this situation, your choice is to sit it out and wait, or initiate the complex failover procedure. AWS data centers are configured to provide multiple availability zones in a region, with low latency network connectivity. This means you can replicate your data across data centers in a synchronous manner, and as a result, failover becomes much simpler. Also, this concept is baked into many AWS services, such as RDS and S3. Active redundancy is great for disaster recovery situations or balancing traffic, but what if all the requests to your resources were harmful? For example, if a particular request caused a bug and it resulted in multiple instances crashing. A practice called shuffle sharding means only sending some of the requests to some of your resources. This way, if one shard of resources is infected or down, the other shard of resources will be up and running. In the example shown here, if request 2 is bad, then at least one set of resources is still protected. AWS economies of scale offer organizations huge opportunities to make cost savings. By making further use of AWS capabilities, there's even more scope to create cost-optimized cloud architectures. Right-sizing is one such approach. In stark contrast to traditional IT infrastructure, Cloud computing means you can select the most cost-effective resource and configuration to fit your requirements. EC2, RDS, Redshift and Elasticsearch give you a wide variety of instance types to choose from. Through benchmarking, you can determine the optimal configuration for your workload. In some cases, it might be optimal to select many of the cheapest instance type available. In others, it might be more beneficial to select fewer instances, but of a larger instance type. AWS Storage offers the same level of right-sizing opportunities. Amazon S3 offers many different storage classes to suit your needs. EBS also comes in a variety of different volume types, all of which will be covered in later lessons. AWS offers many elasticity options to help you save money. You can auto-scale your EC2 workloads horizontally or vertically. You can turn off production workloads when you don't need them. And where possible, you can use Lambda compute workloads so you never have to pay for idle resources. EC2 on-demand instance pricing means you only pay for what you use with no long-term commitments. However, there are two more ways to pay for EC2 instances. One of these is reserved capacity. By committing to a defined period of between 12 to 36 months, you can receive significantly discounted hourly rates compared to on-demand pricing. AWS Trusted Advisor, or AWS EC2 usage reports, identified the resources that would benefit from reserved capacity. There is technically no difference between on-demand and reserved instances. The only difference is the way you pay for it. This concept also exists for Redshift, RDS, DynamoDB, and CloudFront. EC2 spot instances are ideal for workloads that have flexible start and end times, as you are allowed to bid on spare EC2 computing capacity, and spot instances are often available at significant discounts compared to on-demand pricing. Your EC2 spot instance is launched when your bid exceeds the current spot market price, and it will continue to run until either you terminate it or the spot market price exceeds your bid. When the latter happens, your instance is terminated, and you'll not be charged for the partial hour that it was running. So there's three strategies to use for spot instances. There's the one we've just discussed, which is bidding. You could bid much higher than the spot market price for as long as the instance runs. This way, even if the market price spikes occasionally, you'll still make a saving overall. The mix strategy. AWS recommends designing applications that use a mixture of reserved, on-demand, and spot instances. This way you can combine predictable capacity with opportunistic access to cheaper additional compute resources. And then finally, there's spot blocks. AWS allows you to bid for fixed duration spot instances. These have a different hourly pricing, but allow you to define a duration requirement. If your bid is accepted, your instance will run until you terminate it or the duration ends. Now let's take a look at caching. Caching data means storing previously calculated data for future use, so you don't have to recalculate it again. There's two approaches. Application caching. You can design applications to store and retrieve information from fast managed in-memory caches. This way an application can look for results in the cache first, and if the data isn't there, it can then calculate it or retrieve the data and store it in the cache for subsequent requests. This approach improves user response times and reduces load on your resources. An example of this is Amazon Elasticache, which is a service that provides an in-memory cache in the cloud suitable for use with web services. Edge caching uses Amazon CloudFront, so you can cache static content such as images or video and dynamic content such as live video around the world using edge locations. This way users can be served the content that is closest to them, and resulting in low latency response times. The principle applies to both download and upload with edge caching. And finally, security. It's important to have security built into your plans and designs for AWS infrastructure. AWS allows you to take most of the security tools and techniques that you already know and improve them by formalizing security control design into your AWS platform. This simplifies the system for administrators and auditors alike. Now, we're not going to cover too much here because this is all covered in the IAM lesson, but there's things like defense in depth, which allows you to add multiple layers of protection to your resources, reduced privileged access to only give people the access they require, security as a code.
lets you capture security requirements in one script that you can use to deploy new environments. And real-time auditing. AWS has multiple services to ensure you can test and audit your environment in real time. In this section, we're going to take a look at monitoring and logging, and an overview of the tools available to enable AWS monitoring and logging. In this section, you're going to learn about Amazon CloudWatch, Amazon CloudTrail, and Amazon Config, and how they can be used to monitor and log your cloud infrastructure. So Amazon CloudWatch monitors your Amazon Web Services resources and applications in real time in a particular region. It collects and tracks metrics, it uses alarms to send notifications, and you can automatically make changes to monitored resources based on defined rules. Amazon CloudWatch events deliver a stream of system events which alert about changes to AWS resources. Alerts can be sent to services such as AWS Lambda, Amazon SNS, Amazon SQS, and Amazon Kinesis streams. For example, you can monitor the CPU usage and disk reads and writes of your EC2 compute cloud instances. Then you can use this data to determine whether you should launch additional instances to handle the increased load. You can also use this data to stop underused instances and save money. You can also use CloudWatch events to schedule events, such as a snapshot creation or an instance reboot. In addition to the monitoring with the built-in metrics that come with AWS, you can monitor your own custom metrics to enable system-wide visibility into resource utilization, application performance, operational health, and even cost. You can use Amazon CloudWatch logs to monitor, store, and access your application or system logs from Amazon EC2 instances, AWS CloudTrail, or other sources. You can then retrieve the associated log data from CloudWatch logs. So CloudWatch has a number of limits for metrics, events, and logs. Now I'm not going to go into all of them because there's quite a lot, but some of the key ones are: you get 10 CloudWatch metrics per customer per month for free, as well as 10 alarms per customer per month for free, 1 million API requests, 1,000 Amazon SNS email notifications. There's also no limit on the number of custom metrics you can create. You can create up to 5,000 alarms per AWS account, and your metric data is kept for 2 weeks. AWS CloudTrail is a web service that records AWS API calls for your account. The recorded information includes the identity of the API caller, the time of the API call, the source IP address of the API caller, and other request parameters. CloudTrail also stores and delivers log files to you, and it provides a history of AWS API calls for your account. CloudTrail provides increased visibility, so you can answer questions such as: what actions did a given user take over a given time period? Or for a given resource, which user has taken actions on it over a given period of time? What is the source IP address of a given activity? And which activities failed due to inadequate permissions? So CloudTrail will help you when auditors come asking questions, or if you're trying to solve a problem. It also offers durable and inexpensive log file storage. CloudTrail uses Amazon S3 for log file storage, so log files are stored durably and inexpensively. You can also use Amazon S3 lifecycle configuration rules to further reduce storage costs. For example, you can define rules to automatically delete old log files or archive them to Amazon Glacier for additional savings. CloudTrail is a fully managed service, so no installation required. You turn on CloudTrail for your account in the AWS Management Console, and it will start creating CloudTrail log files in an Amazon S3 bucket that you specify. You get notifications for log file delivery. CloudTrail uses the Amazon Simple Notification service so that you can be notified when a new log file is delivered or when a specific event has occurred. Also, companies such as Splunk, Sumo Logic, or Loggly offer integrated solutions to analyze your CloudTrail log files. CloudTrail can also be configured to aggregate log files across multiple accounts and regions, so that log files are delivered to a single S3 bucket. CloudTrail automatically encrypts all log files delivered to the specified S3 bucket by using the Amazon S3 server-side encryption, SSE. You can also further secure your log files using the AWS Key Management Service. You can also validate the integrity of your CloudTrail log files. So if you're concerned that an admin user is trying to cover up his tracks by deleting entries from the log files, you can see whether the log files are unchanged, modified, or have been deleted since CloudTrail delivered them. AWS Config is a fully managed service that provides you with an AWS resource inventory, configuration history, and configuration change notifications. You can automatically check the configuration of AWS resources by checking AWS Config. Using config rules, an IT administrator can quickly determine when and how a resource went out of compliance. For example, you can ensure that your EBS volumes are encrypted, your EC2 instances are properly tagged, or elastic IP addresses are attached to instances. And this is all enabled with a few mouse clicks in the AWS console. AWS Config enables configuration visibility. You can view all the configuration attributes of your AWS resources in real time, and SNS will notify you of any updated configuration or specific changes from the previous state. You can continuously assess the overall compliance of your AWS resource configurations based on your organization's policies and guidelines. AWS config rules give you a visual dashboard with lists, charts, and graphs to help you quickly spot non-compliant resources and take appropriate action. AWS config is also compatible with third-party applications such as Splunk. In this section, we're going to take a look at hybrid IT architectures and have an overview of the tools and functionality available to run hybrid cloud architectures. AWS offers a wide and deep set of functionality that allows you to integrate your existing network, security, data, lifecycle management, and resource management capabilities with the cloud. AWS allows you to extend your existing on-premise network configuration onto your AWS virtual private clouds, so that your AWS resources will operate as if they're part of your existing network. You can do this using Amazon Virtual Private Cloud, VPC, which is a logistically isolated network in the Amazon cloud that gives you complete control over your virtual networking environment. You can choose your own IP range, subnets, route tables, network, etc. Then there's Direct Connect. Rather than use internet-based connections between your on-site resources and the Amazon cloud, Direct Connect lets you establish a dedicated network connection between the two to provide lower costs and a higher level of service. You can use AWS to reliably and cost-effectively back up and secure your data. AWS allows you to replicate your data across geographical regions, manage the lifecycle of the data, or even synchronously replicate your data to a local AWS data center. AWS Storage Gateway is a VM that you install in your data center and configure to be associated with your AWS account. Then you can either use Gateway Cached, which lets you use Amazon S3 storage as your primary data storage, while retaining frequently accessed data locally in your storage gateway, or Gateway Stored. Gateway Stored volumes let you store your primary data locally and asynchronously back that up to AWS. Amazon Simple Storage Service S3 offers a practically unlimited storage that's available for backing up and archiving your critical data, and Amazon Glacier is extremely low-cost storage for infrequently accessed data, for which recovery intervals of several hours are suitable. AWS Security and Access Control is easily managed using IAM or Microsoft Active Directory services. AWS Identity and Access Management is the service that enables you to securely control user access to all your AWS services and resources. An AWS Directory Service is a managed service that allows you to connect your AWS resources with an existing on-premise Microsoft Active Directory, or you can set up a new standalone directory in the AWS cloud. AWS Security and Access Control is easily managed using IAM or Microsoft Active Directory services. AWS Identity and Access Management is the service that enables you to securely control user access to all your AWS services and resources. An AWS Directory Service is a managed service that allows you to connect your AWS resources with an existing on-premise Microsoft Active Directory, or you can set up a new standalone directory in the AWS cloud. And there's three flavors of Active Directory. There's Microsoft AD, which is a fully blown managed Microsoft Active Directory service that supports up to 50,000 users. There's Simple AD, which is a standalone managed directory that's available in two sizes, small and large. Small is for up to 500 users, and large supports up to 5,000 users. Or there's AD Connector, and this is a directory gateway that allows you to proxy directory requests to your on-premise Microsoft Active Directory. And this also comes in two sizes, small and large. A small AD connector is designed for small organizations of up to 500 users, and a large AD connector is designed for larger organizations for up to 5,000 users. You can also use integrated resource and deployment management tools in your hybrid environment. AWS provides monitoring and management tools with robust APIs, so you can easily integrate your AWS resources with on-site tools. And most major software vendors already support AWS, like Microsoft, VMware, and BMC. Tools such as AWS OpsWorks allow you to deploy and operate applications in the AWS cloud or in your own data center. You can use templates or build your own tasks to specify an application's architecture. AWS Code Deploy automates code deployments to instances in your existing data center or in the AWS cloud. AWS Code Deploy simplifies the code deployment process to your instances. This is the practice assignment for designing hybrid storage, where you'll configure a basic plan to resolve an on-premise storage problem. You've been hired by a medium-sized law firm who have an aging storage solution that they would like to replace, but they do not want to purchase any new hardware. They store several terabytes of data, which is comprised of documents and images. A lot of the data is legacy data, which is rarely accessed and can be archived. However, the most recent files need to be available instantly. You have been tasked with providing a very basic high-level plan of a hybrid storage solution using the client's existing data center and AWS. Detail the products and services you would use and sketch out a basic plan of the infrastructure.
So let's review the key takeaways from this lesson.
In this topic, we will learn about Amazon Glacier. Amazon Glacier is an economical storage solution to store data that would remain forever, but rarely accessed. It is an ideal choice for data backup and archiving, provides data security of the highest level, and offers flexibility in both storing and retrieving data. AWS bills you for only the used data or storage, and current least price for storing data in Amazon Glacier is 0.007 cents per gigabyte per month. Maintaining historical data can be a grief, as it is added to the administrative liability of managing the scaling storage. Amazon Glacier eases this hardship by providing features such as capacity planning, hardware provisioning, detecting and repairing hardware failure, data replication, and hardware migrations. When you preserve data in Amazon Glacier, it is stored as archives. This enables a user to store a single file or a combination of several files. Archives are arranged in vaults, which can be accessed using the AWS IAM service. Amazon Glacier stores data in transit via SSL and uses the 256-bit advanced encryption system. AWS enables organizations to store data in a location that is convenient for their businesses, and organizations tend to utilize Amazon Glacier to support the following use cases: archiving off-site enterprise information, backing up media assets, storing research and scientific data, preserving digital data, and replacing magnetic tapes. The Amazon Glacier Archives offers an average annual resilience of 99.999999999%. The archiving service maintains resilience by continuously utilizing several facilities and devices within each facility to store the data. the task continues till the service returns success on the uploading archives.
Any individual object archived into Amazon Glacier, such as a document, video, or any other type of file, is referred to as an archive. Each archive has a unique ID assigned to it by AWS. The archives are stored in vaults. A vault is addressed by a unique name assigned to it by its creator. A given AWS account may create up to 1,000 vaults in Amazon Glacier. You can refer to an archive in Amazon Glacier via a URL that points to the Glacier service and consists of the following three components: the account ID of your AWS master account, the name of the vault, the ID of the individual archive. Data stored in Amazon Glacier by Amazon S3 cannot be retrieved using the Amazon Glacier API. This is the data that Amazon S3 manages on your behalf, and it does not show up as a vault or archive. Amazon S3 archived files can be restored using the S3 Management Console interface or using the Amazon S3 API. Files added directly to Amazon Glacier using the Amazon Glacier API can be retrieved using the Glacier API. Retrieval requests can be any one of the following: direct retrieval of a single archive object by archive ID, filter by archive creation date, ranged archive retrieval, retrieve only a specific range of bytes from a specific archive. You can poll for job completion using the Describe Job API function. Amazon Glacier completion notifications can also be sent using Amazon Simple Notification Service, or SNS. Once an Amazon Glacier job has finished executing, the user can request a download of their thawed data. In this demonstration, you'll learn how to configure Amazon S3 buckets for archiving in Amazon Glacier, which is a lost-cost storage service. First, you need to go to S3 under the Storage and Content Delivery section. Select your required bucket. For this demonstration, we'll select the Test 11 October bucket. Click the Lifecycle option. Click Add Rule. Select the Whole Bucket option. Click the Configuration Rule button. Select the Archive to the Glacier Storage class option. State the number of days after the completion of which you want the data in your S3 bucket to move to the Glacier. For this demonstration, we'll provide 30 days. As you can see in the example provided, the objects in S3 bucket will move to Glacier after the completion of 30 days. Acknowledge the message that you are aware that setting up this particular rule will likely increase your storage costs. Click Review. Provide a rule name. You can review your rule on this page. Click Create and activate rule. As you can see, the rule has already been added. You have learned how to configure Amazon S3 buckets for archiving in Amazon Glacier.
Amazon CloudWatch is a monitoring service for AWS cloud resources and the applications you run on AWS. CloudWatch enables monitoring for EC2 and other Amazon Cloud services so you can get alerts when things go wrong. You can use Amazon CloudWatch to collect and track metrics, so you can get system-wide visibility into resource utilization, application performance, and overall operational health. And you can use these insights to react and keep your applications running smoothly. CloudWatch offers two types of monitoring. There's basic monitoring, which is included free of charge and polls every 5 minutes and gives you 10 metrics, 5 GB of data ingestion, and 5 GB of data storage. Then there's detailed monitoring, and this costs more. There's a price per instance per month, but it polls every minute. So if you want more detailed monitoring, then you can pay for it. AWS CloudWatch allows you to record metrics for services such as EBS, EC2, Elastic Load Balancer, and Amazon S3. And using these metrics, you can add them to dashboards to give visual or text-based notifications of what's going on. And this is a diagram of a dashboard in Amazon CloudWatch. Metrics are at the hypervisor level, so you can get things like CPU, disk, network, but you cannot see memory usage. Metrics appear as you add more resources to your AWS account. You can create events based on your CloudWatch monitoring, for example triggering Lambda functions. So perhaps if an EBS volume fills up, you could trigger an event so that data is removed and archived from the volume, or a new volume is created. So there's many things you can do. You can install CloudWatch agents on EC2 instances, and this will send monitoring data about the instance to CloudWatch. So you can monitor things like HTTP response codes in Apache, or you can count exceptions in application logs. You can set alarms to warn based on resource usage. For example, if CPU utilization is too high, then it could send a notification. It can also auto-scale, so if your CPU is maxed out, you can get another instance launched to take care of some of the load. Or you can send CloudWatch monitoring alarms to EC2 actions to, say, recover an instance or reboot an instance if something happens. You can also use alarms to shut down instances. It isn't just used for starting them up. So if you have idle instances, you can get CloudWatch to shut them down for you. In this demonstration, we're going to take a look at AWS CloudWatch and how we can use it to shut down idle instances. So before I started this demonstration, I launched an Amazon Linux instance and let it run for 10 minutes, just so we'd have some data. So now I'm going to go to Management Tools and click on CloudWatch. And this brings us to the CloudWatch dashboard. So what we're going to do is we're going to create a new dashboard, and we'll click on Create Dashboard so that we can have a look at the monitoring statistics for our new instance. So let's just give it a name and we'll call it just Simplilearn, just for a change. Okay, so it says Create Dashboard. And now we get the option, do we want to put text-based or metric graphs widgets to our dashboard? And we're going to select metric graphs. So we'll click on Configure. And then we're presented with all the CloudWatch metrics that I have available in my AWS account. So obviously I've just launched an EC2 instance, so I'm going to click on EC2 metrics. And my new server is called Simplilearn CloudWatch Demo. So I want to add CPU utilization. So let's click on that. So let me create this widget. And then that now appears on our dashboard. So we can add more. So we click on Add Widget. We'll do another metric graph. We'll go another per instance metric. And let's choose network in and network out. And we'll create the widget. Now, as you can see, there's not a lot happening here because I just launched this instance and I haven't really done anything on it. But this is how you would create a dashboard. And it's quite useful and very easy to see. So you can create a dashboard for your instance types. So what we're also going to do is set up an alarm. So let's go to Alarms. So now we want to create an alarm. So we click on Create Alarm and we get to choose the metric we want to base the alarm on. Now obviously we have an EC2 instance, so we're going to choose that option. And we're going to do it based on CPU utilization of our Simplilearn CloudWatch Demo instance. So we'll click on that and we'll click Next. So now we get to give our alarm a name. So just going to call it Simplilearn_alarm. Just for the purposes of this demo, we can give it a description. And now we get to set the alarm threshold. So we're saying whenever CPU utilization is, and we're going to say less than or equal to 50% for one consecutive period, and remember a period is 5 minutes in basic monitoring, we want this alarm to fire. So why would you do this? Well, imagine if you had a really high-powered server that we were using every night to do some highly intensive compute computations. So you might know that it runs for a couple of hours and it's charging you quite a lot of money per hour to run, but when the CPU utilization drops below, say, 50% or 10%, you know the job is complete. So then you can get an alarm to fire and an action to happen. So you could set a notification, so we could get it to send an email when this alarm fires. We're not going to do that in this demonstration, but we can do an EC2 action. So whenever this state is in alarm, I want it to stop this instance. So this instance is going to be stopped whenever the CPU utilization is less than 50% for 5 minutes. And it's just telling us that there. So now if I click on Create Alarm, and here is our alarm. So it's just so it's telling us we're in alarm already because this instance has been up and running. It has monitoring data for the last 5 minutes, and it's saying the alarm has fired. So let me click on it and we'll see why. It says state changed to alarm, reason threshold crossed. One data point, 0.0034, was less than or equal to the threshold of 50%. And it says when it's in alarm, it's going to stop the instance. So if we go to the EC2 dashboard, and here we can see that the Simplilearn CloudWatch Demo instance has been stopped, and it's in a status of alarm. So it's telling us that our alarm fired and it took it straight down. Now obviously that's a pretty dramatic example. You wouldn't expect anything like that to happen in a real world, but it's a good way of seeing how alarms work. In this section, you'll learn what elastic load balancing is. Elastic load balancing automatically distributes incoming application traffic across multiple Amazon EC2 instances. It enables you to achieve increased levels of fault tolerance for your applications by seamlessly providing the required amount of load balancing capacity needed to distribute the application traffic. You can distribute incoming traffic across your EC2 instances in a single availability zone or multiple availability zones. Elastic load balancing automatically scales its request handling capacity in response to incoming traffic. Elastic load balancing can also detect the health of your Amazon EC2 instances. When it detects an unhealthy instance, it will spread the load across the remaining instances and no longer route traffic to the unhealthy instance. When you're using VPC, you can create and manage security groups associated with elastic load balancing to provide additional networking and security options. You can also create a load balancer without a public IP address, so it serves as an internal, i.e. non-internet facing, load balancer. Elastic load balancing also supports the ability to stick user sessions to specific EC2 instances using cookies. And if you remember from lesson 2 when we talked about session affinity, this is a version of that. In this demonstration, we're going to create a load balancer for our Simplilearn web servers. So to do that, we'll go to the Compute EC2 section. And I want to show you that before we can configure load balancing, there's a couple of things we need to do. So if we go to Load Balancers on the left-hand side, and then click on Create Load Balancer. So we want to create the load balancer inside Simplilearn VPC. Now I want to show you this warning that comes up. It says please select at least 2 subnets in different availability zones to provide high availability for your load balancer. And you could think, well, that's great, we have 2 subnets. We have a public subnet and a private subnet, and they're both in different availability zones. So if we add them both, we get another warning. It says this is an internet-facing elastic load balancer, but there is no internet gateway attached to the subnet you've just selected. So obviously our private gateway, private subnet, only has a NAT gateway to provide its internet access, so it's not a public internet-facing subnet. So what that means is we need to create a new public subnet in a different availability zone for our load balancer. So we already have this one, public, in US East 1B. We're going to create a public subnet in US East 1C as well. So to do that, let's go back to the networking VPC section. And this is going to be a quick review of the VPC lesson. So we'll go to subnets. We'll sort by VPC. So here are our 2 existing subnets. So we'll create a new subnet and we're going to call it, let me just paste what I copied, We're going to call it 10.0.3.0 US East 1C Simplilearn Pub. And we're going to put it in our Simplilearn VPC. And we want to put it in the US East 1C availability zone, so it's different to our existing public subnet. And we're going to put it in that CIDR block. So let's click Create. So there we are. Now we have 3 subnets in our Simplilearn VPC. 2 of them are public. Now, if you remember, when you create a new subnet, it will get attached to your default route table by default. So that's no good because our default route table doesn't have internet access. So we need to go to route tables. We click on our main default route table and have a look at subnet associations. We can see that our new subnet is in here. So we need to move it into our custom route table. So it will be the same as our existing public subnet. So if we click on Edit, we just tick the box next to our new public subnet and click Save. So now our new public subnet is in this route table, so it has internet access. So now we're good to go. So let's go back to the EC2 section, and we want to launch a new web server into this new public subnet. So we'll go to, well, we'll launch it from our AMI because we've already configured our web servers as an AMI. So we'll click Launch. We'll choose T2 Nano. We'll configure our instance details. So we're going to place it in the Simplilearn VPC. We're going to place it in our new public subnet in the US East 1C availability zone. We're going to enable a public IP. We're going to give it the administrator IAM role, and we're going to protect against accidental termination. The storage is fine. We're going to tag this one as Simplilearn Web Server 3. We'll configure the security group, so we'll put it in an existing group, which will be the web servers group, and we'll launch it using our existing Simplilearn key pair, which I have possession of. Okay, so that's launching. So we can see our Simplilearn web servers. So there we are, we've got 3 of them. We've got 1, 2 which are already up and running, and number 3 which is coming online. So now we're ready to create our load balancing. So let's go to load balancers again and create load balancer. We want to put it in our VPC and we'll give it a name. So this is the kind of internal name. We can tag it differently later on because you can't put any underscores or hyphens in this section. So we'll call it Simplilearn LB, Simplilearn VPC. If we wanted to create an internal load balancer, so it was balancing traffic that was just internal to our AWS VPC, we could tick this box. Here's the listener configuration. So what we can do here is we're saying that any HTTP traffic that comes in on port 80 to the load balancer is being pushed to port HTTP 80 on our instances. So what we could do is you could change this. You could have a different port for the load balancer and it maps it to your web servers. You could protect your web servers, but we're just going to leave it as it is. Now we want to add the subnets, so we're going to add both of our public subnets, and that warning's now gone, so now we're good. We have 2 subnets in 2 availability zones. Next we assign security groups. So we could just use our existing web server security group because that has HTTP port 80 open. It also has HTTPS open and SSH. So it's probably good practice to create a new security group just for our load balancer. So I'll call it Simplilearn Load Balancer SG. And we're simply going to have HTTP port 80 open from anywhere and nothing else. We should probably just give it a quick description so we know what it is. Security group for load balancing. Okay, so let's click Next, Configure Security Settings. And it's just telling us that our load balance security isn't using a secure listener because we're not using HTTPS or SSL, which is fine for this demonstration. Next, we configure the health check. So this is the check that the load balancer is going to perform to see if our instances are healthy. So it's using HTTP port 80 and it's going to look for existence of a file. So we're going to tell it to look for our healthcheck.html file. And if that doesn't exist, then the instance isn't healthy. Now we can configure some more details. So the response timeout is 5 seconds. We'll leave that. The interval between checks, the default value is 30. So let's bring that down because we want things to happen quicker. So that's 10 seconds. Unhealthy threshold is set to 2. So if it has 2 checks where it doesn't find the file, it's going to determine that the instance is unhealthy. And the healthy threshold is 10. We're also going to bring that down. We'll bring that down to 3. So after 3 consecutive healthy checks, it will say the instance is healthy. Okay, so now we can add our EC2 instances. So we'll add our 3 web servers. We've enabled cross-zone load balancing, so it can push traffic across both availability zones. And the connection draining setting we'll just leave as default. That's when it detects an unhealthy instance, that's how long before it will start redirecting traffic elsewhere. So next we'll click on Add Tags, so we can give this a more meaningful name. Simplilearn _ load balancer, and review and create. Okay, so we can review everything we did. We should be okay, so let's click create, and our load balancer is now being created. So let's have a look. So here it is. If we click on instances, you can see the instances, and it's saying they're all out of service at the moment. So that's because it's just configuring itself and it will take a while to come up. So I'm going to pause the demonstration and we'll come back when everything's up and running. Okay, so the load balancer has configured, and you can see that 2 of our 3 web servers are in service, but our 3rd web server is out of service. So why do you think this is? Well, I'll tell you why. It's because our new web server, Simplilearn Web Server 3, has just come up and we haven't done anything to it other than just launch the AMI. So let's go and check out what's going on the instance. So I've opened sessions to our 3 web servers here, and this is the new one, and it's because the Apache service isn't started by default. So we need to start the Apache service. Okay, so we get that weird error, but it tells me it's okay. So if we now go back to the load balancer and we wait a few seconds, we should see the Simplilearn web server number 3 come online. There you are, so now we're online. So it was as simple as just starting the service. So that shows how load balancing works. Now if something was out of service, we could remove it from the load balancer, or we could go and investigate the problem. Or we could use auto-scaling to manage it automatically on our behalf, and that's what we're going to look at in the next demonstration.
Welcome to the overview of Amazon EBS section. Amazon Elastic Block Store, or EBS for short, provides persistent block-level storage volumes for use with Amazon EC2 instances in the AWS cloud. Each Amazon EBS volume is automatically replicated within its availability zone to protect you from component failure, to offer high availability and durability. So basically EBS is the disk volumes that you attach to your EC2 instance.
You can create an EBS volume in the Management Console. When you create a new EBS volume, you need to define the region and the availability zone for it. You can also create new volumes through Amazon API or command line tools. The screen displays an example of creating a volume with the AWS CLI create volume command. Note that the size of the volume, availability zone, and the volume type is defined in the command. The region is assumed from the default settings of AWS CLI. You can also copy a volume to a different region using snapshots. One important point to be noted is that a first access penalty is attached to both Amazon EBS volumes and instant store volumes. This penalty can be a 5 to 50% reduction in performance on the first read or write. It is recommended that you warn the volume in order to eliminate this penalty from affecting production workloads, though this is not mandatory and in many cases may not be noticeable. Amazon EBS volumes can be stripped RAID 0 for performance, or configured redundant storage RAID 1 by using RAID arrays. You can create RAID arrays by using the standard operating system tools. You already know you can back up the data on your EBS volumes to Amazon S3 by taking point-in-time snapshots. Initial snapshot of the root or boot volume must be consistent, so it is highly recommended to stop the instance before making the first snapshot, or freeze the file system. Snapshot command runs and returns asynchronously and remains in a pending state until it is finished. You can watch the status of the snapshot in the AWS Management Console or through the API using AWS CLI tools. You can scale an Amazon EBS volume using snapshots. If you are performing the process on the root volume, be sure to stop the instance before detaching the original volume. Detach the original volume. If it is the root volume, then you will have to perform this action from the Management Console or from another Amazon EC2 instance that will continue running. Create a snapshot of the detached volume. Use the AWS EC2 create volume command to create a new volume. You can specify in the command that the volume will be created from the snapshot you previously took of the smaller or larger volume. Attach a new volume to the stopped EC2 instance, and if you expand the root volume, restart the instance. Keep in mind the following points to help you better manage snapshots. Use automation to manage a large number of snapshots across a large fleet. Use CLI tools to automate creating and managing snapshots through Linux Shell and Windows Batch. Create backup commands using CLI and schedule them through cron for Linux or Task Scheduler for Windows. Use services such as AWS Data Pipeline or configuration management systems like Chef to set up scheduling tasks remotely. On this screen, CLI commands for 3 common snapshot management operations are displayed: taking the snapshot, moving the snapshot across regions, and finding the snapshot ID and restore it to a new volume. The AWS CLI commands are self-explanatory. Note that it is always useful to pass a description for the newly created snapshot. Although snapshots are stored in Amazon S3, they are not directly accessible using the Amazon S3 utilities. You need to use the Amazon EBS tools to restore and manage snapshots.
In this demonstration, we're going to take a quick look at EBS snapshots. So we'll start by going to Compute EC2, and we'll go to the Volume section. Now here are the 2 volumes, the root volumes that are attached to our Simplilearn web servers. So I've tagged them as Simplilearn Web Server 1 root and Web Server 2 root, so we can see what they are. Now to create a snapshot, it's very easy. We highlight the volume you want to take a snap of, click on Actions, and click on Create Snapshot. Then we get to give it a name, so Simplilearn Web Server 1 root snap. Give it a description, snap of Simply1 Web Server root, and it's saying encrypted no, and that's because the root volume isn't encrypted. If this was an encrypted volume, then this would also be an encrypted snapshot. So we click on Create. So snapshot creation started. So if we go to Snapshots on the left hand side, we can see here that our snapshot has already been created. So that was a quick one. Now if you had a much larger volume, then it would take longer, because remember, it takes the snap, then it copies the snapshot to Amazon S3, so that can sometimes take a while. So this is 100% available. So what can we do with this? Well, we can keep this for safekeeping, and we could take a snapshot every night or every week of the web server, so we can restore to a point in time. Or if we wanted to, we could create a volume from this particular snapshot. So we could say, yep, create a new snap. We could change the different volume types. So here we are, as we mentioned, here are the two different HDD options, which are new as of April 2016. And we can change the availability zone. So once you have the snap, you can do pretty much anything with it in your region. You can also create an AMI from your EBS snapshot. So you could create an image of it, and you could use that to create a new instance if you wanted to. So that's a very brief overview of Amazon EBS snapshots.
Hi guys, welcome. And today's topic is on AWS Autoscaling. So this is Akhil. I would be taking up a tutorial on the autoscaling. But before that, I would request you guys to subscribe our channel. The link you can find just below this video at the right side. Let's begin with our tutorial and let's look into what we have in today's session. So I would be covering up why we require AWS Autoscaling. What is AWS Autoscaling? What are the benefits of using the scaling service? How this autoscaling works? The different scaling plans we have. What is the difference between the snapshot and the AMI? What is a load balancer? And how many types of load balancers we have? And along with that, I would be covering up a real life demo on the AWS. Let's begin with why we require AWS Autoscaling. Now, before AWS Cloud Scaling, there was a question in the mind of enterprises that they were spending a lot of money on the purchase of the infrastructure. If they have to set up some kind of a solution, so they have to purchase an infrastructure and a one-time cost was required. So that was a burden for them in terms of procuring a server, hardware, software, and then having a team of experts to manage all those infrastructure. So they used to think that no longer they require these resources if there was a cost-efficient solution for their project. That was the project manager used to think. Now, after the AWS Cloud Scaling that was introduced, automatically the autoscaling maintains the application performance based on the user requirements at the lowest possible price. So what does the autoscaling does is that whenever there is a scalability required, it manages it automatically. And hence the cost optimization became possible. Now, what is AWS Autoscaling? Let's look into deep. So AWS Autoscaling is a service that helps users to monitor their applications and the servers and automatically adjust the capacity of their infrastructure to maintain the steadiness. So they can increase the capacity, they can even decrease the capacity also for the cost optimization. And also predictable performance at the lowest possible cost. Now, what are the benefits of autoscaling? It gave the better fault tolerance applications. You can get the servers created and you can have a clone copy of the servers so that you don't have to deploy the applications again and again. Better cost management because the scalability is decided by the AWS automatically based on some threshold parameters. It was a reliable service, and whenever the scaling is created or initiated, you can get the notifications onto your mail IDs or to your cell phones. Scalability, as I mentioned, is always there in the autoscaling. It can scale up, it can scale down as well. And it has the flexibility in terms of whenever you want to schedule it, if you want to stop it, if you want to keep the size of the servers at a fixed number, you can always make the changes on the fly. And the better availability. Now, with the use of the autoscaling, we come around with the terminology called snapshot and the AMI. Let's look into the difference between the snapshots and the AMI. Snapshots versus AMI. So in a company, there was one of the employee that was facing an issue with launching the virtual machines. So he asked his colleague a question. Is it possible to launch multiple virtual machines with a minimum amount of time? Because it takes a lot of time in terms of creating the virtual machines. The other colleague said that yes, it is possible to launch multiple EC2 instances, and that can be done at a lesser time and with the same configuration. And this can be done either you use a snapshot or the AMI on the AWS. Then the colleague said that what are the differences between the snapshot and AMI? Let's look into the difference now. The snapshots basically kind of a backup of a single EBS volume, which is just like a virtual hard drive. That is attached to the EC2 instance. Whereas the AMI, it is basically used as a backup of an EC2 instance only. The snapshots opts for this when the instance contains multiple static EBS volumes. When you opt for the snapshot, whenever the instance contains multiple static EBS volumes. AMI, this is widely used to replace the failed EC2 instance. In the snapshots, here you pay only for the storage of the modified data, whereas with the AMI, you pay only for the storage that you use. The snapshots are non-bootable images on EBS volume, whereas AMI are bootable images on the EC2 instance. However, creating an AMI image will also create the EBS snapshots. Now, how does AWS Autoscaling work? Let's look into it. So for the AWS Autoscaling to work, you have to configure single unified scaling policy per application resource. And this scaling policy, with that you can explore the applications also. And then select the service you want to scale. Also, for the optimization, select do you want to optimize the cost or do you want to optimize the performance. And then keep track of scaling by monitoring or getting the notifications. Now, what are the different scaling plans we have? So, in the autoscaling, a scaling plan basically helps a user to configure a set of instructions for scaling based on the particular software requirement. The scaling strategy basically guides the service of AWS Autoscaling on how to optimize resources in a particular application. So, it's basically kind of the parameters that you set it up so that how the resource optimization can be achieved in the autoscaling. With the scaling strategies, users can create their own strategy based on their required metrics and thresholds, and this can be changed on the fly as well. What are the two types of scaling policies we have? So there are basically dynamic scaling and the predictive scaling. Now, what is dynamic scaling? It basically guides the service of AWS Autoscaling on how to optimize the resources. And it is helpful in optimizing resources for availability and particular price. Now, with scaling strategies, users can create their plan based on the required metrics and thresholds. So a metric can be like, let's say, a network in, network out, or it can be a CPU utilization, memory utilization likewise. Now, in the predictive scaling, its objective is to predict future workload based on daily and weekly trends and regular forecast future network traffic. So it is kind of a forecast that happens based on the previous past experiences. It uses a machine learning technique for analyzing that network traffic, and this scaling is like how weather forecast works, right? It provides schedule scaling actions to ensure the resource capacity is available for application requirement. Now, with the autoscaling, you would need the load balancers also, because if there are multiple instances that are created, then you would need a load balancer to distribute the load to those instances. So let's understand what do we mean by a load balancer. A load balancer basically acts as a reverse proxy, and it is responsible for distributing the network or the application traffic across multiple servers. With the help of a load balancer, you can achieve a reliability, you can achieve a fault tolerance of an application. That is basically, it increases the fault tolerance and the reliability. So for example, when there is a high network traffic that is coming to your application, and if that much traffic comes to your application to the instances, your instances may crash. So how you can avoid that situation? So you need to manage the network traffic that is coming to your instances, and that can be done with the load balancer. So thanks to the AWS load balancers, which helps in distributing network traffic across backend servers in a way that it increases performance of an application. Here in the image, you can see the traffic coming from a different resources landing onto the EC2 instance, and the load balancer is actually distributing that traffic to all the three instances, hence managing the network traffic quite properly. Now, what are the types of load balancers we have? There are three types of load balancers on the AWS. One is the classic load balancer, second is the application load balancer, and the third one is the network load balancer. Let's look into what we have in the classic load balancer. So the classic load balancer is the most basic form of load balancing, and we call it as a primitive load balancer also, and it is widely used for the EC2 instances. It is based on the IP address and the TCP port, and it routes network traffic between end users as well as in between the backend servers. And it does not support host-based routing, and it results in low efficiency of resources. Let's look into what we have in the application load balancer. This is one of the advanced forms of load balancing. It performs the task on the application level in the OSI model. It is used when there are HTTP and HTTPS traffic routing is required, and also it supports the host-based and path-based routing and performs well with the microservices or the backend applications. The network load balancer performs the task at layer 4 of the connection level in the OSI model. The prime role of the network load balancer is to route the TCP traffic, and it can manage a massive amount of traffic and is also suitable to manage the low latencies. Let's look into the demo and see how practically we can create the autoscaling. Hi guys, let's look into the demo for how we can create an autoscaling on the AWS console. So right now I'm logged into the AWS console and I am in the Mumbai region. What you need to do is you have to go to the compute section, and under that click on the EC2 service. Let's wait for the EC2 service to come. Now just scroll down, and under the load balancing there is an option called autoscaling. So there first you have to create a launch configuration, and then after that you have to create the autoscaling groups. So click on launch configuration, and then you have to click on create launch configurations. So click on create launch configuration. Now this launch configuration is basically the set of parameters that you define while launching an autoscaling, so that this uniformity is maintained with all the instances. So that includes, let's say if you select a Windows OS or a Linux OS, that particular type of an operating system will be implemented in all the instances that will be part of an autoscaling. So there are certain set of parameters that we have to specify during the launch configuration so that we can have a uniformity in terms of launching the servers. So here I would select an Amazon Linux AMI, and then I would select the type of a server, which will be t2.micro. Click on configure details, put the name to the launch configuration. Let's say we put it as a demo, and the rest of the things we'll keep it default. Click on add storage. Since it's a Linux AMI, we can go with the 8 GB storage. That should be fine. Click on configure security group. Let's create a new security group which has the SSH port open, and that is open for anywhere, which is basically source IPv4 and IPv6 IPs. Any IP would be able to access that. Click on review. Just review your launch configuration. If you want to make changes, you can do that. Otherwise, click on create a launch configuration. You would need the key pair, and this key pair will be a unique key pair which will be used with all the instances that are part of the autoscaling group. So we can select an existing key pair if you have that. Otherwise, you can create a new key pair. So I have an existing key pair. I'll go with that, acknowledge it, and click on create launch configuration. Now we have successfully launched the configuration of an autoscaling. The next thing is to create an autoscaling group. So click on create an autoscaling group using this launch configuration. Put a group name. Let's say we put something like test, and the group size to start with, it says one instance, so that means at least a single instance will always be running, and it will be initiated and running 24/7 till the autoscaling is available. You can increase the size of the minimum base instances also. Let's say you can change it to 2 also, so you would get at least 2 servers running all the time. So we'll go with the one instance. The network would be the VPC default, and in the VPC particular region we can select the availability zones. So let's say if I select availability zone 1A and then availability zone 1B. So how the instances will be launched? So one instance will be launched in 1A, the other one in the 1B, the third one in the 1A, fourth one in the 1B. Likewise, it will be equally spread among the availability zones. Next part is to configure the scaling policies. So click on it. If you want to keep this group at its initial size, let's say if you want to go with only a single instance or 2 instances and you don't want the scaling to progress, you can put it, keep this group at its initial size. So this is basically a way to halt the scaling. But we'll use the scaling policies to adjust the capacity of this group. So click on it. And we would scale between, let's say, minimum 1 instance that we have, and we'll scale it between 1 to 4 instances. And what condition, on what basis these instances will be scaled up or scaled down would be defined in the scale group size. So the scaling policies you can implement based on a scale group size or using the simple scaling policies using the steps. So in the scale group size, you have certain metrics. You can use average CPU utilization. You can define a metric related to average network in, average network out, or the load balancer request counts per target. And if you create the simple scaling policies using steps, then you need to create the alarms. And there you can get some more metrics that you can add up as a parameter for the auto scaling. Let's go with the scaling group size. Let's go with the metric type as average CPU utilization. And the target value here you have to specify what would be the threshold that when the instance CPU utilization is crossed, then a new instance should be initiated. So you can put a reasonable threshold for that. Let's say we put something like 85%. And whenever the instance CPU utilization is crossed 85% threshold, you will see that there will be a new instance created. Let's go to the next configure notifications. And here you can add notifications. So let's say if there is a new instance that is initiated and you want to basically be notified, so you can get notifications over your email IDs or you can get it on the cell phones. So for that, for adding the notification, you would need the SNS service that is called as a simple notification service. And you have to create a topic there. You have to subscribe for the topic using your email ID, and then you should get the notifications. Click on configure tags. The tags are not mandatory. You can basically put a tag. Let's say if you want to identify the instance or the purpose it was created. Otherwise, you can leave it blank also. Click on review and review your scaling policies, notification, tags, as well as the scaling group details. Click on create auto scaling group, and here you go. Your scaling has been launched. Click on close, and you should get at least a single instance initiated automatically by the auto scaling. So let's wait for the details to appear. So here you can see our launch configuration name, demo, auto scaling group name, test, minimum instance we want 1, the maximum instances we want 4. We have selected 2 availability zones, AP South 1A, AP South 1B, and the instance 1 has been initiated. And if you want to verify where exactly this instance has been initiated, just click on the instances here, and here you will see that our single instance has been initiated, that is in service, and that has been initiated in AP South 1B. Now once the threshold of this instance crosses 85%, that is what we have defined in the scaling policies, then you should see that another instance will be initiated. So likewise, this is basically I have created steps to initiate a scaling policy, that means to increase the number of servers whenever the threshold crosses. Likewise, here itself you can add another policy to scale down the resources in case if the CPU utilization goes to a normal value.
So what exactly is an AWS certification? It represents a degree of expertise in AWS. It is obtained after passing one or more exams provided by Amazon, and each different role, like the SysOps administrator, developer, or solutions architect, has a different exam associated with it. This in turn helps employees demonstrate and validate technical cloud knowledge, which means that the people who are certified actually know what they're talking about. I have seen a common misconception among people where they believe that just because they're certified, they're entitled to a job. That's not true. Now, without proper practice or hands-on experience, the certification is wasted on you. So remember, just because you're certified does not mean you'll get a job. It only makes the job application process slightly easier relative to someone who's not been certified. Now, why is AWS given so much importance? Some of the important reasons are: an AWS certified individual gains credibility for their skills in AWS. They also gain access to free practice exams which help them prepare for the next AWS certification. There's an increase in monetary compensations, which only means that they get paid more, and you gain recognition for your knowledge and skills in AWS. Right now we're in the AWS certification website, whose link will be in the description, and now we're going to talk about the types of AWS certification. As you can see here, there are 3 levels of AWS certification. There's the foundational level, associate level, and professional level certification. Now, the foundational level certification only requires you to have a basic understanding of how the AWS cloud works. Now, the AWS Certified Cloud Practitioner is optional for the architect path, developer path, and operations path. It is mandatory for the specialty certifications like the advanced networking, big data, and security certifications. Now, the associate level certifications are mid-level certifications for a technical role. Now, a professional certification is the highest level of certification that you can have for a technical role. Now, you have the solutions architect for the architect path and the DevOps engineer certification for both the developer and operations path. So how do you decide which of these certifications is suitable for you? So you've seen here that AWS provides various certifications for a number of job roles like SysOps administrator, solution architect, developer. So you need to make the right choice, taking into consideration the areas of your interest and the experience level that you have. Now we're going to talk about each of these certifications in detail. So first, let's talk about the AWS Certified Cloud Practitioner. Now we all understand that AWS is a widely recognized product in the market. So this certification helps you validate how well you know the AWS cloud. So this is just the basic understanding. Now, it is optional for the developer path and the operations path. I would suggest it's a good idea to start here because it forms a solid bedrock on all the other things that you're going to learn soon. Now, more importantly, it does not require any technical knowledge of other roles such as development, architecture, administration, and so on. So it's a great place to start for newcomers. Now you have the architect role certifications. Now, this is for you if you're interested in becoming a solutions architect or a solution design engineer or someone who just works with designing applications or systems on the AWS platform. Now, first we have the AWS Certified Solutions Architect Associate Level Certification. Now, this certification is for you if you want to show off how well you can architect and deploy applications on the AWS platform. Now, it is recommended that you have at least a year of experience working with distributed systems on the AWS platform. At the same time, it's also required that you understand the AWS services and be able to recommend a service based on requirements. You need to be able to use architectural best practices and you need to estimate the AWS cost and how you can reduce them. Next up, you have the AWS Certified Solutions Architect Professional Level Certification. Now, you will not get the certification unless you're done with the AWS Certified Solutions Architect Associate Level Certification. This is to show off your technical skills and experience in designing distributed applications on the AWS platform. Now, this does require you to have 2 years of experience working with cloud architecture on AWS. At the same time, it also requires you to be able to evaluate requirements and then make architectural recommendations. You also need to provide guidance on the best practices on architectural design across a number of different platforms. The developer level certifications are for you if you're interested in becoming a software developer. Now, the AWS Certified Developer Associate certification is to test how well you know how to develop and maintain applications on the AWS platform. It does require you to have a year or more of hands-on experience to design and maintain AWS-based applications. Like any software developer role, it is necessary that you know in depth at least one high-level programming language. It's also necessary that you understand the core of AWS services, uses, and basic architectural best practices. You need to be able to design, develop, and deploy cloud-based solutions on AWS platform, and you need to understand how applications can be created. You need to have experience in developing and maintaining applications for a number of AWS services like Amazon SNS, DynamoDB, SQS, and so on. Now for the AWS Certified DevOps Engineer Professional Level Certification. Note here that this certification is exactly the same as the one you have under the operations role. So both of them are the same thing. So here it tests your ability to create, operate, and manage distributed applications on the AWS platform. Now it is necessary or it is mandatory to have the AWS Certified Developer Associate certification or the AWS Certified SysOps Administrator certification with 2 or more years of hands-on experience in doing the same in AWS environment. It requires you to be able to develop code in at least one high-level language. You need to be able to automate and test applications via scripting and programming, and to understand agile or other development processes. The operation certifications are for you if you want to become a SysOps administrator, systems administrator, or someone in a DevOps role who wants to deploy applications, networks, and systems in an automatable and repeatable way. The AWS Certified SysOps Administrator Associate certification tests your knowledge in deployment, management, and operations on the AWS platform. Now, you need to have 1 or more years of hands-on experience in AWS-based applications. You need to be able to identify and gather requirements, then define a solution to be operated on AWS. You need to be able to provide guidance for the best practices through the life cycle of a project as well. Now, the specialty certifications are for you if you're well versed in AWS and want to showcase your expertise in other technical areas. The AWS Certified Big Data certification showcases your ability to design and implement AWS services which can help derive value from a large amount of complex data. You are, however, required to have completed the foundational or associate level certification before you can attempt this. You need a minimum of 5 years of hands-on experience in the data analytics field as well. Next, we have the AWS Certified Advanced Networking certification. This validates your ability to design and implement AWS solutions as well as other hybrid IT network architectures at scale. This also requires you to have completed the foundational or associate level certification. You need to have a minimum of 5 years of hands-on experience architecting and implementing network solutions. And lastly, we have the AWS Certified Security certification. It helps showcase your ability to secure the AWS platform. You're required to have an associate or cloud practitioner level of certification, a minimum of 5 years of IT security experience, and 2 years of hands-on experience securing AWS workloads. Now say I wanted to schedule an examination. So for example, I want to do the Solutions Architect certification. So first I would go there. Now here I can click on register now and the process continues, or I can click on learn more. By doing this, again I can schedule the examination here. I can also get access to other data like the number of questions available, the cost of an examination, the portions I need to study, and so on. Now let's talk about the Solutions Architect certification with a little more detail. Now this certification exam costs $150 and the practice exam costs $20. Now here I can schedule the examination or download the exam guide. I've already downloaded the exam guide and here it is. Now this exam guide tells you about what you need to learn and what is expected from you. Here they want you to define a solution based on requirements and provide guidance in its implementation. It is also recommended that you know about how the AWS services work, 1 year of hands-on experience with distributed systems on AWS to identify and define technical requirements and so on. The rest is available in the exam guide. And most importantly, they tell you the main content domains and their weightages. Now we have 5 domains. First domain is to design resilient architectures, which holds 34% of weightage. At domain 2, you have to define performant architectures. 3 is to specify secure applications and architectures, cost optimized architectures, and 5 to define operationally excellent architectures. Now, like you've seen here, you've selected one certification and learned it in detail. You can do the same for any of these other certifications. You can press learn more and download their exam guide and learn everything that you need to know. And welcome to the session on AWS certification. In this session, I'll be telling you about several things like why AWS is so important. Next, we'll talk about the job roles in AWS, the career path to become an AWS Solutions Architect, the certifications that are available in AWS, and companies that are hiring in 2020. Also guys, if you have any questions regarding the topic or AWS, let us know in the comment section below. Our team of experts will help you as soon as possible. Now, before we get on to this, let's talk about why or what exactly is AWS. AWS or Amazon Web Services is a cloud computing platform that offers more than 175 different services across several domains. Now, among the several cloud service providers in the market right now, like Microsoft Azure, VMware, Rackspace, and so on, AWS is more commonly used than any of its competitors. But what makes AWS so special? Why must you get certified by them? So to answer our earlier question, let's have a look at 2019's third quarter's cloud market share, which is provided by Canalys. Now, AWS dominated the cloud service market share with 32% of the entire share. And it had a growth of over $2.3 billion year over year. Now you can see in the graph here that Azure and GCP only account for 17% and 7% respectively. The others like Rackspace and IBM Cloud are contributing 44%. Now, if you do need more convincing as to choosing AWS, let me give you more reasons why. Firstly, it provides pay-as-you-go pricing, which means you only pay for how much you use. Now you use what you need, and then the costs are scaled automatically and accordingly. Now, for example, say you use EC2, which provides virtual machines. You only use for how much virtual machines you've created and how long you use them. AWS is also very secure. Now, this provides end-to-end privacy and security and storage. AWS also has experience. Now, AWS has over 4 years of leg up over other cloud service providers like Microsoft Azure. This means over the years, they have skills and infrastructure management that can give you more. Next, AWS is also very flexible. This allows users to select their operating system, language, database, and other services with great ease. AWS is also very easy to use. You can host your applications very quickly. and securely, whether it's existing or a completely new application. AWS is also extremely scalable. Now, if you're a small scale company, you don't need a lot of resources. AWS understands that and scales down. If you're a larger organization, obviously you're going to need a lot more resources. AWS can help with that as well. Now, let's talk about the job roles within AWS. Now, here are some of them. These aren't all of them, but we have AWS Cloud Architect, SysOps Administrator, Cloud Developer, System Integrator, Cloud DevOps Engineer, Solutions Architect, Network Specialist, and Big Data Specialist. Now, getting each of these roles becomes much easier when you're certified by AWS. Now, let's talk about the steps you need to take so that you can become an AWS Solutions Architect. Now, we're selecting this one because this is one of the most common and talked about job roles in AWS. Now, most of the job roles I mentioned earlier have similar steps, but with a few steps added or removed somewhere else. Now, first off, you need an understanding of operating systems. You'll need to have a basic understanding of operating systems like Windows or Linux. Now, although this isn't exactly mandatory, this will help you understand cloud services better since most of them are based on Linux. Next up, you need to have experience with programming languages. Languages like SQL, Go, Python, C#, .NET, and so on will help you develop cloud-based applications based on requirements from your organization. Now, although this isn't mandatory either, some services do require coding so that you can use them properly. In the next step, we have networking. You need to understand networking fundamentals like virtual networks, local area networks, wide area networks, networking models, and so on. Now, this is really important because this will help you understand how the back-end infrastructure of the cloud works. After that, the most self-explanatory step, learn AWS. Now, you need to focus on learning the different services that are offered by AWS. Now, AWS provides a year-long free tier where you get access to several important services like EC2 and S3. So you can use it to get practical experience with these services. Now you can decide among several different career paths that are offered by AWS. Paths like Cloud Practitioner, Cloud Architect, Cloud Developer, Operations, DevOps Engineer, and some others. And finally, you need to be certified by AWS. You need to choose from different levels of certification that are provided by AWS. These can help you showcase your proficiency in working with different AWS solutions. Now let's talk about certifications available in AWS. Now, as you can see on screen, there are 3 levels. 4 actually. Firstly, you have foundational level certification that includes the Cloud Practitioner certification. Now for this, you need to have 6 months of basic cloud knowledge and industry knowledge as well. So basically, the Cloud Practitioner certification acts as the starting point for just about every other job role you want to take, be it architect, operational, or developer. Then in associate, you need to have a year of experience working with AWS Cloud, solving solutions and implementing solutions. You have options for solutions architect, SysOps administrator, developer, and so on. And finally, you have professional level certification. Now, after 2 years of experience with the AWS Cloud, you can take up this certification. You have options of Solutions Architect Professional and DevOps Engineer Professional. Now, there are certain specialty certifications that are provided by AWS. These are based on advanced networking, big data, security, machine learning, and Alexa Skill Builder. Now, let's have a look at AWS's website. Let's go to Google, search for AWS certification. And here you can see that, like I told you, here are the certifications. Let's go to the bottom here. And you can see that here all the certifications that I mentioned are divided into different levels. Like I told you, Cloud Practitioner, Architect, Developer, Operations, and DevOps Engineer. Let's have a look at Cloud Practitioner. So here you can see the steps you need to take to become a Cloud Practitioner. Now, AWS suggests that you take up their course and then follow it up by taking their certification test. Now similarly, let's have a look at how to become an AWS Cloud Architect. You can select the link here. So like we saw with Cloud Practitioner, they give you a set of courses you need to take, followed up by a certification test. Basically, you need to first get the associate level certification and then move on to the professional level certification after you've gotten some experience and knowledge. Similarly, you can look at other job roles like developer, very similar, and operations. Likewise, everything else you can see here. Now let's go back and talk about the companies that are hiring in 2020. So this is basically every company that's hiring in 2020. So you have examples like IMDb, Lamborghini, Adobe, Bitdefender, HTC, and so much more. This is just the tip of the iceberg. Hi guys, this is Rahul from Simplilearn, and today I'm going to tell you how you can become an AWS Solutions Architect. So who is an AWS Solutions Architect? Now, the main role of an AWS Solutions Architect is to help you deploy your applications on the AWS platform. Now, this is nothing but a cloud computing platform. So it's not to say that you can't deploy your applications on the cloud computing platform yourself. It's just that when it comes to organizations, the applications that you need to deploy become a whole lot more complex. That's where an AWS Solutions Architect can help. Ever since cloud computing became a thing, companies around the world have started migrating their physical infrastructure onto the cloud. That's what an AWS Solutions Architect does. They help you migrate your physical infrastructure onto the AWS cloud. Companies around the world work on a budget, and an AWS Solutions Architect will help design a cloud infrastructure based on the organization's budget. Before that can be done, however, an AWS Solutions Architect has to create a design with an intricate and detailed blueprint of the cloud infrastructure that they plan to set up. Now, AWS Solutions Architects also have to focus mainly on non-functional requirements like usability, reliability, scalability, and performance of the cloud infrastructure. They're also responsible when it comes to minimizing risks that an organization can face when it comes to cloud computing platforms. Now, they could face risks like security leaks, calculation mistakes, and application downtimes. An AWS Solutions Architect has to ensure that these don't happen. Before we can talk about how you can become an AWS Solutions Architect, I have some exciting news for you guys. We've launched our own YouTube community. You'll get to see a lot of quizzes, polls, offers, and much more to make your learning experience a whole lot more fun. You can find all of this on your subscription feed, or you can also click on the top right corner right now to get started. And let's get back to how can you become an AWS Solutions Architect. Now, to become an AWS Certified Solutions Architect, you need to clear the AWS Certified Solutions Architect Associate Level Examination. Now, here's some details about it. The exam score ranges from 100 to 1000 marks, and the minimum passing score is 720. However, there's a catch. The passing marks are actually set using statistical analysis, so they can be changed based on how difficult the examination actually is. The exam fee is $150, and you can also take a practice examination which costs $20. Now, regardless of the examination you take, be it Solutions Architect, SysOps Administrator, or Developer, any associate level examination costs $150. For the professional level examination, it's $300. Now, if you want to learn more about the AWS certifications, I suggest you click on the top right corner and watch our video AWS certifications in 10 minutes to learn more. Now, the exam duration is of 130 minutes, and you have two types of questions, multiple choice and multiple answer. Now, the multiple choice questions have 4 options, out of which one of them is right, and you have multiple answer where you have 5 options, out of which 2 of them are correct. You can take the examination in English, Japanese, Korean, and simplified Chinese. Now, let's talk about how you can schedule an examination. First, let's go to Google and search for AWS certifications. Click on the first link. So on this page, we can go to the bottom and find the different certifications AWS provides. Click on Architect and select the AWS Certified Solutions Architect Associate certification. Click on Register Now. And here you need to click on the AWS certification account. You can sign in with your Amazon account or create a new one. I already have an Amazon account that I'll be using for signing in here. In case you don't, you can click on the Create Your Amazon Account button here and create an account for yourself. Now after that is done, you can schedule new examination. And you can scroll down to the bottom. Here, AWS Certified Solutions Architect Associate Level Certification. Click on Schedule Exam. Press Continue. And here you need to select your language, which I'm assuming is English. I'm from India, so I don't need to change anything here, but you can change your country or time zone and other details based on your requirement. And select your preferred month. I want to do it in October. Now select Search for Exam Center. Select the one that's closest to you. I'm going to select this one. And here you can select the day that you want to take your test and the time available. I want to do it on the 15th. I select the time that I want and press Continue. Now you can go through all the details here, change them if you want to, otherwise you can press Continue. After this is done, close. And here we have the final step, which is the fees. You can enter your details here and pay now to finish the process. Now let's look at an outline of the exam content. Now what you're going to see in the exam are 5 major domains, and here you have each of the domains with their respective weightages. First you have at 34% designing resilient architectures. At 24% you have both defining performant architectures and specifying secure applications and architectures. At 10% you have designing cost optimized architectures, and at 6% you have defining operationally excellent architectures. Now let's look at each of these domains in detail. Now the first domain, or design resilient architectures, can be divided into 4 parts. Firstly, you need to know how you can choose reliable or resilient storage using services like AWS S3, AWS Glacier, and AWS EBS. Then you have how you can design decoupling mechanisms using AWS services. Now this is possible with the help of AWS SNS. Now these aren't the only services that enable this, these are just some of the services. Then how you can design a multi-tier architecture solution. Now this is important because you need to know how you can create a solution that involves several other services. Then you need to know how you can design highly available and fault-tolerant architectures. Now for the second domain, defining performant architectures. First, you have how to choose performance storages and databases. Services that are used are AWS RDS, AWS Redshift, and AWS DynamoDB. The second step is how you can apply caching to improve performance. A service that can be used for this is AWS Elastic Cache. Third, how you can design solutions with elasticity and scalability. You have AWS Lambda, AWS CloudWatch, and AWS Data Pipeline. Now, for the third domain, which is specifying secure applications and architectures, you need to know how you can secure applications using services like AWS Inspector, AWS CloudTrail, and AWS IAM. You need to know how to secure data using Cloud HSM and AWS Macie, and how you can define the networking infrastructure using CloudFront, VPC, and Elastic Load Balancer. For the fourth domain, you have designing cost-optimized architectures. Firstly, you need to know how you can design cost-optimized compute solutions. You can use AWS EC2, Elastic Beanstalk, Lambda, and AWS Lightsail. Then you need to know how you can design cost-optimized storage solutions using AWS S3, Glacier, EBS, and Elastic File System. And the final domain, to define operationally excellent architectures. You need to set up design features and solutions that enable operational excellence. Now, some of the features are that you perform operations as code, you annotate documentation, you make frequent and small reversible changes, and anticipate and tackle failures. Now, let's have a look at the job opportunities when it comes to AWS Solutions Architects. Now, if you have a look at this graph, you can see that AWS has always provided a lot more job postings as compared to the other two giants in the cloud computing domain, which are Microsoft Azure and Google Cloud Platform. Now, if you do a little bit of research, you'll find out that there's a significant lacking of experienced personnel when it comes to AWS. So I would suggest this is the best time for you to get certified in AWS. So how can Simplilearn help you with your AWS certifications? Now we're on the Simplilearn homepage. And here we have the AWS Solutions Architect course. On this course, which is the AWS Solutions Architect Certification Training course, we have 36 hours of instructor-led training, 20 hours of self-paced learning, 16 live demos, 3 simulation exams, 3 hands-on practice projects, and so much more. Here, our main emphasis is on making sure that you have enough hands-on experience with the services that you crack the examination at your first attempt. So here we also go through some of the more important services that you need to learn, like IAM, VPC, EC2, S3, and so much more. We'll also talk about databases, application services, security practices, disaster recovery, and so on. We even have practice examinations to help you prepare.
Video by Simplilearn. Today, I am going to help you understand how to pass the AWS Cloud Practitioner exam. So, let's get started. Before we get started, let us look at today's agenda. First, we will go through what is AWS Cloud Practitioner and its eligibility criteria. Then we will go through the exam objectives and its exam content. Further, we will learn how to prepare for the exam and look at a few sample questions. And finally, we will learn a few tricks related to the exam. Now, what is AWS Cloud Practitioner? AWS has a variety of certifications. Under foundational level comes AWS Cloud Practitioner. Going up, we can achieve professional and advanced level certificates. AWS gives a variety of specialty certificates, which is something very unique. It is a foundational level certificate provided by AWS. It requires 6 months of AWS Cloud and industry knowledge. Becoming an AWS Certified Cloud Practitioner is recommended. It is an optional step towards achieving an associate level or specialty certification. With the Cloud Practitioner certificate, you can get a job as a cloud engineer or AWS practitioner in many companies. Now, let us talk about the eligibility criteria. Every exam has its own eligibility. In order to take this certification, the candidate must follow 2 important criteria. First, he should have at least 6 months of experience working with AWS Cloud Concepts in various roles like technical, sales, and finance. Next, it is mandatory for him to have knowledge of the AWS Cloud Platform and its working. Also, he should know about the various IT services. Now, let's talk about the exam overview. The exam duration is 90 minutes. The candidate should get 65% of the answers right in order to pass the exam. The question types are multiple choice and multiple response questions. The cost of this exam is $100. Every certificate is valid for a few months or years. AWS Cloud Practitioner is valid for 2 years. After 2 years, this certificate needs to be renewed, as in, the exam needs to be taken again. Let's get into the exam objectives now. The AWS Cloud Practitioner validates the candidate's strength in various domains. First, he should be able to explain the cloud knowledge and its platform. He should know how to manage the account. He should know about the billing and pricing details. The candidate should have knowledge of key services available on the AWS Cloud Platform. The candidate should be able to explain the various cloud values. The candidate should be able to explain security concepts, security model, and compliance concepts. The candidate should recognize the main sources of technical assistance or documentation. The candidate must be able to explain the key features of operating and deploying in AWS Cloud. And finally, he should be able to explain the cloud architecture and its basic principles. In order to excel in this exam, we should know the topics that occur in the exam. So, let's take a look at the exam content. The exam has 4 major domains, namely cloud concepts, security and compliance, technology, and billing and pricing. The pie chart indicates the weightage of each domain in the exam. The cloud concepts contain 28% of the total exam content. Security and compliance contains 24% of the exam content. Technology has the maximum weightage of 36% of the total exam content, and billing and pricing has the lowest weightage of 12% of the entire exam content. Now, let's dive deep into each of these technologies. First comes cloud concepts. In this, you need to have some basic knowledge of cloud computing concepts. Questions asked from this field are broad enough. So to perform well, you must have high-level cloud concepts which include elasticity, scalability, high availability, and fault tolerance. Next, we have security and compliance. Security is marked as an important topic of whether you are working with infrastructure or not. This certification exam includes a variety of questions related to security and culpable management. You may find some important topics regarding this domain in your exam as follows: shared security model, cloud logs, DDoS protection, and IAM, that is, managing users, password policies, and MFA. The next domain is technology. Technology is the most important domain of the AWS Cloud Practitioner exam.
If you want to adapt in this section, then you should have the knowledge of core AWS services. Some of the AWS services that you must know are EC2, ELB, RDS, S3, SNS, and AWS Lambda. And finally, we have billing and pricing. The AWS Certified Cloud Practitioner exam concentrates on the business applications of AWS. Billing and pricing becomes important topics that we should know. You must have knowledge of general account information, AWS support, how certain services are built, how to calculate the cost of services, and using what tools, etc. There may be some questions which overlap with other exam domains. Example, AWS Cost Calculator service may fall into billing and pricing domain as well as technology domain. Now that we know the domains, let's go ahead and see how to prepare for the exam. The first thing is we have to start off with the AWS training classes. The following 3 AWS training courses will help you pass the exam. That is AWS Cloud Practitioner Essential, AWS Technical Essentials, and AWS Business Essentials. Moving forward, the next step is to read the AWS Certified Cloud Practitioner Certification Exam Guide. This guide would give an idea about the essential areas that needs to be concentrated on. It provides an overview of all the exam objectives with preparation instructions. The next step is to get familiar with the subject areas. Before taking any exam, knowing the subject areas is very important. The exam content has been explained before, so review the subject areas carefully, plan and prepare how to attempt the test accordingly. Moving forward, we have to go through the AWS white papers. These white papers contain useful information and cover many important topics. Some of the popular AWS white papers are Overview of AWS, how AWS pricing works, maximizing value with AWS, and many more. Self-study is enough to pass the certification exam. The online training will help you understand the subject areas. A lot of material can be found on the AWS website. Also, read the facts related to the AWS cloud services, applications, and moreover architecture. The next important step is to examine sample questions and take free tests. To ace the exam, a practice test is always necessary to see where you stand and what subjects you need to concentrate on. AWS has many practice tests and you can take them before the exam. The final step is to schedule the exam and get certified. So once you're prepared well enough, then enroll for the exam, choose any testing center near you at AWS training website and register yourself. Going forward, let's look at few of the sample questions that AWS website has. So all these questions are present under the AWS website, so you can go through them. Now, the first question is, why is AWS more economical than traditional data centers for applications with varying computing workloads? So you can see the answer choices on the screen. The correct answer is Amazon EC2 instances can be launched on demand when needed. The next question is, which AWS service would simplify migration of a database to AWS? The choices are AWS Storage Gateway, AWS Database Migration Service, Amazon Elastic Compute Cloud, Amazon AppStream 2.0. So the correct answer is AWS Database Migration Service. The next question is, which AWS offering enables customers to find, buy, and immediately start using software solutions in the AWS environment? So you can see the answer choices on the screen. The correct answer is AWS Marketplace. Which AWS networking service enables a company to create a virtual network within AWS? The choices are AWS Config, AWS Route 53, AWS Direct Connect, Amazon Virtual Private Cloud. The correct answer is Amazon Virtual Private Cloud. Which of the following is AWS's responsibility under the AWS Shared Responsibility model? So the options are configuring third-party applications, maintaining physical hardware, securing application access and data, managing custom Amazon machine images. So the correct answer is maintaining physical hardware. The sixth question is, which component of AWS global infrastructure does Amazon CloudFront use to ensure low latency delivery? The choices are AWS Regions, AWS Edge Locations, AWS Availability Zone, Amazon Virtual Private Cloud. The correct answer is AWS Edge Locations. So the seventh question is, how would a system administrator add an additional layer of login security to a user's AWS Management Console? The answer choices are use AWS Cloud Directory, audit AWS Identity and Access Management roles, enable multi-factor authentication, enable AWS CloudTrail. So the correct answer is to enable multi-factor authentication. The next question is, which service can identify the user that made the API call when an Amazon Elastic Compute Cloud instance is terminated? So the options are Amazon CloudWatch, AWS CloudTrail, AWS X-Ray, AWS Identity and Access Management. The correct answer is AWS CloudTrail. The next question is, which service would you use to send alerts based on Amazon CloudWatch alarms? The options are Amazon Simple Notification Service, AWS CloudTrail, AWS Trusted Advisor, Amazon Route 53. The correct answer is Amazon Simple Notification Service. And finally, the last question is, where can a customer find information about prohibited actions on AWS infrastructure? So the correct answer for this is AWS Acceptable Use Policy. So you can see we get sample questions like these. You can go through the website and see all the other preparation and exam guides you need. Finally, the last topic in this video is the tips while taking the exam. Since the time is limited, wasting time on difficult questions is unavoidable. The next tip is to keep a track of time and learn how to manage time to answer all the questions. Third one is analyze the questions first and then answer, because sometimes they may be traps. And finally, as per the guidelines, some questions may have multiple answers, so read the questions properly.
There are over 18 million jobs in the field of cloud computing globally. Simplilearn's AWS Certified Solution Architect Associate Level course will help you understand the key concepts required to prepare for the certification exam. The practice assignments and the 3 live projects, this course comprises of 24 hours of instructor-led training, 15 hours of e-learning, over 50 demonstrations to understand architecting through the AWS console, and you will also be provided with 3 question sets totaling 180 questions. The worldwide cloud computing market grew 28% to $110 billion in revenues in 2015. In the last quarter of 2015, AWS revenue was up 69% year on year. AWS Solutions Architect Associate Level is the perfect certification to start your journey with AWS. You'll enhance your existing knowledge of AWS and will deepen your understanding of every product and service that AWS offers. You will learn how to design, plan, and scale in the AWS cloud using Amazon recommended best practices. With the certification, you'll be an asset to any organization, helping it to leverage the benefits of best practices around advanced cloud-based solutions and migrate existing workloads to the cloud. Whether you're looking to future-proof your career or just prove your know-how about the leading cloud provider in the global market, becoming an AWS Solutions Architect Associate will put you well on your way to achieving your career goals. You can reach out to our teaching assistant support staff anytime during the course and for assistance with projects. Candidates can submit their queries at help and support on our website, or they can get connected with our staff using SimplyTalk and the live chat options. This concludes the course introduction, and we hope you're all geared up to begin the AWS Solutions Architect Associate Level course. Happy learning!
Hello and welcome to the introductory video of the AWS SysOps Administrator Associate Level course offered by Simplilearn. In this video, you will get to know some of the interesting facts about AWS, get a brief overview about the course, and know how the certification can help your career. Amazon Web Services provides a highly reliable, scalable, low-cost infrastructure platform in the cloud that powers hundreds of thousands of businesses in 190 countries around the world. The worldwide cloud computing market grew 28% to $110 billion in revenues in 2015. In the first quarter of 2016, Amazon Web Services, or AWS, revenue was up by 58%. The certification holder takes home an average salary of $125,871, up from $114,935 last year. According to Forbes, there are over 18 million jobs in the field of cloud computing globally. AWS SysOps Administrator Associate is the perfect certification to prove your technical expertise in deploying, managing, and operating scalable, highly available, and fault-tolerant systems on AWS platform. You'll enhance your existing knowledge of AWS so you can select the appropriate products and tools to leverage AWS in the most efficient and cost-effective way. You'll learn how to implement and control the flow of data to and from AWS, and also be able to estimate AWS usage costs and identify operational cost control mechanisms. With the certification, you will be an asset to any organization, helping it to leverage the benefits of best practices around advanced cloud-based solutions and migrate on-premises applications to AWS. Simplilearn's AWS SysOps Administrator Associate level course will help you understand the key concepts required to prepare for the certification exam. Before diving into the course details, let us get a glimpse of all the interesting ways you get to learn about AWS. Delve into the various AWS services. Work with AWS Management Console. Learn the CLI commands. Validate your knowledge. The practice assignments and the 3 live projects are included especially for you to gain hands-on experience with AWS Management Console and the CLI to become a domain expert in building, deploying, and managing systems in AWS. This course comprises 24 hours of instructor-led training, 15 hours of e-learning, and 3 hours of demonstrations to understand technical details associated with data management, networking, security, and more. You will also be provided with 3 question sets, totaling 180 questions to validate the depth of your knowledge. Learning path. This certification also serves as a prerequisite for the AWS DevOps Engineer Professional Exam. Whether you are looking to future-proof your career or enhance your know-how about the leading cloud provider in the global market, becoming an AWS SysOps Administrator Associate will put you well on your way to achieving your career goals. You should ideally be an IT professional with experience in both traditional IT infrastructure and the AWS platform. You should have experience in everyday operations of a system administrator, which include deployment of the IT systems, backups, OS management, and have some experience with the AWS platform. You can reach out to the Teaching Assistant support staff anytime during the course and for assistance with projects. You can submit your queries at Help and Support on our website, or get connected with our staff using SimplyTalk and live chat options. This concludes the course introduction, and we hope you are all geared up to begin the AWS SysOps Administrator Associate level course. Let's get started with the first lesson, monitoring and metrics. Happy learning!
Hi there, I'm Samuel, and I'm here to walk you through some of the AWS interview questions which we find are important, and our hope is that you would use this material in your interview preparation and be able to crack that cloud interview and step into your dream cloud job. By the way, I'm a cloud technical architect, trainer, and an interview panelist for cloud, network, and DevOps. So as you progress in watching, you're going to see that these questions are practical scenario-based questions that tests the depth of the knowledge of a person in a particular AWS product or in a particular AWS architecture. So why wait? Let's move on. All right, so in an interview, you would find yourself with a question that might ask you, define and explain the 3 basic types of cloud services and the AWS products that are built based on them. See, here, it's a very straightforward question. Just explain 3 basic types of cloud service. And when we talk about basic type of cloud service, it's compute, obviously, that's a very basic service. Storage, obviously, because you need to store your data somewhere. And networking, that actually connects a couple of other services to your application. These basic will not include monitoring. These basic will not include analytics because they are considered as optional. They are considered as advanced services. You could choose a non-cloud service or a product for monitoring and for analytics. So they're not considered as basic. So when we talk about basics, they are compute, storage, and networking. And the second part of the question says, explain some of the AWS products that are built based on them. Of course, compute EC2 is a major one. That's the major share of the compute resource. And then we have platform as a service, which is Elastic Beanstalk. And then function as a service, which is Lambda. Autoscaling and Lightsail are also part of compute services. So the compute domain, it really helps us to run any application, and the compute service helps us in managing the scaling and deployment of an application Again, Lambda is a compute service, so the compute service also helps in running event-initiated stateless applications. The next one was storage. A lot of emphasis is on storage these days, because if there's one thing that grows in a network on a daily basis, that's storage. Every new day we have new data to store, process, manage. So storage is again a basic and an important cloud service, and the products that are built based on the storage services are S3 object storage, Glacier for archiving, EBS Elastic Block Storage as a drive attachment for the EC2 instances, and EFS file share for the EC2 instances. So the storage domain helps in the following aspects. It holds all the information that the application uses, so it's the application data. And we can also archive old data using storage, which would be Glacier, and any object files and any requirement for block storage can be met through Elastic Block Store and S3, which is again an object storage. Talking about networks, it's just not important to answer the question with the name of the services and the name of the product. It'll also be good if you could go in depth and explain how they can be used, right? So that actually proves you to be a person knowledgeable enough in that particular service or product. So talking about networking domain, VPC, networking, can't imagine networking without VPC. In a cloud environment, especially in AWS cloud environment. And then we have Route 53 for domain resolution or for DNS. And then we have CloudFront, which is an edge caching service that helps customers to read their application with low latency. So networking domain helps with some of the following use cases. It controls and manages the connectivity of the AWS services within our account. And we can also pick an IP address range. If you're a network engineer, or if you are somebody who works in networks or are planning to work in network, you will soon realize the importance of choosing your own IP address for easy remembering. So having an option to have your own IP address in the cloud, own range of IP address in the cloud, it really helps, really helps in cloud networking. The other question that gets asked would be the difference between the availability zone and the region. Actually, the question generally gets asked so to test how well you can actually differentiate and also correlate the availability zone and the region relationship, right? So a region is a separate geographic area like the US West 1, which represents North California, or the AP South, which represents Mumbai. So regions are a separate geographic area. On the contrary, availability zone resides inside the region. You shouldn't stop there, you should go further and explain about availability zones. And availability zones are isolated from each other, and some of the services will replicate themselves within the availability zone. So availability zone does replication within them, but regions, they don't generally do replication between them. The other question you could be asked is, what is autoscaling? What do we achieve by autoscaling? So in short, autoscaling, it helps us to automatically provision and launch new instances whenever there is an demand. It not only helps us meeting the increasing demand, it also helps in reducing the resource usage when there is low demand. So autoscaling also allows us to decrease the resources or resource capacity as per the need of that particular hour. Now, this helps business in not worrying about putting more effort in managing or continuously monitoring the server to see if they have the needed resource or not, because autoscaling is going to handle it for us. So business does not need to worry about it. And autoscaling is one big reason why people would want to go and pick a cloud service, especially an AWS service. The ability to increase and shrink based on the need of that hour. That's how powerful is autoscaling. The other question you could get asked is, what's geo-targeting in CloudFront? Now we know that CloudFront is caching, and it caches content globally in the Amazon caching service global wide. The whole point is to provide users worldwide access to the data from a very nearest server possible. That's the whole point in using or going for CloudFront. Then what do you mean by geo-targeting? Geo-targeting is showing customer and specific content. Based on language, we can customize the content. Based on what's popular in that place, we can actually customize the content. The URL is the same, but we could actually change the content a little bit, not the whole content, otherwise it would be dynamic, but we can change the content a little bit, a specific file or a picture or a particular link in a website, and show customized content to users who will be in different parts of the globe. So how does it happen? CloudFront will detect the country where the viewers are located, and it will forward the country code to the origin server. And once the origin server gets the specialized or a specific country code, it will change the content and it will send to the caching server, and it gets cached there forever. And the user gets to view a content which is personalized for them for the country they are in. The other question you could get asked is the steps involved in using CloudFormation or creating a CloudFormation or backing up an environment with a CloudFormation template. We all know that if there is a template, we can simply run it and it provisions the environment, but there is a lot more going into it. So the first step in moving towards infrastructure as a code is to create the CloudFormation template, which as of now supports JSON and YAML file format. So first create the CloudFormation template and then save the code in an S3 bucket. S3 bucket serves as the repository for our code, and then from the CloudFormation call the file in the S3 bucket and create a stack. And now CloudFormation uses the file, reads the file, understands services that are being called, understands the order, understands how they are connected with each other. CloudFormation is actually an intelligent service. It understands the relation. Based on the code, it would understand the relationship between the different services, and it would set an order for itself and then would provision the services one after the other. Let's say a service has a dependency, and the dependent service, the other service which this service, let's say service A and B, service B is dependent on service A, let's say. CloudFormation is an intelligent service. It would provision the resource A first and then would provision resource B. What happens if we inverse the order? If we inverse the order, resource B first gets provision, and because it does not have dependency, chances that the CloudFormation's default behavior is that if something is not provisioned properly, if something is not healthy, it would roll back. Chances that the environment provisioning will roll back. So to avoid that, CloudFormation first provisions all the services that has or that's dependent on, that's depended by another service. So it provisions those services first and then provisions the services that has dependencies. And if you're being hired for a DevOps or if the interviewer wanted to test your skill on systems side, this definitely would be a question in his list. How do you upgrade or downgrade a system with near zero downtime? Now everybody's moving towards zero downtime or near zero downtime. All of them want their application to be highly available. So the question would be, how do you actually upgrade or downgrade a system with near zero downtime? Now we all know that I can upgrade an EC2 instance to a better EC2 instance by changing the instance type, stopping and starting. But stopping and starting is going to cause a downtime, right? So you should be answering, or you should be thinking in those terms, because that's a wrong answer. Specifically, the interviewer wants to know, how do you upgrade a system with zero downtime? So upgrading system with zero downtime, it includes launching another system parallelly with the bigger EC2 instance type, with the bigger capacity, and install all that's needed. If you're going to use an AMI of the old machine, well and good. You don't have to go through installing all the updates and installing all the application. From the AMI, once you've launched it in a bigger instance, locally test the application to see if it is working. Don't put it on production yet. Test the application to see if it is working. And if the application works, we can actually swap. If your server is behind Route 53, let's say, all that you could do is go to Route 53, update the information with the new IP address of the new server, and that's going to send traffic to the new server now. So the cutover is handled. Or if you're using static IP, you can actually remove the static IP from the old machine and assign it to the new machine. That's one way of doing it. Or if you are using Elastic NIC card, you can actually remove the NIC card from the old machine and attach the NIC card to the new machine. So that way we would get near zero downtime. If you're hired for an architect level, you should be worrying about cost as well, along with the technology. And this question would test how well you manage cost. So what are the tools and techniques we can use in AWS to identify and know that we are paying the correct amount for the resources that we are using? Or how do you get a visibility of your AWS resources running? One way is to check the billing. There's a place where you can check the top services that were utilized. It could be free and it could be paid service as well. Top services that can be utilized. It's actually in the dashboard of the cost management console. So that table here shows the top 5 most used services. So looking at it, you can get it. All right, so I'm using a lot of storage. I'm using a lot of EC2. Why is storage high? You can go ahead and try to justify that, and you will find if you are storing things that shouldn't be storing, and then clean it up. Why is compute capacity so high? Why is data transfer so high? So if you start thinking in those levels, you'll be able to dig in and clean up unnecessary and be able to save your bill. And there are cost explorer services available which will help you to view your usage pattern or view your spending for the past 13 months or so, and it will also forecast for the next 3 months. Now, how much will you be using if your pattern is like this? So that will actually help and will give you a visibility on how much you have spent, how much you will be spending if the trend continues. Budgets are another excellent way to control cost. You can actually set a budget. All right, this is how much I am willing to spend for this application, for this team, or for this month, for this particular resource. So you can actually put a budget mark, and anytime it exceeds, anytime it's nearing, you would get an alarm saying that, well, we're about to reach the allocated budget amount, stuff like that. That way you can go back and know, and you know that how much the bill is going to be for that month, or you can take steps to control bill amount for that particular month. So AWS budget is another very good tool that you could use. Cost allocation tags helps in identifying which team or which resource has spent more in that particular month. Instead of looking at the bill as one list with no specifications into it and looking at it as an expenditure list, you can actually break it down and tag the expenditure to the teams with cost allocation tags. The dev team has spent so much. The production team has spent so much. The training team has spent more than the dev and the production team. Why is that? Now, you'll be able to think in those levels only if you have cost allocation tags. Now, cost allocation tags are nothing but the tags that you would put when you create a resource. So for production services, you would put as a production tag, you would create a production tag and you would associate that resources to it. And at a later point, when you actually pull up your bill, that's going to show a detailed list of this is the owner, this is the group, and this is how much they have used in the last month. And you can move forward with your investigation and encourage or stop users using more services with the cost allocation tags. The other famous question is, are there any other tools or is there any other way of accessing AWS resource other than the console? Console is GUI, right? So in other words, other than GUI, how would you use the AWS resource and how familiar are you with those tools and technologies? The other tools that are available that we can leverage and access the AWS resource are, of course, PuTTY. You can configure PuTTY to access the AWS resources, like log into an EC2 instance. An EC2 instance does not always have to be logged in through the console. You could use PuTTY to log into an EC2 instance, and like the jump box, like the proxy machine, and like the gateway machine. And from there, you can actually access the rest of the resources. So this is an alternative to the console. And of course, we have the AWS CLI in any of the Linux machines or Windows machines we can install. So that's 8.2, 3 and 4. We can install AWS CLI for Linux, Windows, also for Mac. So we can install them, and from there, from your local machine, we can access, run AWS commands and access, provision, monitor the AWS resources. The other ones are we can access the AWS resource programmatically using AWS SDK and Eclipse. So these are a bunch of options we have to use the AWS resource other than the console. If you're interviewed in a company or by a company that focuses more on security and want to use AWS native services for their security, then you would come across this question. What services can be used to create a centralized logging solution? The basic services we could use are CloudWatch logs, store them in S3, and then use Elasticsearch to visualize them, and use Kinesis to move the data from S3 to Elasticsearch. Right. So log management, it actually helps organizations to track the relationship between operational and security changes and the events that got triggered based on those logs. Instead of logging into an instance or instead of logging into the environment and checking the resources physically, I can come to a fair conclusion by just looking at the logs. Every time there's a change, the system would scream and it gets tracked in the CloudWatch, and then CloudWatch pushes it to S3. Kinesis pushes the data from S3 to Elasticsearch, and I can do a time-based filter, and I would get a fair understanding of what was going on in the environment for the past 1 hour or whatever the time window that I wanted to look at. So it helps in getting a good understanding of the infrastructure as a whole. All the logs are getting saved in one place, so all the infrastructure logs are getting saved in one place, so it's easy for me to look at it in an infrastructure perspective. So we know the services that can be used, and here are some of the services and how they actually connect to each other. It could be logs that belongs to one account, it could be logs that belongs to multiple accounts. It doesn't matter, those three services are going to work fairly good, and they're going to inject or they're going to suck logs from the other accounts, put it in one place and help us to monitor. So as you see, you have CloudWatch here that actually tracks the metrics. You can also use CloudTrail if you want to log API calls as well, push them in an S3 bucket. So there are different types of log. Flow logs are getting captured in an instance. Application logs are getting captured from the same VPC, from a different VPC, from the same account, from a different account. And all of them are analyzed using Elasticsearch using the Kibana client. So step 1 is to deploy the ECS cluster. Step 2 is to restrict access to the ECS cluster because it's valid data. You don't want anybody to put their hands and access their data. So restrict access to the ECS dashboard. And we could use Lambda also to push the data from CloudWatch to the Elasticsearch domain. And then Kibana is actually the graphical tool that helps us to visualize the logs instead of looking at log as just statements or in a bunch of characters, a bunch of files. Kibana helps us to analyze the logs in a graphical or a chart or a bar diagram format. Again, in an interview, the interviewer is more concerned about testing your knowledge on AWS security products, especially on the logging, monitoring, event management or incident management. Then you could have a question like this: what are the native AWS security logging capabilities? Now, most of the services have their own logging in them, like S3. S3 has its own login, and CloudFront has its own logging. DS has its own logging. VPC has its own logging. In addition, there are account level logins like CloudTrail and AWS config services. So there are a variety of logging options available in the AWS, like CloudTrail, config, CloudFront, Redshift logging, RDS logging, VPC flow logs, S3 object logging, S3 access logging, stuff like that. So we're going to look at two servers in specific. CloudTrail. Now this CloudTrail, the very first product in that picture we just saw, the CloudTrail provides an very high level history of the API calls for all the accounts. And with that, we can actually perform a very good security analysis of our account. And these logs are actually delivered to, you can configure it, they can be delivered to S3 for long time archivals. And based on a particular event, it can also send an email notification to us saying, hey, just got this error, thought I'll let you know, stuff like that. The other one is config service. Now, config service helps us to understand the configuration changes that happened in our environment. And we can also set up notifications based on the configuration changes. So it records the cumulative changes that are made in a short period of time. So if you want to go through the lifetime of a particular resource, what are the things that happened? What are the things it went through? They can be looked at using AWS config. All right. The other question you could get asked is if your role includes taking care of cloud security as well. Then the other question you could get asked is the native services that Amazon provides to mitigate DDoS, which is denial of service. Now, not all companies would go with Amazon native services, but there are some companies which want to stick with Amazon native services just to save them from the headache of managing the other softwares or bringing in another tool, a third-party tool, into managing DDoS. They simply want to stick with Amazon proprietary Amazon native services, and a lot of companies are using Amazon service to prevent DDoS, denial of service. Now, denial of service is, if you already know what denial of service is, well and good. If you do not know, then let's know it now. Denial of service is a user trying to or maliciously making attempt to access a website or an application. The user would actually create multiple sessions and he would occupy all the sessions, and he would not let legitimate users access the service. So he's in turn denying the service for the user. A quick picture review of what denial of service is. Now look at it. These users, instead of making one connection, they are making multiple connections, and there are cheap software programs available that would actually trigger connections from different computers in the internet with different MAC addresses, so everything kind of looks legitimate for the server, and it would accept those connections and it would keep the sessions open. The actual users won't be able to use them, so that's denying the service for the actual users, denial of service. All right, and distributed denial of service is generating attacks from multiple places, from a distributed environment. So that's distributed denial of service. So the tools, the native tools that helps us to prevent the denial of service attacks in AWS is Cloud Shield and Web Access Firewall, AWS WAF. Now they are the major ones. They are designed to mitigate a denial of service. If your website is often bothered by denial of service, then we should be using AWS Shield or AWS WAF. And there are a couple of other tools that also does. When I say that also does, denial of service is not their primary job, but you could use them for denial of service. Route 53's purpose is to provide DNS. CloudFront is to provide caching. Elastic Load Balancer, ELB's work is to provide load balancing. VPC is to create a secure virtual private environment. But they also support mitigating denial of service, but not to the extent you would get in AWS Shield and AWS WAF. So AWS Shield and WAF are the primary ones, but the rest can also be used to mitigate distributed denial of service. The other tricky question is this actually will test your familiarity with the region and the services available in the region. So when you're trying to provision a service in a particular region, you're not seeing the service in that region. How do we go about fixing it, or how do we go about using the service in the cloud? It's a tricky question. And if you have not gone through such situation, you can totally blow it away. You really need to have a good understanding on regions, the services available in those regions, and what if a particular service is not available, how to go about doing it. The answer is not all services are available in all regions. Anytime Amazon announces a new service, they don't immediately publish them on all regions. They start small, and as in when the traffic increases, as in when it becomes more likable to the customers, they actually move the service to different regions. So as you see in this picture, within America, North Virginia has more services compared to Ohio or compared to North California. So within North America itself, North Virginia is the preferred one. So similarly, there are preferred regions within Europe, Middle East, and Africa, and preferred regions within Asia Pacific. So anytime we don't see a service in a particular region, chances that the service is not available in that region yet, we got to check the documentation and find the nearest region that offers that service and start using the service from that region. Now you might think, well, if I'm looking for a service in Asia, let's say in Mumbai, and if it is not available, why not simply switch to North Virginia and start using it? You could, but that's going to add more latency to your application. So that's why we need to check for application, which is check for region, which is very near to the place where you want to serve your customers, and find nearest region instead of always going back to North Virginia and deploying your application in North Virginia. Again, there's a link in aws.com that you can go and look for services available in different region, and that's exactly what you're seeing here. And if your service is not available in a particular region, switch to the other region that provides your service, the nearest other region that provides that service, and start using service from there. With the coming up of cloud, a lot of companies have turned down their monitoring team. Instead, they want to go with the monitorings that cloud provides. Nobody wants to, or at least many people don't want to go through the hassle of, at least new startups and new companies that are thinking of having a monitoring environment. Now, they don't want to go with traditional NOC monitoring. Instead, they would like to leverage AWS monitorings available, because it monitors a lot of stuff, not just the availability, but it monitors a lot of stuff like failures, errors. It also triggers emails, stuff like that. So how do you actually set up a monitor to how do you set up a monitor to monitor the website metrics in real time in AWS? The simple way, anytime you have a question about monitoring, CloudWatch should strike your mind, because CloudWatch is meant for monitoring, is meant for collecting metrics, is meant for providing graphical representation of what's going on in a particular network at a particular point of time. So CloudWatch helps us to monitor applications, and using CloudWatch we can monitor the state changes. Not only the state changes, the autoscaling life cycle events. Anytime there are more services added, there is a reduction in the number of servers because of less usage. Very informative messages can be received through CloudWatch. CloudWatch can now support scheduled events. If you want to schedule anything, CloudWatch has an event that would schedule an action, right? Schedule a trigger, time-based, not incident-based. Anything happening and then you get an action happening that's incident-based. On the other hand, you can simply schedule few things on time-based. So that's possible with CloudWatch. So this CloudWatch integrates very well with a lot of other services like notifications for notifying the user or for notifying the administrator about it. And it can integrate well with Lambda. So to trigger an action, anytime you're designing an auto-healing environment, this CloudWatch can actually monitor and send an email if we are integrating it with SNS, Simple Notification Service. Or this CloudWatch can monitor, and based on what's happening, it can trigger an event in Lambda, and that would in turn run a function till the environment comes back to normal. So CloudWatch integrates well with a lot of other AWS services. Alright, so CloudWatch has 3 statuses: green when everything is going good, yellow when the service is degraded, and red when the service is not available. Green is good, so we don't have to do anything about it. But anytime there's an yellow, the picture that we're looking at, it's actually calling a Lambda function to debug the application and to fix it. And anytime there's a red alert, it immediately notifies the owner of the application about, well, the service is down, and here is the report that I have. Here is the metrics that I've collected about the service, stuff like that. If the job role requires you to manage the servers as well, there are certain job roles which are on the system side. There are certain job roles which is development plus system side. Now you're responsible for the application and the server as well. So if that's the case, you might be tested with some basic questions like the different types of virtualization in AWS and what are the difference between them. Alright, the three major types of virtualization are HVM, which is hardware virtual machine. The other one is PV, para virtualization. And the third one is PV on HVM, para virtualization on hardware virtual module. Alright, the difference between them, or actually describing them, is actually the difference between them. HVM, it's actually a fully virtualized hardware. The whole hardware is virtualized and all virtual machines act separate from each other. And these VMs are booted by executing master boot record in the root block. And when we talk about para virtualization, para grub is actually the special boot loader which boots the PV AMIs. And when we talk about PV on HVM, it's actually the marriage between HVM and PV. And this para virtualization on HVM, in other words, PV on HVM, it actually helps operating system take advantage in storage and the network input output available through the host. Another good question is, name some of the services that are not region specific. Now, you've been taught that all services are within a region and some services are within an availability zone. For example, EC2 is within an availability zone, EBS is within an availability zone, S3 is region specific, DynamoDB is region specific, stuff like that. VPC is both availability and region specific, meaning subnets are availability zone specific and VPC is region specific, stuff like that. So you might have thought, you might have learned in that combination. But there could be some tricky questions that tests you how well you have understood the region, non-region, and availability, non-availability services. I should say there are services that are not region specific. That would be IAM. So we can't have IAM for every availability zone and for every region, which means users will have to use one username and password for one region, and anytime they switch to another region they will have to use another username and password. That's more work, and that's not a good design as well. Authentication has to be global. So IAM is a global service, and which means it's not region specific. On the other hand, Route 53 is again a regional specific. So we can't have Route 53 for every region. Route 53 is not a region specific service. It's a global service. And it's one application. Users access from everywhere or from every part of the world. So we can't have one URL or one DNS name for each region if your application is a global application. And then Web Application Firewall works well with CloudFront. Then CloudFront is a region-based service. So the Web Application Firewall, it's not a region-specific service. It's a global service. And CloudFront is again a global service. Though you can cache content on a continent and country basis, it's still considered a global service. Right? It's not bound to any region. So when you activate CloudFront, you're activating it away from region or availability zone. So when you're activating a Web Application Firewall, because it's not a region specific service, you're activating it away from availability zone and regions. So a quick recap: IAM users, groups, roles, and accounts, they are global services. They can be used globally. Route 53 services are offered at edge locations and they are global as well. Web Application Firewall, a service that protects our web application from common web exploits. They are global service as well. CloudFront is Global Content Delivery Network, CDN, and they are offered at edge locations, which are a global service. In other words, non-region specific service or beyond region service. Alright, this is another good question as well. In the project that you are being interviewed, if they really want to secure their environment using NAT, or if they are already securing their environment using NAT by any of these two methods like NAT gateway or NAT instances, you can expect this question: what are the difference between a NAT gateway and NAT instances? Now, they both serve the same thing, right? So they're not two different services trying to achieve two different things. They both serve the same thing, but still they do have differences in them, right? On a high level, they both achieve providing NATing for the service behind it, but the difference comes when we talk about the availability of it. NAT gateway is a managed service by Amazon, whereas NAT instance is managed by us. Now I'm talking about the third point, maintenance here. NAT gateway is managed by Amazon. NAT instance is managed by us, and availability of NAT gateway is very high, and availability of NAT instance is less compared to the NAT gateway because it's managed by us. It's on an EC2 instance which could actually fail, and if it fails we'll have to relaunch it. But if it is NAT gateway, if something happens to that service, Amazon would take care of reprovisioning it. And talking about bandwidth, it can burst up to 75 gigabits. Traffic through the NAT gateway can burst up to 75 gigabits. But for NAT instance, it actually depends on the server that we launch. And if we are launching a T2 micro, it barely gets any bandwidth. So there's a difference there. And the performance, because it's highly available because of the bigger pipe, 75 gigabits, the performance of the NAT gateway is very high, but the performance of the NAT instance is going to be average. Again, it depends on the size of the NAT instance that we pick. And billing. A billing for NAT gateway is the number of gateways that we provision and the duration for which we use the NAT gateway. But billing for NAT instance is number of instance and the type of instance that we use. Of course, number of instance, duration, and the type of instance that we use. Security in NAT gateway cannot be assigned, meaning it already comes with full packed security. But in NAT instance, security is a bit customizable. I can go and change the security because it's a server managed by me or managed by us. I can always change the security. Well, allow this, don't allow this, stuff like that. Size and load of the NAT gateway is uniform, but the size and the load of the NAT instance changes as per a NAT gateway is a fixed product. But NAT instance can be small instance, can be a big instance, so the size and the load through it varies. Right. The other question you could get asked is, what are the difference between stopping and terminating an EC2 instance? Now you will be able to answer only if you have worked on environments where you have your instance stopped and where you have your instance terminated. If you have only used lab and are attending the interview, chances are that you're always lost when answering this question. It might look like both are the same. Well, stopping and terminating, both are the same. But there is a difference in it. So when you stop an instance, it actually performs a normal shutdown on the instance and it simply moves the instance to the stopped state. But when you actually terminate the instance is moved to the stop state. The EBS volumes that are attached to it are deleted and removed, and we'll never be able to recover them again. So that's a big difference between stopping and terminating an instance. If you're thinking of using the instance again along with the data in it, you should only be thinking of stopping the instance, but you should be terminating the instance only if you want to get rid of that instance forever. If you are being interviewed for an architect level position or a junior architect level position or even an cloud consultant level position or even in an engineering position, this is a very common question that get asked. What are the different types of EC2 instances based on their cost or based on how we pay them, right? They're all compute capacity. For example, the different types are on-demand instances, spot instances, and reserved instances. It kind of looks the same. They all provide the compute capacity. They all provide the same type of hardwares for us. But if you're looking at cost saving or optimizing cost in our environment, we got to be very careful about which one are we picking. Now we might think that, well, I'll go with on-demand instance because I pay on a per hour basis, which is cheap. I can use them anytime I want, and anytime I don't want, I can simply get rid of it by terminating it. You're right, but if the requirement is to use the service for 1 year, the requirement is to use the service for 3 years, then you'll be wasting a lot of money buying on-demand instances. You'll be wasting a lot of money paying on an hourly basis. Instead, we should be going for reserved instance where we can reserve the capacity for the complete 1 year or complete 3 years and save huge amount in buying reserved instances. Alright, so on-demand is cheap to start with if you're only planning to use it for a short while, but if you're planning to run it for a long while, then we should be going for reserved instance. That is what is cost efficient. So spot instance is cheaper than on-demand instance. And there are different use cases for spot instance as well. So let's look at one after the other. The on-demand instance. The on-demand instance is purchased at a fixed rate per hour. This is very short term and irregular workloads. And for testing, for development, on-demand instance is a very good use case. We should be using on-demand for production. Spot instance. Spot instance allows users to purchase EC2 at a reduced price, and anytime we have more instances, we can always go and sell it in spot instances. I'm referring to anytime we have more reserved instances, we can always sell them in spot instance catalog. And the way we buy spot instance is we actually put a budget. This is how much I'm willing to pay. All right, would you be able to give service within this cost? So anytime the price comes down and meets the cost that we have put in, we'll be assigned an instance, and anytime the price shoots up, the instance will be taken away from us. But in case of on-demand instances, we have bought that instance for that particular hour and it stays with us. But with spot instances, it varies based on the price. If you meet the price, you get the instance. If you don't meet the price, it goes away to somebody else. And the spot instance availability is actually based on supply and demand in the market. There's no guarantee that you will get spot instance at all time. All right, so that's a caveat there you should be familiar with. That's a caveat there you should be aware when you are proposing somebody that we can go for spot instance and save money. It's not always going to be available. If you want your spot instance to be available to you, then we need to carefully watch the history of the price of the spot instance. Now, how much was it last month and how much is it this month? So how can I quote, or how much can I quote, stuff like that. So you got to look at those history before you propose somebody that, well, we're going to save money using spot instance. On the other hand, reserved instance provide cost savings for the company. We can opt for reserved instances for 1 year or 3 years. There are actually 3 types of reserved instances: light, medium, and heavy reserved instances. They are based on the amount that we would be paying. And cost benefit also depends with reserved instance. The cost benefit also depends based on, are we doing all upfront or no upfront or partial payment, then split the rest as monthly payments. So there are many purchase options available. But overall, if you're looking at using an application for the next 1 year and 3 years, you should not be going for on-demand instance. You should be going for reserved instance, and that's what gives you the cost benefit. And in an AWS interview, sometimes you might be asked, how you interact with the AWS environment. Are you using CLI? Are you using console? And depending on your answer, whether console or CLI, the panelists put a score. Okay, this person is CLI specific, this person is console specific, or this person has used AWS environment through the SDK, stuff like that. So this question tests whether you are a CLI person or a console person. And the question goes like this: how do you set up SSH agent forwarding so that you do not have to copy the key every time you log in? If you have used PuTTY, anytime if you want to log into an EC2 instance, you will have to put the IP and the port number. Along with that, you will have to map, or we will have to map the key in the PuTTY, and this has to be done every time. That's what we would have done in our lab environments, right? But in production environment, using the same key or mapping the same key again and again every time, it's actually an hassle. It's considered as a blocker. So you might want to cache it. You might want to permanently add it in your PuTTY session so you can immediately log in and start using it. So here in the place where you would actually map the private key, there's a quick button that actually fixes or that actually binds your SSH to your PuTTY instance. So we can enable SSH agent forwarding that will actually bind our key to the SSH, and next time when we try to log in, we don't have to always go through mapping the key and trying to log in. Alright, this question, what are Solaris and AX operating systems? Are they available with AWS? That question generally gets asked to test how familiar are you with the AMIs available? How familiar are you with EC2? How familiar are you with the EC2 hardwares available? That basically tests that. Now the first question or the first thought that comes to your mind is, well, everything is available with AWS. I've seen Windows, I've seen Ubuntu, I've seen Red Hat, I've seen Amazon AMIs, and if I don't see my operating system there, I can always go to Marketplace and try them. If I don't find a Marketplace, I can always go to Community and try them. So there are a lot of AMIs available, there are a lot of operating systems available. I will be able to find Solaris and AX, but that's not the case. Solaris and AX are not available with AWS. That's because Solaris uses a different, Solaris does not support the architecture, does not support public cloud currently. The same goes for AX as well. They run on Power CPU and not on Intel, and as of now, Amazon does not provide power machines. This should not be confused with HPC, which is high performance computing. Should not be confused with that. Now, these are different hardwares, different CPU itself that the cloud providers they do not provide yet. Another question you could get asked in organizations that would want to automate their infrastructure using Amazon native services would be, how do you actually recover an EC2 instance or auto recover an EC2 instance when it fails? Well, we know that EC2 instances are considered as immutable, meaning irreparable. We don't spend time fixing bugs in an OS, stuff like that. Once an EC2 instance crashes, like it goes on a OS panic, or there are various reasons why it would fail. So we don't have to really worry about fixing it. We can always relaunch that instance and that would fix it. But what if it happens at 2 o'clock in the night? What if it happens during a weekend when nobody's in office looking or monitoring those instances? So you would want to automate that, not only on a weekend or during midnights, but it's general practice good to automate it. So you could face this question: how do you actually automate an EC2 instance once it fails? And the answer to that question is using CloudWatch, we can recover the instance. So as you see, there is an alarm threshold set in CloudWatch. And once the threshold is met, meaning if there is an error, if there is a failure, if the EC2 instance is not responding for a certain while, we can set an alarm. And once the alarm is met, let's say the CPU utilization stayed high for 5 minutes. Right, it's not taking any new connections, or the instance is not pinging for 5 minutes, or in this case it's 2 minutes. It's not pinging, so it's not going to respond connection. So in those cases, you would want to automatically recover that EC2 instance by rebooting the instance. All right, now look at this, the take this action section under the action. So there we have a bunch of options like recover this instance, meaning reboot the instance. So that's how we would recover. The other two options are beyond the scope of the question, but still you can go ahead and apply, just like I'm going to do it. So the other option is stop the instance. That's very useful when you want to stop instances that are having low utilizations. Nobody's using the system as of now. You don't want them to be running and wasting the cloud expenditure. So you can actually set an alarm that stops the EC2 instance that's having low utilization. So somebody was working in an instance and they left it without, or they forgot to shut down that instance, and it gets, they will only use it again the next day morning. So in between there could be like 12 hours that the system is running idle, nobody's using it, and you're paying for it. So you can identify such instances and actually stop them when the CPU utilization is low, meaning nobody is using it. The other one is to terminate. Let's say you want to give system to somebody temporarily and you don't want them to hand the system back to you. All right, this is actually an idea. In other words, this is actually the scenario. So you hand over a system to somebody, and when they're done, they're done. We can actually terminate the system. So you could instruct the other person to terminate the system when they're done, and they could forget and the instance could be running forever. Or you can monitor the system after the specified time is over and you can terminate the system. Or best part, you can automate the system termination. So you assign a system to somebody and then turn on this CloudWatch action to terminate the instance when the CPU is low for like 2 hours, meaning they've already left, or CPU is low for 30 minutes, meaning they've already left, stuff like that. So that's possible. And if you're getting hired for an system side architect, or even on the SysOps side, you could face this question: what are the common and different types of AMI designs? There are a lot of AMI designs. The question is the common ones and the difference between them. So the common ones are the full back AMIs, and the other one is just enough OS AMI, JEOS AMI, and the other one is hybrid type AMIs. So let's look at the difference between them. The full backed AMI, just like the name says, it's fully baked. It's ready to use AMI. This is the simplest AMI to deploy. It can be a bit expensive, it can be a bit cumbersome because you'll have to do a lot of work beforehand. You could use the AMI. So a lot of planning, a lot of thought process will go into it, and the AMI is ready to use, right? You hand over the AMI to somebody and it's ready to use. Or if you want to reuse the AMI, it's already ready for you to use. So that's full baked AMI. The other one is just enough operating system AMI. Just like the name says, it has, as you can also see in the diagram or in the picture, it covers a part of the OS. All bootstraps are already packed properly, and the security monitoring, logging, and the other stuff are configured at the time of deployment or at the time you would be using it. So not much thought process will go in here. The only focus is on choosing the operating system and what goes, the operating system specific agents or bootstraps that goes into the operating system. That's all we worry about. The advantage of this is it's flexible, meaning you can choose to install additional softwares at the time of deploying, but that's going to require an additional expertise on the person who will be using the AMI. So that's another overhead there. But the advantage is that it's kind of flexible. I can change the configurations during the time of deployment. The other one is a hybrid AMI. Now the hybrid AMI actually falls in between the fully baked AMI and just enough operating system options. So these AMIs have some features of the baked type and some features of the just enough OS type. So as you see, the security monitoring logging are packed in that AMI, and the runtime environments are installed during the time of a deployment. So this is where the strict company policies would go into the AMI. Company policies like you got to log this, you got to monitor this. These are the ports that generally gets open in all our systems, stuff like that. So they strictly go into the AMI and sits in an AMI format. And during deployment, you have the flexibility of choosing the different runtime and the application that sits in an EC2 instance. Another very famous question you would face in an interview is, how can you recover login to an EC2 instance to which you lost the key? Well, we know that if the key is lost, we can't recover it. There are some organizations that integrate their EC2 instances with an AD. That's different. Alright, so you can go and reset the password in the AD and you will be able to log in with the new password. But here the specific tricky question is, you are using a key to log in, and how do you recover if you have lost the key? Generally, companies would have made a backup of the key so we can pick from the backup, but here the specific question is, we have lost the key, literally no backups on the key at all. So how can we log in? And we know that we can't log into the instance without the key present with us. So the steps to recover is that make the instance use another key and use that key to log in. Once the key is lost, it's lost forever. We won't be able to recover it. You can't raise a ticket with Amazon. Not possible. They're not going to help. It's beyond the scope. So make the instance use another key. It's only the key that's the problem. You still have valid data in it. You got to recover the data. It's just the key that's having the problem. So we can actually focus on the key part alone and change the key, and that will allow us to log in. So how do we do it? Step-by-step procedure. So first, verify the EC2 config service is running in that instance. If you want, you can actually beforehand install the EC2 config in that service, or you can actually make the EC2 config run through the console. Just a couple of button clicks and that'll make the EC2 config run in that EC2 instance, and then detach the root volume for that instance. Of course, it's going to require a stop and start. So detach the root volume from the instance, attach the root volume to another instance as a temporary volume, or it could be a temporary instance that you've launched only to fix this issue, and then log in to that instance and to that particular volume and modify the configuration file. Modify it to use the new key, and then move the root volume back to its original position and restart the instance. And now the instance is going to have the new key, and you also have the new key with which you can log in. So that's how we go ahead and fix it. Now let's move on to some product specific or S3 product specific questions. A general perception is S3 and EBS can be used interchangeably, and the interviewer would want to test your knowledge on S3 and EBS. Well, EBS uses S3, that's true, but they can't be interchangeably used. So you might face this question, what are some key differences between AWS S3 and EBS? Well, the differences are, S3 is an object store, meaning you can't install anything in it. You can store drive files, but you can't actually install in it. It's not a file system. But EBS is a file system. You can install services, install applications in it, and that's going to run stuff like that. And talking about performance, S3 is much faster and EBS is super faster when accessing from the instance, because from the instance, if you need to access S3, you'll actually have to go out through the internet and access the S3, or S3 is an external service, a very external service. You'll have to go through, or you'll have to go outside of your VPC to access S3. S3 does not come under a VPC, but EBS comes under a VPC. It's on the same VPC, so you would be able to use it kind of locally. Compared to S3, EBS is very local, so that way it's going to be faster. And redundancy, talking about redundancy of S3 and EBS. S3 is replicated. The data in S3 is replicated across the data centers, but EBS is replicated within the data center, meaning S3 is replicated across availability zones. EBS is within an availability zone. So that way redundancy is a bit less in EBS. In other words, redundancy is higher in S3 than EBS. And talking about security of S3, S3 can be made private as well as public, meaning anybody can access S3 from anywhere in the internet. That's possible with S3. But EBS can only be accessed when attached to an EC2 instance. Right? Just one instance can access it, whereas S3 is publicly directly accessible. The other question related to S3 security is, how do you allow access to a user to a certain bucket, which means this user is not having access to S3 at all, but this user needs to be given access to a certain bucket. How do we do it? The same case applies to servers as well. In few cases, there could be an instance where a person is new to the team and you actually don't want them to access the production service. Now he is in the production group, and by default he or she is granted access to that server, but you specifically want to deny access to that production server till the time he or she is matured enough to access or understand the process, understand the do's and don'ts before they can put their hands on the production server. So how do we go about doing it? So first we would categorize our instances. Well, these are critical instances. These are normal instances. And we would actually put a tag on them. That's how we categorize. Right? So you put a tag on them. Put a tag saying, well, they are highly critical, they are medium critical, and they are not critical at all. Still they're in production, stuff like that. And then you would pick the users who wants to, or who should be or should not be given access to a certain server, and you would actually allow the user to access or not access servers based on a specific tag. In other words, you can use actually tags. In the previous step, we put tags on the critical server, right? So you would define that this user is not going to use this tag. All right, this user is not allowed to use the resources with this tag. So that's how you would make your step forward. So you would allow or deny based on the tags that you have put. So in this case, he or she will not be allowed to servers which are tag critical servers. So that's how you deny access to them. And the same goes for bucket as well. Right, if an organization is excessively using S3 for their data storage because of the benefit that it provides, the cost and the durability, you might get asked this question, which is organizations would replicate the data from one region to another region for additional data durability and for having data redundancy. Not only for that, they would also do that for DR purposes, for disaster recovery. If the whole region is down, you still have the data available somewhere else and you can pick and use it. Some organizations would store data in different regions for compliance reasons, to provide low latency access to their users who are local to that region, stuff like that. So when companies do replication, how do you make sure that there is consistency in the replication? How do you make sure that the replication is not failing and the data gets transferred for sure and there are logs for that replication? This is something that the companies would use where they're excessively using S3 and they're fully relying on the replication in running their business. And the way we could do it is we can set up a replication monitor. It's actually a set of tools that we could use together to make sure that the cloud replication, region level replication is happening properly. So this is how it happens. Now on this side, on the left hand side, we have the region 1, and on the right hand side we have region 2, and region 1 is the source bucket and region 2 is the destination bucket. Right, so object is put in the source bucket and it has to go directly to the region 2 bucket or made a copy in the region 2 bucket. And the problem is sometimes it fails and there is no consistency between them. So the way you would do it is connect these services together and create an cross-replication or cross-region replication monitor that actually monitors your environment. So there are CloudWatch that make sure that the data is moved, no data is failing. Again, there's CloudWatch on the other end, make sure that the data is moving. And then we have the logs generated through CloudTrail, and that's actually written in DynamoDB. And if there is an error, if something is failing, you get notified through an SMS or you get notified through an email using the SNS service. So that's how we could leverage these tools and set up an cross-region replication monitor that actually monitors your data replication. Some common issues that companies face in VPC is that we all know that I can use Route 53 to resolve an IP address externally from the internet, but by default the servers won't connect to the other servers using our custom DNS name. That it does not do that by default. So it's actually a problem. There are some additional things that as an administrator or as an architect or as a person who uses it, you will have to do. And that's what we're going to discuss. So the question could be, VPC is not resolving the server through the DNS. You can access it through the IP, but not through the DNS name. And what could be the issue and how do you go about fixing it? And you will be able to answer this question only if you have done it already. It's a quick and simple step. By default, VPC does not allow, that's the default feature. And we will have to enable the DNS hostname resolution before. Now this is for the custom DNS, not for the default DNS that comes along. This is for the custom DNS. So we will have to enable the DNS hostname resolution. So we'll have to enable the DNS hostname resolution so they actually resolve. Let's say I want to connect to server1.simplylearn.com. By default, it's not allowed. But if I enable this option, then I will be able to connect to server1.simplylearn.com. If a company has VPCs in different regions and they have a head office in a central place and the rest of them are branch offices and they are connecting to the head office for access or for saving data or for accessing certain files or certain data or storing data, all right, so they would actually mimic the hub and spoke topology where you have the VPC which is centrally in an accessible region, a centrally accessible region, and then you would have a local VPCs or branch offices in different other regions and they get connected to the VPC in the central location. And the question is, how do you actually connect the multiple sites to a VPC and make communication happen between them? By default, it does not do that. We know that VPCs, they need to be peered between them in order to access the resources. Let's look at this picture, right? So I have like a customer network or branch offices in different parts and they get connected to a VPC. That's fine. So what we have achieved is those different offices, the remote offices, they are connecting to the VPC and they're talking, but they can't connect or they can't talk to each other. That's what we have built. But the requirement is the traffic needs to, or they should be able to talk to each other, but they should not have a direct connection between them, which means that they will have to come and hit the VPC and then reach the other customer network, which is in Los Angeles or which is in New York. All right, that's the requirement. So that's possible with some architecting in the cloud. So that's using VPN Cloud Hub. You look at these dotted lines, which actually allows customers or which actually allows the corporate networks to talk to each other through the VPC. Again, by default, it doesn't happen. Cloud Hub is an architecture that we should be using to make this happen. And what's the advantage of it? As a central office or as the headquarters office, which is in the VPC, or headquarters data center, which is in the VPC, you have control, or the VPC has control on who talks to who and what traffic can talk to, what traffic can be routed to the other head office, stuff like that. That centralized control is on the VPC. The other question you could get asked is, name and explain some security products and features available in VPC. Well, VPC itself is an security service. It provides security service to the application, but how do you actually secure the VPC itself? That's the question. And yes, there are products that can actually secure the VPC, or the VPC delivers those products to secure the application. Access to the VPC is restricted through a network access control list. Right? So that's an security product in VPC. And a VPC has security groups that protects the instances from unwanted inbound and outbound traffic, and network access control list protects the subnets from unwanted inbound and outbound access. And there are flow logs we can capture in VPC that captures incoming and outgoing traffic through a VPC, which will be used for later analysis, as in what's the traffic pattern, what's the behavior of the traffic pattern, stuff like that. So there are some security products and features available in VPC. Now, how do you monitor VPC? VPC is a very important concept, very important service as well. Everything sits in a VPC. Most of the service sits in a VPC, except for Lambda and S3 and DynamoDB and a couple of other services. Most of them sit in a VPC for security reasons. So how do you monitor your VPC? How do you gain some visibility on your VPC? Well, we can gain visibility on our VPC using VPC flow log. That's the basic service. As you see, it actually captures what's allowed, what's not allowed, stuff like that. Which IP is allowed, which IP is not allowed, stuff like that. So we can gather it and we can use that for analysis. And the other one is CloudWatch and CloudWatch logs, the data transfers that happen. So this is who gets allowed and who does not get allowed. I mean, the flow logs is who is allowed and who's not allowed, that kind of detail. And CloudWatch gives information about the data transfer, how much data is getting transferred. We can actually pick unusual data transfers if there is a sudden hike in the graph. There's a sudden hike and something happens at 12 on a regular basis and you weren't expecting it. There's something suspicious. It could be valid backups. It could be a malicious activity as well. So that's how you know, by looking at CloudWatch logs and CloudWatch dashboard. Now let's talk about multiple choice questions. When going for an interview, you might sometimes find yourself that the company is conducting an online test. Based on the score, they can put you to a panelist and then they would take it forward. So we thought we'll also include multiple choice questions to help you better handle such situation if you come across. Alright, when you find yourself in such situation, the key to clear them is to understand the question properly, read between the lines. That's what they say. There can be like a big paragraph with 3 lines or 10 lines. You really got to understand what the question is about and then try to find answer for that question. So that's a thumb rule number 1. And then the second rule is try to compare and contrast the services mentioned, or try to compare and contrast the answers. You can easily weed out 1 or 2 answers and then you will be left with only 2 answers to decide from. So that also helps you with time, and that also helps you with some precision in your answer. So number 1, read between the lines. Number 2, compare and contrast the services, and you'll be able to easily weed out the wrong ones. So let's try answering this question. Suppose you are a game designer and you want to develop a game with a single digit millisecond latency. Which of the following database services would you choose? So we know that the following are database services. Good enough. All right. And it talks about millisecond latency. That's a key point. And the third thing is it's a game. Could be a mobile game. It's a game that you are trying to design and you need millisecond latency and it has to be a database. Alright, so let's talk about the options available. RDS. RDS is a database for sure. Is it good for game design? We'll come back to that. Neptune. Neptune is a graph, a database service in Amazon. So that's kind of out of the equation. And Snowball is actually a storage. Alright, it's a transport medium, I would say. So that's again out of the equation. So the tie is between RDS and DynamoDB. So if we need to talk about RDS, RDS is a platform as a service. It provides cost-efficient, resizable capacity, but it's an SQL database, meaning the tables are kind of strict. It's good for banking and other type of applications, but not really good for anything that has to do with gaming. So the only option left is DynamoDB. Again, it's the right answer. DynamoDB is actually an fast and flexible NoSQL database service, and it provides a single digit millisecond latency at any scale. And it's a database at the same time. It's a key value store model database. So the right answer is DynamoDB. Alright, let's look at the next question. If you need to perform real-time monitoring of AWS services and get actionable insights, which service would you use? Alright, let's list the services. So it talks about real-time monitoring. A firewall manager, what does it provide? Now, firewall manager is not really a monitor, just like the name says, it's a manager. It manages multiple firewalls. And AWS Guard Duty is an threat detection service. It does monitoring. It does continuously monitor our environment, but it monitors for threats. All right, only threats. Now let's talk about CloudWatch. CloudWatch is a service that helps to track metrics. It's a service that is used to monitor the environment and give us a system-wide visibility, and also it helps us to store logs. So at the moment it kind of looks like that could be the right answer. We don't know that yet, but I mean, we have one more option left, that's EBS. So what's EBS? EBS is a block storage, elastic block store. If we abbreviate EBS, it's elastic block store. So all three of them are easily out of the question. The first one is to manage, second one is to find threats. Of course, it does monitoring. So there's, if there is one relation between CloudWatch and Guard Duty, that's monitoring. So easily we can actually find ourselves slipped towards picking Guard Duty, but know that Guard Duty is only for gaining security insight, but not about gaining AWS service insight. So CloudWatch is a service that helps us to get a system-wide or an AWS-wide or an account-wide, and it has a number of metrics we can monitor and get a very good insight of how a service is performing, be it CPU, be it RAM, be it network utilization, be it connection failures. CloudWatch is a service that helps us perform a real-time monitoring and get some actionable insights on the services. Alright, let's talk about this 33rd question. As a web developer, you are developing an app especially for the mobile platform. Alright, there is a mention that this is especially for the mobile platform. So a lot of services gets filtered out, mobile platform. Right, which of the following lets you add user sign up, sign in, and access control to your web and mobile app quickly and easily? Alright, so this is all about signing in to your mobile app. So if we need to read between the lines, that's how we can read sign up or sign in into an mobile platform. Alright, so we have like 4 options here. Shield, AWS Massey, AWS Inspector, Amazon Cognito. So let's try to weed out services which are not relevant to it. So what's AWS Shield? AWS Shield is actually a service that provides a DDoS mitigation or a DDoS protection, denial of service protection. It's a security feature. Let's talk about the second option. AWS Massey is again a security service that uses machine learning to automatically discover and classify the data. It again talks about security, and this security is all about encrypting or saving the data. It does not come close with signing up and mobile platform. Alright, let's talk about the other one, AWS Inspector. Now, AWS Inspector has something to do with apps. It definitely has something to do with apps. So kind of looks like that's relevant as of now. So it actually helps with improving the security and compliance of the apps that we deploy in the cloud. So kind of looks like it could be because it has to do with apps. The last one, Cognito. Now, Cognito is a service that actually lets the administrator to have control access over web and mobile apps. And it's a service that helps us to sign up and sign in to an mobile and web app. So that very much looks like we found the answer. So Cognito is a service that helps web app and mobile app for sign up and signing in, and also gives the administrator to have control over access control over the web and the mobile app. Pretty much we found it. So it's Cognito. Cognito is a service that helps us to set up, sign in, and have access control over the users who would be using our mobile and web app. Alright, how about this question? You are an ML engineer or a machine learning engineer who is on the lookout for a solution that will discover sensitive information that your enterprise stores in AWS and then uses NLP to classify that data and provide business related insights. Which among the following services would you choose? So we have a bunch of services that's going to help us achieve, or one of it is going to help us achieve the above requirement. So it's a service that deals with machine learning. You're a machine learning engineer who's looking for a service that will help you to discover information at your enterprise store. So we're talking about storage, discover information in store, and then classify the data depending on severity, sensitivity, classify the data. So which service is that? So firewall manager, just like the name says, it's a manager. And AWS IAM, if we abbreviate it, it's Identity and Access Management. So it's Identity and Access Management, nothing to do with identifying sensitive data and managing it. So the first two is already out of the equation. And then the AWS Massey, we already had a quick definition description for AWS Massey, that it's actually a security service that uses machine learning. Kind of looks like it could be it. It's a security service that uses machine learning, and it discovers and classifies the sensitive information. Not only that, it does not stop there. It goes beyond and protects the sensitive data. AWS Massey kind of looks like, but we still have one more option to look at, which is Cloud HMS. Cloud HMS is also a security service. Kind of looks like that could be the answer as well. And it enables us to generate encryption keys and save the data. So kind of 50% of it. It's a security service. It encrypts, helps us protect the data, but AWS Massey is right on spot. It's a machine learning service. It helps us to classify the data and also to protect the data. So the answer for this question would be AWS Massey. So hope you kind of get it how this is going. So first we apply the thumb rule, identify the question that's being asked, read between the lines, and then try to find the service that meets your requirement. And finding the service is by first weeding out the wrong ones, recollect everything that you've learned about the service and see how well that matches with those hints that you have picked up. And if that doesn't match, weed that out, and you'll end up with just two to decide from at some point, and then it becomes easy for you to decide. Click on the question, submit it, and then move on to the other question in your interview. Alright, so how about this one? You are a system administrator in a company which is running most of its infrastructure on AWS. You are required to track your users and keep a look on how your users are being authenticated. Alright, so this is where the problem statement starts. Alright, you need to keep track of how your users are being authenticated, and you wish to create and manage AWS users and use permissions to allow and deny their access to the AWS resources. Alright, so you are to give them permission, number one, and then, if we put them in the right order, first giving them permissions and then tracking their usage. Let's see which of the service will help us achieve it. IAM is a service that helps us to, looking at the permissions, we can actually predict whether the user or the group will have service or not. So that helps us to get a track of who is able to use, who's not able to use certain service and all that stuff. So it kind of looks like, but we have other three options left. Let's look at AWS Firewall Manager. Just like the name says, it's actually a firewall manager. It helps us to manage multiple firewalls. Simple as that. And Shield is a service. It's a service that's used to protect denial of service or distributed denial of service. An API gateway is a service that makes it easy for developers to create, publish, maintain, and monitor and secure APIs. So, it's completely on the API side, very less on user and how you authenticate your user. We can get that by looking at the name itself, right? If we abbreviate it, or if you try to find a definition for the name API gateway, you would get it. It has to do with API. But if we abbreviate AWS IAM, it's Identity and Access Management, pretty much meets the requirement for the problem statement above. It's AWS Identity and Access Management. That's the right answer. Alright, let's look at this one. If you want to allocate various private and public IP address in order to make them communicate with the internet and other instances, you will use this service. Which of the following is this service? So it talks about using public and private IP address. So this service uses IP address, and then this service helps us to allow and deny connections to the internet and to the other instances. So you get the question, is it? Let's pick the service that helps us achieve it. Route 53. Route 53 is actually a DNS service, right? So it's not a service that's used to allow or deny. No, it does not do that. VPC uses public and private IP address. Yes. So kind of looks like VPC helps us to allow, the security in VPC, the security group, the network access control list in a VPC, the routing table in a VPC that actually helps us to allow or deny a connection to a particular IP address or to a particular service within the VPC or outside of the VPC. So as of now, it kind of looks like it could be, but let's look at the other services. What if we find a service that closely matches to the above requirement than the Amazon VPC? Gateway, API gateway. We know that it's a managed service that makes it easy for developers to create, publish, maintain and monitor APIs and secure APIs. So that has completely to do with API, not with IP. CloudFront, we know about CloudFront that it's a content delivery network and it provides global distribution of servers where our content can be cached. It could be video or bulk media or anything else. They can be cached locally so users can easily access them and download them easily. All right, so that's CloudFront. Now at this point, after looking at all four, it looks like VPC is the right answer, and in fact VPC is the right answer. VPC has public IP address. VPC can help us with private IP address. VPC can be used to allow deny connection based on the security group, access control list, and the routing table it has. So that's right answer is VPC. Alright, how about this one? This platform as a service or platform as a DB service provides us with a cost-efficient and resizable capacity while automating time-consuming administrative tasks. So this question is very clear. It's a DB service we got to look for, and it's a service that can provide automating some of the time-consuming tasks. It has to be resizable at the same time. So let's talk about Amazon Relational Database. It's a database kind of matches the requirement. We can resize it as and when needed. All right. Looks like it's a fit as of now. It actually automates some of the time consuming work. Looks like it's a fit as of now. Let's move on to Elastic Cache and then try to see if that matches the definition that we've figured out above. Elastic Cache, it's actually a caching service. It's again an in-memory data store which helps in achieving high throughput and low latency in memory data store. So it's not a full-blown database and it does not come with any Amazon provisioned automation in it for automating any of the administration tasks. No, it does not come up with anything like that. Yeah, we can resize the capacity as and when needed, but automation, it's not there yet, and moreover it's not a database. So that's out of the equation. VPC is not a resizable one. Once we have designed VPC, it's fixed. It can't be resized. So that's out of the equation. And Amazon Glacier is a storage but not a database. Right, so that's again out of the equation. So the tie is kind of between Amazon Relational Database Service and Amazon Elastic Cache because they both aid the database service, but Elastic Cache is not a full-blown database. It actually helps the database, but it's not a full-blown database. So it's Amazon Relational Database. So that's the one which is a platform as a service. It's the one which can be resized. It's the one which can be used to automate the time-consuming administrative tasks. Alright, let's talk about this one. Which of the following is a means for accessing human researchers or consultants to help solve a problem on a contractual or a temporary basis? Alright, let's read the question again. Which of the following is a means for accessing human researchers or consultant to help solve problems on a contractual or a temporary basis? It's like assigning tasks or hiring AWS experts for a temporary job. So let's try to find that kind of service in the 4 services that are listed. Amazon Elastic MapReduce. MapReduce is actually an framework service that makes it easy and cost effective to analyze large amount of data, but that has nothing to do with accessing human researchers. All right, let's talk about Mechanical Turk. It's a web service that provides a human workforce, that's the definition for it, For example, automation is good, but not everything can be automated. For something to qualify for automation, it has to be a repetitive task. A one-time task can't be automated, or the time and money that you would be spending in automation is not worth it. Instead, you could have done it manually. So that does not qualify for automation. And anything that requires intelligence, right? Anything that's a special case. Right? Automation can do repetitive tasks. Automation can do precise work, but it has to be a repetitive task. The scenario, it should have been there already. Only then that can be executed. But if it's a new scenario and it requires appropriate addressing, then it requires human task. So we could hire researchers and consultants who can help solve a problem using Amazon Mechanical Turk. The other two are already out of the equation. Now, DevPay is actually a payment system through Amazon, and multi-factor authentication, as it says, it's an authentication system. So the right answer is Amazon Mechanical Turk. Alright, this sounds interesting. Let's look at this one. This service is used to make it easy to deploy, manage, and scale containerized applications using Kubernetes on AWS. Which of the following is this AWS service? So it's a service to deploy, manage, and scale containerized applications. So it deals with containers. It also should have the ability to use Kubernetes, which is a container orchestration service. Alright, the first one, Amazon Elastic Container Service. Kind of looks like it's the one. The name itself has the word and the relation we're looking for, Elastic Container Service. So this container service is an highly scalable, high performance container orchestration service. Let's look at the other one, AWS Batch. It's a service that enables IT professionals to schedule and execute batch processing. I mean, the name itself says that that's meant for batch processing. Elastic Beanstalk, that's another service that helps us to deploy, manage, and scale, but it helps us with EC2 instances, not with containerized instances. So that's again out of the equation. Would Lightsail be a good tie for Elastic Container Service? What's Lightsail? Now, Lightsail is a service. It's called as a virtual private server without a VPC. It's called as a virtual private server. It comes with predefined compute, storage, networking capacity. It's actually a server, not a container. Right, so at this point that also becomes out of the equation. So it's Amazon Elastic Container Service. That's the one that helps us to easily deploy, manage, scale container services, and it helps us orchestrate the containers using Kubernetes. Alright, how about this one? Alright, this service lets us to run code without provisioning or managing servers. So no servers, run code. Select the correct service from the below option. Alright, so no servers, but we should be able to run code. Amazon EC2 Autoscaling. EC2 Autoscaling? EC2 is Elastic Compute Cloud, which is a server, and Autoscaling is a service that helps us to achieve scaling the server. So that's the definition for it. Could be that's out of the equation. AWS Lambda. Now Lambda is a service. It's actually an event-driven serverless computing platform, and Lambda runs code in response to the event that it receives, and it automatically manages the compute resource that's required for that code. As long as we have uploaded a code that's correct and set up events correctly to map to that code, it's going to run seamlessly. So that's about Lambda. It kind of looks like it could be the answer because Lambda runs code. We don't have to manage servers. It manages servers by itself. But we can't conclude as of now. We have other two services to talk about. AWS Batch. Alright, Batch is a service that enables IT professionals to run batch job. We know that. And about Inspector, Amazon Inspector, it's actually a service that helps us to increase and identify any security issues and align our application with compliance. Well, that's not the requirement in the question. The requirement in the question was run code without provisioning a server, and without any more space for confusion, AWS Lambda is a service, or is the service that runs code without provisioning and managing services. Right, the right one. All right. Let's get started. So in an environment where there is a lot of automation, infrastructure automation, you'll be posted with this question: how can you add an existing instance to a new autoscaling group? Now this is when you are taking an instance away from the autoscaling group to troubleshoot, to fix a problem, to look at logs, or if you have suspended the autoscaling, you might need to re-add that instance to the autoscaling group. Only then it's going to take part in it, right? Only then the autoscaling is going to count it as part of it. It's not a straight procedure. When you remove them, it doesn't get automatically re-added. And I've had worked with some clients, so when their developers were managing their own environment, they had problems adding the instance back to the autoscaling group. Irrespective of what they tried, the instance was not getting added to the autoscaling group, and whatever they fix that they were provided, or whatever fix that they have provided, were not getting counted in the autoscaling group. So like I said, it's not a straight a click button procedure. There are ways we'll have to do it. So how can you add an existing instance to the autoscaling group? There are a few steps that we need to follow. So the first one would be to, under the EC2 instance console, right, under the instance, under actions in specific, there's an option called attach to autoscaling group, right? If you have multiple autoscaling groups in your account or in the region that you're working in, then you're going to be posted with the different autoscaling groups that you have in your account. Let's say you have 5 autoscaling groups for 5 different applications. You're going to be posted with 5 different autoscaling groups, and then you would select the appropriate autoscaling group and attach the instance to that particular autoscaling group. While adding to the autoscaling group, if you want to change the instance type, that's possible as well. Sometimes when you want to add the instance back to the autoscaling group, there would be requirement that you change the instance type to a better one, to a better family, to the better instance type. You could do that at that time. And after that, you have completely added the instance back to the autoscaling group. So it's actually a 7-step process, adding an instance back to the autoscaling group. In an environment where they're dealing with migrating the instance, or migrating an application, or migrating an instance, migrating an VM into the cloud, if the project that you're going to work with deals with a lot of migrations, you could be posted this question: what are the factors you will consider while migrating to Amazon Web Services? The first one is cost. Is it worth moving the instance to the cloud? Given the additional bells and whistles features available in the cloud, is this application going to use all of them? Is moving into the cloud beneficial to the application in the first place? Beneficial to the users who will be using the application in the first place. So that's a factor to think of. So this actually includes cost of the infrastructure and the ability to match the demand and supply transparency. Is this application in high demand? Is it going to be a big loss if the application becomes unavailable for some time? So there are a few things that needs to be considered before we move the application to the cloud. And then if the application needs to be provisioned immediately? Is there an urge? Is there an urge to provision the application immediately? That's something that needs to be considered. If the application requires to go online, if the application needs to hit the market immediately, then we would need to move it to the cloud. Because in on-premises, procuring, buying an infrastructure, buying the bandwidth, buying the switch port, buying an instance, buying the softwares, buying the license related to it, it's going to take time, at least like 2 weeks or so, before you can bring up an server and launch an application in it, right? So if the application cannot wait, waiting means workforce productivity loss, is it? So we would want to immediately launch instances and put application on top of it. In those cases, if your application is of that type, if there is an urge in making the application go online as soon as possible, then that's a candidate for moving to the cloud. And if the application, or if the the software or if the product that you're launching, it requires hardware. It requires an updated hardware all the time. That's not going to be possible in on-premises. We try to deal with legacy infrastructure all the time in on-premises. But in the cloud, they're constantly upgrading their hardwares. Only then they can keep themselves up going in the market. So the cloud providers are constantly updating their hardwares. And if you want to be benefited, or if your application wants to be benefited by the constant upgrading of the hardwares, making sure the hardware is as latest as possible, the software version, the licensing is as latest as possible, then that's a candidate to be moved to the cloud. And if the application does not want to go through any risk, if the application is very sensitive to failures, if the application is very much tagged to the revenue of the company and you don't want to take a chance in seeing the application fail and seeing the revenue drop, then that's a candidate for moving to the cloud. And business agility, moving to the cloud, at least half of the responsibility is now taken care by the provider. In this case, it's Amazon. At least half of the responsibility is taken care by them. Like if the hardware fails, Amazon makes sure that they're fixing the hardware immediately. And notifications, if something happens, there are immediate notifications available that we can set it up and make ourselves aware that something has broken, and we can immediately jump in and fix it. So you see, the responsibility is now being shared between Amazon and us. So if you want to get that benefit for your application, for your organization, for the product that you're launching, then it needs to be moved to the cloud so you can get that benefit from the cloud. The other question you could get asked is, what is RTO and RPO in AWS? They are essentially disaster recovery terms. When you're planning for disaster recovery, you cannot avoid planning disaster recovery without talking about RTO and RPO. Now, what's the RTO? What's the RPO in your environment? Or how do you define RTO? How do you define RPO? Are some general questions that get asked. RTO is recovery time objective. RTO stands for the maximum time the company is willing to wait for the recovery to happen or for the recovery to finish when a disaster strikes. So RTO is in the future, right? How much time is it going to take to fix and bring everything to normal? So that's RTO. On the other hand, RPO is recovery point objective, which is the maximum amount of data loss your company is willing to accept as measured in time. RPO always refers to the backups, the number of backups, the frequency of the backups, right? Because when an outage happens, you can always go back to the latest backup, right? And if the latest backup was before 12 hours, you have lost the in-between 12 hours of data storage, right? So RPO is the acceptable amount. If the company wants less RPO is 1 hour, then you should be planning on taking backups every 1 hour. If RPO is 12 hours, then you should be planning on taking backups every 12 hours. So that's how RPO and RTO helps disaster recovery. The fourth question you could get asked is, if you'd like to transfer huge amount of data, which is the best option among Snowball, Edge, and Snowmobile? Again, this is a question that gets asked if the company is dealing with a lot of data transfer into the cloud, or if the company is dealing with migrating data into the cloud. I'm talking about a huge amount of data in petabytes. Snowball and all of the Snowball series deals with petabyte-sized data migrations. So there are three options available as of now. AWS Snowball is an data transport solution for moving high volume of data into and out of a specified AWS region. On the other hand, AWS Snowball Edge adds additional computing functions. Snowball is simple storage and movement of data, and Snowball Edge has a compute function attached to it. Snowmobile, on the other hand, is an exabyte scale migration service that allows us to transfer data up to 100 petabytes. That's like 100,000 terabytes. So depending on the size of data that we want to transfer from our data center to the cloud, we can rent any of these three services. let's talk about some CloudFormation questions. This is a classic question. How is AWS CloudFormation different from AWS Elastic Beanstalk? From the surface, they both look like the same. You don't go through the console provisioning resources. You don't go through CLI and provision resources. Both of them provision resources through click button. Right? But underneath, they are actually different services. They aid different services. So knowing that is going to help you understand this question a lot better. Let's talk about the difference between them, and this is what you will be explaining to the interviewer or the panelist. So the CloudFormation service helps you describe and provision all the infrastructure resources in the cloud environment. On the other hand, Elastic Beanstalk provides an simple environment to which we can deploy and run application. CloudFormation gives us an infrastructure, and Elastic Beanstalk gives us a small contained environment in which we can run our application. And CloudFormation supports the infrastructure needs of many different types of application, like the enterprise application, the legacy applications, and any new modern application that you want to have in the cloud. On the other hand, the Elastic Beanstalk, it's a combination of developer tools. They are tools that helps manage the life cycle of a single application. So CloudFormation, in short, is managing the infrastructure as a whole, and Elastic Beanstalk, in short, is managing and running an application in the cloud. And if the company that you're getting hired is using CloudFormation to manage their infrastructure, or if they're using infrastructure or any of the infrastructure as a code services, then you would definitely face this question: what are the elements of an AWS CloudFormation template? So it has 4 or 5 basic elements, right? And the template is in the form of JSON or in YAML format. Right, so it has parameters, it has outputs, it has data, it has resources, and then the format or the format version or the file format version for the CloudFormation template. So parameter is nothing but it actually lets you to specify the type of EC2 instance that you want, the type of RDS that you want, right? So EC2 is an umbrella, RDS is an umbrella, and parameters within that EC2 and parameters within that RDS are the specific details of the EC2 or the specific details of the RDS service. So that's what parameters in a CloudFormation template. And then the element of the CloudFormation template is outputs. For example, if you want to output the name of an S3 bucket that was created, if you want to output the name of the EC2 instance, if you want to output the name of some resources that have been created, instead of looking into the template, instead of navigating through in the console and finding the name of the resource, we can actually have them outputted in the result section. So you can simply go and look at all the resources created through the template in the output section, and that's what output values or output does in the CloudFormation template. And then we have resources. Resources are nothing but what defines what are the cloud components or cloud resources that will be created through this CloudFormation template. Now, EC2 is a resource, RDS is a resource, and S3 bucket is a resource, Elastic Load Balancer is a resource, and NAT Gateway is a resource, VPC is a resource. So you see, all these components are the resources, and the resource section in the CloudFormation defines what are the AWS cloud resources that will be created through this CloudFormation template. And then we have version. Version actually identifies the capabilities of the template. We just need to make sure that it is of the latest version type, and the latest version is 0909 2010. That's the latest version number. You'll be able to find that on the top of the CloudFormation template, and that version number defines the capabilities of the CloudFormation template. So just need to make sure that it's the latest all the time. Still talking about CloudFormation, this is another classic question: what happens when one of the resources in a stack cannot be created successfully? Well, if the resource in a stack cannot be created, the CloudFormation automatically rolls back and terminates all the resources that was created using the CloudFormation template. So whatever resources that were created through the CloudFormation template from the beginning, let's say we have created like 10 resources and the 11th resource is now failing, CloudFormation will roll back and delete all the 10 resources that were created previously. And this is very useful when the CloudFormation cannot go forward. CloudFormation cannot create additional resources because we have reached the Elastic IP limits. Elastic IP limit per region is 5, right? And if you have already used 5 IPs and your CloudFormation is trying to buy 3 more IPs, we've hit the soft limit. Till we fix that with Amazon, CloudFormation will not be able to launch additional resources and additional IPs. So it's going to cancel and roll back everything. That's true with a missing EC2 AMI as well. If an AMI is included in the template but the AMI is not actually present, then CloudFormation is going to search for the AMI, and because it's not present, it's going to roll back and delete all the resources that it created. So that's what CloudFormation does. It simply rolls back all the resources that it created. I mean, if it sees a failure, it would simply roll back all the resources that it created. And this feature actually simplifies the system administration and layered solutions built on top of AWS CloudFormation. So at any point, we know that there are no orphan resources in our environment, because something did not work, or because there was an CloudFormation executed some, there are no orphan resources in our account. At any point, we can be sure that if CloudFormation is launching a resource and if it's going to fail, and it's going to come back and delete all the resources it's created, so there are no orphan resources in our account. Now let's talk about some questions in Elastic Block Store. Again, if the environment deals with a lot of automation, you could be thrown this question: how can you automate EC2 backup using EBS? It's actually a 6-step process. To automate the EC2 backups, we'll need to write a script to automate the below steps using AWS API. And these are the steps that should be found in the scripts. First, to get the list of instances, and then the script that we are writing should be able to connect to AWS using the API and list the Amazon EBS volumes that are attached locally to the instance. And then it needs to list the snapshots of each volume, make sure the snapshots are present, and it needs to assign a retention period for the snapshot, because over time the snapshots are going to be invalid, right? Once you have some 10 latest snapshots, any snapshot that you have taken before that 10 becomes invalid because you have captured the latest, and 10 snapshot coverage is enough for you. And then the 5th point is to create a snapshot of each volume, create a new snapshot of each volume, and then delete the old snapshot. Anytime a new snapshot gets created, the oldest snapshot in the list needs to go away. So we need to include options, we need to include scripts in our script, lines in our script that make sure that it's deleting the older snapshots which are older than the retention period that we are mentioning. Another question that you could see in the interview, be it a written interview, be it online interview, or be it an telephonic or face-to-face interview, is what's the difference between EBS and Instant Store? Let's talk about EBS first. EBS is kind of permanent storage. The data in it can be restored at a later point. When we save data in EBS, the data lives even after the lifetime of the EC2 instance. For example, we can stop the instance and the data is still going to be present in EBS. We can move the EBS from one instance to another instance and the data is simply going to be present there. So EBS is kind of permanent storage when compared to instance. On the other hand, instance store is temporary storage, and that storage is actually physically attached to the host of the machine. EBS is an external storage, and instance store is locally attached to the instance or locally attached to the host of the machine. We cannot detach an instance store from one instance and attach it to another, but we can do that with EBS. So that's a big difference. One is permanent data and another one is EBS is permanent, instance store is volatile data, and instance store, with instance store we won't be able to detach the storage and attach it to another instance. And another feature of instance store is data in an instance store is lost if the disk fails or the instance is stopped or terminated. So instance store is only good for storing cache data. If you want to store permanent data, then we should think of using EBS and not instance store. While talking about storage on the same lines, this is another classic question. How can you take backups of EFS like EBS? And if you can take backup, how do you take that backup? The answer is yes, we can take EFS to EFS backup solution. EFS does not support snapshot. Like EBS, EFS does not support snapshot. Snapshot is not an option for EFS, Elastic File System, right? We can only take backup from one EFS to another EFS, and this backup solution is to recover from unintended changes or deletions of the EFS, and this can be automated, right? Any data that we store in EFS can be automatically replicated to another EFS, and once this EFS goes down or gets deleted, or data gets deleted, or the whole EFS is for some reason interrupted or deleted, we can recover the data from, we can use the other EFS and bring the application to consistency. And to achieve this, it's not an one-step configuration, it's a cycle. There are a series of steps that's involved before we can achieve EFS to EFS backup. The first thing is to sign in to the AWS Management Console, and under EFS, or click on EFS to EFS restore button from the services list, and from there we can use the region selector in the console navigation bar to select the actual region in which we want to work on, and from there ensure that we have selected the right template. Some of the templates would be EFS to EFS backup, granular backups, incremental backups. Right, so there are some templates, the kind of backups that you want to take. Do you want to take granular? Do you want to take increment backups? Stuff like that. And then create a name to that solution, the kind of backup that we have created. And finally review all the configurations that you have done and click on save. And from that point onwards, the data is going to be copied. And from that point onwards, any additional data that you put is going to copy it and replicate it. Now you have an EFS to EFS backup. This is another classic question in companies which deals with data management. There are easy options to create snapshots, but deleting snapshots is not always an click button or a single step configuration. So you might be facing a question like, how do you auto delete old snapshots? And the procedure is like this. Now, as best practice, we will take snapshots of EBS volume to S3. All snapshots get stored in S3. We know that now. And we can use AWS Ops Automator to automatically handle all snapshots. The Ops Automator service, it allows us to create, copy, delete EBS snapshots. So there are CloudFormation templates available for AWS Ops Automator, and this Automator template will scan the environment, and it would take snapshots. It would copy the snapshot from one region to another region if you want, if you're setting up a DR environment. And not only that, based on the retention period that we create, it's going to delete the snapshots which are older than the retention period. So life or managing snapshot is made a lot easier because of this Ops Automator CloudFormation template. Moving into questions in Elastic Load Balancer, this again could be a question in the interview. What are the different types of load balancers in AWS, and what's their use case? What's the difference between them? And as of now, as we speak, there are three types of load balancers which are available in AWS. The first one being application load balancer. Just like the name says, the application load balancer works on the application layer and deals with HTTP and HTTPS requests. And it also supports path-based routing. For example, Simplilearn.com / some web page, Simplilearn.com / another website. So it's going to direct the path based on the / value that you give in the URL. So that's path-based routing. So it supports that. And not only that, it can support port-based :8080, :8081, or :8090. Based on that port also, it can take a routing decision, and that's what application load balancer does. On the other hand, we have network load balancer, and the network load balancer makes routing decisions at the transport level. It's faster because it has very less thing to work on. It works on lower OSI layer. It works on a lower layer, so it has very less information information to work with than compared with application layer. So comparatively, it's a lot faster and it handles millions of requests per second. And after the load balancer receives the connection, it selects a target group for the default rule using the flow hash routing algorithm. It does simple routing, right? It does not do path-based or port-based routing. It does simple routing, and because of it, it's faster. And then we have classic load balancer, which is kind of expiring as we speak. Amazon is discouraging people using classic load balancer, but there are companies which are still using classic load balancer. They are the ones who were the first one to step into Amazon when classic load balancer was the first load balancer or the only load balancer available at that point. So it supports HTTP, HTTPS, TCP, SSL protocol, and it has a fixed relationship between a load balancer port and the container port. So initially we only had classic load balancer, and then after some point Amazon said instead of having one load balancer address all type of traffic, we're going to have two load balancers called as the child from the classic, two load balancer, and one is going to specifically address the application requirement and one is going to specifically address the network requirement, and let's call it as application load balancer and network load balancer. So that's how now we have two different load balancers. Talking about load balancer, another classic question could be, what are the different uses of the various load balancer in AWS Elastic load balancing? There are three types of load balancer. We just spoke about it. Application load balancer is used if we need flexible application management and TLS termination, and network load balancer if we require extreme performance and the load balancing should happen based on static IPs for the application. And classic load balancer is an old load balancer which is for people who are still running their environment from EC2 classic network. Now this is an older version of VPC, or this is what was present before VPC was created. EC2 classic network is what was present before EC2 was created. So they are the three types and they are the use cases of it. Let's talk about some of the security related questions you would face in the interview. When talking about security and firewall in AWS, we cannot avoid discussion talking about WAF, Web Application Firewall, and you would definitely see yourself in this situation where you've been asked how can you use AWS WAF in monitoring your AWS applications. WAF or Web Application Firewall protects our web application from common web exploits, and WAF helps us control which traffic source your application should be allowed or blocked, which traffic from a certain source, which source or which traffic from a certain source should be allowed or blocked your application. With WAF we can also create custom rules that blocks common attack patterns. If it is a banking application, it has a certain type of attacks, and if it is simple data management, data storage application, it has content management application, it has a separate type of attack. So based on the application type, we can identify a pattern and create rules that would actually block that attack based on the rule that we create. And WAF can be used for three cases. The first one is allow all requests, and then block all requests, and count all requests for a new policy. So it's also an monitoring and management service which actually counts all the policies, or counts all the requests that matches a particular policy that we create. And some of the characteristics we can mention in AWS WAF are the origin IPs and the strings that appear in the request. We can allow block based on origin IP, allow block based on strings that appear in the request. We can allow block or count based on the origin country, length of the request. We can block and count the presence of malicious scripts in an connection. We can count the request headers, or we can allow block a certain request header, and we can count the presence of malicious SQL code in a connection that we get and that want to reach our application. Still talking about security, what are the different AWS IAM categories we can control? Using AWS IAM, we can do the following. One is create and manage IAM users. And once the user database gets bigger and bigger, we can create and manage them in groups. And in IAM, we can use it to manage the security credentials kind of setting the complexity of the password, setting additional authentications, like MFA, and rotating the passwords, resetting the password. There are a few things we could do with IAM. And finally, we can create policies that actually grants access to AWS services and resources. Another question you will see is, what are the policies that you can set for your user's password? So some of the policies that we can set for the user password is the minimum length, or the complexity of the password by at least having one number or one special characters in the password. So that's one. And then the requirement of a specific character types, including uppercase, lowercase, number, and non-alphabetic characters. So it becomes very hard for somebody else to guess what the password would be and try to hack them. So we can set the length of the password, we can set the complexity in the password, and then we can set an automatic expiration of the password. So after a certain time, the user is forced to create a new password, so the password is not stale, old, and easy to guess in the environment. And we can also set settings like the user should contact the admin when the password is about to expire. So you can get a hold of how the user is setting their password. Is it having good complexity in it? Is it meeting company standards? Or there are a few things that we can control and set for the users when the users are setting or recreating the password. Another question that could be posted in an interview, so to understand your understanding of IAM, is what's the difference between an IAM role and an IAM user? Let's talk about IAM user. Let's start small and then go big, or let's start simple and then talk about the complex one. The IAM user has a permanent long-term credential, and it's used to interact directly with AWS services. And on the other hand, IAM role is an IAM entity that defines a set of permissions for making AWS service requests. So IAM user is an permanent credential and role are temporary credentials. And IAM user has full access to all AWS IAM functionalities. And with role, trusted entities such as IAM users, application, or AWS services assume the role. So when an IAM user is given a permission, it sticks within the IAM user. But with roles, we can give permissions to applications, we can give permissions to users in the same account, in a different account, the corporate ID. We can give permissions to EC2, S3, RDS, VPC, and lot more. Role is wide, and IAM user is not so wide. It's very constrained only for that IAM user. Let's talk about managed policies in AWS. Managed policies, there are two types, customer managed and Amazon managed. So managed policies are IAM resources that express permissions using the IAM policy language. We can create policies, edit them, manage them separately from the IAM user group and roles which they are attached to. So they are something that we can do to managed policies if it is customer managed. And we can now update policy in one place, and the permissions automatically extend to all the attached entries. So I can have like 3 services, 4 services point to a particular policy, and if I edit that particular policy, it's going to reflect on those 3 or 4 services. So anything that I allow is going to be allowed for those 4 services. Anything that I denied is going to be denied for the 4 services. Imagine what would be without the IAM managed policy. We'll have to go and specifically allow deny on those different instances 4 or 5 times, depending on the number of instances that we have. So like I said, there are 2 types of managed policies. One is managed by us, which is customer managed policies, and then the other is managed by AWS, which is AWS managed policy. This question, can you give an example of an IAM policy and a policy summary? This is actually to test how well versed are you with the AWS console. The answer to that question is, look at the following policy. This policy is used to grant access to add, update, and delete objects from a specific folder. In this case, name of the folder is example folder, and it's present in a bucket called example bucket. So this is an IAM policy. On the other hand, the policy summary is a list of access level, resource and conditions for each service defined in a policy. So IAM policy is all about one particular resource, and the policy summary is all about multiple resources. With IAM policy, it was only talking about S3 bucket and one particular S3 bucket. Here it talks about CloudFormation template, CloudWatch logs, EC2, Elastic Beanstalk services. Summary of resources and the permissions and policies attached to them. That's what policy summary is all about. Another question could be like this: what's the use case of IAM and how does IAM help your business? Now, two important or primary work of IAM is to help us manage IAM users and their access. It provides secure access to multiple users to their appropriate AWS resources. So that's one it does. And the second thing it does is manage access for federated users. Federated users or non-IAM users, and through IAM we can actually allow and provide secure access to resources in our AWS account to our employees without the IAM user. Now, they could be authenticated using the Active Directory, they could be authenticated using the Facebook credential, Google credential, Amazon credential, and a couple of other credentials, third-party identity management, right? So we could actually trust them and we could give them access to our account based on the trust relationship that we have built with the other identity systems. All right, so two things. One is manage users and their access manage IAM user and their access in our AWS environment, and second is manage access for federated users who are non-IAM users. And more importantly, IAM is a free service, and with that will only be charged for the use of the resources, not for the IAM username and password that we create. All right, let's now talk about some of the questions in Route 53. One classic question that could be asked in an interview is, what is the difference between latency-based routing and geo-DNS or geo-based DNS routing? Now, the geo-based DNS routing takes routing decisions on the basis of the geographic location of the request. And on the other hand, the latency-based routing utilizes latency measurements between networks and data centers. Now, latency-based routing is used where you want to give your customers the lowest latency as possible. So that's when we would use latency-based routing. And on the other hand, geo-based routing is when we want to direct customers to different websites based on the country they are browsing from. You could have two different or three different websites for the same URL. Take Amazon, the shopping website, for example. When we go to Amazon.com from in the US, it directs us to the US web page where the products are different, the currency is different, right, and the flag and a couple of other advertisements that shows up are different. And when we go to Amazon.com from India, it gets directed to the Amazon.com Indian site, where again the currency, the product, and the advertisements, they're all different, right? So depending on the country they're trying to browse, if you want to direct customers to 2 or 3 different websites, we would use geo-based routing. Another use case of geo-based routing is if we have a compliance that you should handle all the DNS requests, or if you should handle all the requests from a country within the country, then you would do geo-based routing. You wouldn't direct the customer to a server which is in another country, right? You would direct the customer to a server which is very local to them. That's another use case of geo-based routing. And like I said, for latency-based routing, the whole goal or aim is to achieve minimum end-user latency. If you are hired for the architect role and if that requires working a lot on the DNS, then you could be posted with this question: what is the difference between domain and a hosted zone? A domain is actually a collection of data describing a self-contained administrative and technical unit on the internet, right? So for example, Simplilearn.com is actually a domain. On the other hand, hosted zone is actually an container that holds information about how you want to route traffic on the internet to a specific domain. For example, lms.simplilearn.com Simplilearn.com is an hosted zone, whereas Simplilearn.com is an domain. So in other words, in hosted zone, you would see the domain name plus a prefix to it. LMS is a prefix here. FTP is a prefix. Mail.simplilearn.com is a prefix. So that's how you would see a prefix in hosted zones. Another classic question from Route 53 would be, how does Amazon Route 53 provide high availability and low latency? The way Amazon Route 53 provides high availability and low latency is by globally distributed DNS servers. Amazon is a global service and they have DNS services globally. Any customer doing a query from different parts of the world, they get to reach an DNS server which is very local to them, and that's how it provides low latency. Now this is not true with all the DNS providers. There are DNS providers who are very local to a country, who are very local to a continent. So they generally don't provide low latency service. Right, it's always high latency. It's low latency for local users, but anybody browsing from a different country or a different continent, it's going to be high latency for them. But that's not again true with Amazon. Amazon is a globally distributed DNS provider. It has DNS servers global wide, and like I said, it has optimal locations. It has got global servers, or in other words, it has got servers around the globe, different parts in the globe, and that's how they are able to provide high availability. And because it's not running on just one server but on many servers, they provide high availability and low latency. If the environment that you're going to work on is going to take a lot of configuration backups, environmental backups, then you can expect questions in AWS config. A classic question would be, how does AWS config work along with AWS CloudTrail? AWS CloudTrail actually records user API activity on the account, and any HTTPS access or any sort of access that's made to the cloud environment, that's recorded in the CloudTrail. In other words, any API calls, the time is recorded, the type of call is recorded, and what was the response given? Was it a failure? Was it successful? They also get recorded in CloudTrail. It's actually a log. It actually records the activity in your cloud environment. On the other hand, config is a point-in-time configuration details of your resources. For example, at a given point, what are all the resources that were present in my environment? What are all the resources, or what are the configuration in those resources at a given point? They get captured in AWS config. Right? So with that information, you can always answer the question, what did my AWS resource look like at a given point in time? That question gets answered when we use AWS config. On the other hand, with CloudTrail, you can answer the question, by looking at the CloudTrail or with the help of CloudTrail, you can easily answer the question, who made an API call to modify this resource? That's answered by CloudTrail. And with CloudTrail, we can detect if a security group was incorrectly configured and who did that configuration. Let's say there happened to be a downtime and you want to identify. Let's say there happened to be a downtime and you want to identify who made that change in the environment. You can simply look at CloudTrail and find out who made the change. And if you want to look at how the environment looked like before the change, you can always look at AWS config. Can AWS configure or AWS config aggregate data across different AWS accounts? Yes, it can. Now this question is actually to test whether you have used AWS config or not. I know some of the services are very local, is it? Some of these services are availability zone specific, some of them are regional specific, and some of them are global services in Amazon. And though some of these services are region services, you still can do some changes, add some configuration to it and collect regional data in it. For example, S3 is a regional service, but still you can collect logs from all of the regions into an S3 bucket in one particular region. That's possible. And CloudWatch is an regional service, but still you can, with some changes to it, with some adding permissions to it, you can always monitor the CloudWatch that belongs to CloudWatch logs that belongs to other regions. They're not global by default, but you can do some changes and make it global. Similarly, AWS config is a service that's a region-based service, but still you can make it act globally. We can aggregate data across a different region and different accounts in an AWS config and deliver the updates from different accounts to one S3 bucket and can access it from there. AWS config also works or integrates seamlessly with SNS topic. So, anytime there is a change, anytime a new data gets collected, you can always notify yourself or notify a group of people about the new log or the new config or new edit that happened in the environment. Let's look at some of the database questions. Database should be running on reserved instances. So whether you know that fact or not, the interviewer wants to understand how well you know that fact by asking this question. How are reserved instances different from on-demand DB instances? Reserved instances and on-demand instances are exactly the same when it comes to their function, but they only differ based on how they are built. Reserved instances are purchased for 1 year or 3 year reservation, and in return we get a very low per hour pricing because we're paying upfront. It's generally said that reserved instance is 75% cheaper than on-demand instance, and Amazon gives you that benefit because you're committing for 1 year and sometimes you're paying in advance for the whole year. On the other hand, on-demand instances are built on an hourly price. Talking about autoscaling, how will you understand the different types of autoscaling? The interviewer might ask this question: which type of scaling would you recommend for RDS and why? There are two types of scaling, as you would know now, vertical and horizontal. And in vertical scaling, we can vertically scale up the master database with a couple of clicks. Alright, so that's vertical scaling. Vertical scaling is keeping the same node and making it bigger and bigger. If previously it was running on T2 micro, now we would like to run it on M3, 2 times large instance. Previously it had 1 virtual CPU, 1 gigabit. Now it's going to have 8 virtual CPU and 30 gigabit of RAM. So that's vertical scaling. On the other hand, horizontal scaling is adding more nodes to it. Previously it was running on 1 VM. Now it's going to run on 2, 3, 10 VMs. Right, that's horizontal scaling. So database can only be scaled vertically, and there are 18 different types of instances we can resize our RDS to. Right, so this is true for RDS MySQL, Postgres, SQL, MariaDB, Oracle, Microsoft SQL servers. There are 18 type of instances we can vertically scale up to. On the other hand, horizontal scaling are good for replicas. So they are read-only replicas. We're not going to touch the master database. We're not going to touch the primary database, but I can do horizontal scaling only with Amazon Aurora, and I can add additional read replicas. I can add up to 15 read replicas for Amazon Aurora and up to 5 read replicas for RDS MySQL, Postgres, SQL, and MariaDB RDS instances. And when we add replica, we are horizontally scaling, adding more nodes, right? Read-only nodes. So that's horizontal scaling. So how do you really decide between vertical and horizontal scaling? If you're looking to increase the storage and the processing capacity, we'll have to do a vertical scaling. If you're looking at increasing the performance or of the read-heavy database, we need to be looking for horizontal scaling, or we need to be implementing horizontal scaling in our environment. Still talking about database, this is another good question you can expect in the interview. What is the maintenance window in Amazon RDS? Will your DB instance be available during the maintenance event? Alright, so this is really to test how well you have understood the SLA, how well you have understood the Amazon RDS, the failover mechanism of Amazon RDS, stuff like that. So RDS maintenance window, it lets you decide when a DB instance modification, a database engine upgrades, or software patching has to occur. And you actually get to decide, should it happen at 12 in the night, or should it happen at afternoon? Should it happen early in the morning? Should it happen in the evening? You actually get to decide. And automatic scheduling by Amazon is done only for patches that are security and durability related. Sometimes Amazon takes down and does automatic scheduling if there is a need for a patch update that deals with security and durability. And by default, the maintenance window is for 30 minutes. And the important point is the DB instance will be available during that event because you're going to have primary and secondary, right? So when that upgrade happens, Amazon would shift the connection to the secondary, do the upgrade, and then switch back to the primary. Another classic question would be, what are the consistency models in DynamoDB? In DynamoDB, there is eventual consistency read. This eventual consistency model, it actually maximizes your read throughput. And the best part with eventual consistency is all copies of data reach consistency within a second. And sometimes when you write and when you're trying to read immediately, chances that you would still be reading the old data. That's eventual consistency. On the other hand, there is another consistency model called the strong consistency or strongly consistent read, where there is going to be a delay in writing the data, making sure the data is written in all places, but it guarantees one thing, that is, once you have done a write and then you're trying to do a read, it's going to make sure that it's going to show you the updated data, not the old data. You can be guaranteed of it that it is going to show the updated data and not the old data. That's strongly consistent. Still talking about database, talking about NoSQL, DynamoDB or NoSQL database, which is DynamoDB in Amazon. You could be asked this question: what kind of query functionality does DynamoDB support? DynamoDB supports get and put operation. DynamoDB supports, or DynamoDB provides flexible querying by letting you query on non-primary key attributes using global secondary index and local secondary indexes. A primary key can be either a single attribute partition key or a composite partition sort key. In other words, a DynamoDB indexes a composite partition sort key as a partition key element and a sort key element. And by holding the partition key, when doing a search or when doing a query, by holding the partition key element constant, we can search across the sort key element to retrieve the other items in that table. And the composite partition sort key should be a combination of user ID partition and a timestamp. So that's what the composite partition sort key is made of. Let's look at some of the multiple choice questions. Sometimes some companies would have a written test or an MCQ type online test before they call you for the first level or before they call you for the second level. So these are some classical questions that companies ask in their multiple choice online questions. Let's look at this question. As a developer, using this pay-per-use service, you can send, store, and receive messages between software components. Which of the following is being referred here? Let's look at it. Right, we have AWS Step Functions, Amazon MQ, Amazon Simple Queue Service, Amazon Simple Notification Service. Let's read the question again. As a developer, using this pay-per-use service, so the service that we are looking for is a pay-per-use service, you can send, store, and retrieve messages between two software components, kind of like a queue there. So what would be the right answer? It would be Amazon Simple Queue Service. Now, Amazon Simple Queue Service is the one that's used to decouple the environment. It breaks the tight coupling and then it introduces decoupling in that environment by providing a queue or by inserting a queue between two software components. Let's look at this other question. If you would like to host a real-time audio and video conferencing application on AWS, right? It's an audio and video conferencing application on AWS. This service provides you with a secure and easy to use application. What is this service? Let's look at the options. They are Amazon Chime, Amazon Workspace, Amazon MQ, Amazon AppStream. You might tend to look at Amazon AppStream because it's real-time and a video conference, but it's actually for a different purpose. It's actually Amazon Chime that lets you create chat and create a chat board and then collaborate with the security of the AWS services. So it lets you do the audio, it lets you do the video conference, all supported by AWS security features. It's actually Amazon Chime. Let's look at this question. As your company's AWS solution architect, you are in charge of designing thousands of individual jobs which are similar. Which of the following service best serves your requirement? AWS EC2 Autoscaling, AWS Snowball, AWS Fargate, AWS Batch. Let's read the question again. As your company's AWS solution architect, you are in charge of designing thousands of individual jobs which are similar. It looks like it's batch service. Let's look at the other options as well. AWS Snowball is actually an storage transport service. EC2 Autoscaling is introducing scalability and elasticity in the environment, and AWS Fargate is container services. AWS Batch is the one is being referred here that actually runs thousands of individual jobs which are similar. AWS Batch is the right answer. Right, let's look at the other one. You are a machine learning engineer and you're looking for a service that helps you build and train machine learning models in AWS. Which among the following are we referring to? So we have Amazon SageMaker, AWS Deep Lens, Amazon Comprehend, AWS Device Farm. Let's read the question again. You are a machine learning engineer and you're looking for a service that helps you build and train machine learning models in AWS. Which among the following are referred here? The answer is SageMaker. It provides every developer and data scientist with the ability to build, train, and deploy machine learning models quickly. That's what SageMaker does. Now, for you to be familiar with the products, I would recommend you to simply go through the product description. There's one page available on Amazon that explains all the products, quick, neat, and simple. That really helps you to be very familiar with what the product is all about and what it is capable of. Is it a DB service? Is it a machine learning service? Or is it a monitoring service? Is it a developer service? Stuff like that. So get that information, get that details before you attend an interview, and that should really help to answer or face such questions with great confidence. So the answer is Amazon SageMaker, because that's the one that provides developers and data scientists the ability to build, train, and deploy machine learning models quickly as possible. All right, let's look at this one. Let's say that you are working for your company's ID team and you are designated to adjust the capacity of the AWS resource based on the incoming application and network traffic. How do you do it? So what's the service that actually helps us to adjust the capacity of the AWS resource based on the incoming application? Let's look at it. Amazon VPC, Amazon IAM, Amazon Inspector, Amazon Elastic Load Balancing. Amazon VPC is a networking service. Amazon IAM is an username password authentication. Amazon Inspector is a service that actually does a security audit in our environment. And Amazon Elastic Load Balancer is a service that helps in scalability. That's in one way, indirectly that helps in increasing the availability of the application, right? And monitoring how much requests are coming in through the Elastic Load Balancer, we can actually adjust the environment that's running behind it. So the answer is going to be Amazon Elastic Load Balancer. All right, let's look at this question. This cross-platform video game development engine that supports PC, Xbox, PlayStation, iOS, and Android platforms allows developers to build and host their games on Amazon's servers. So we have Amazon GameLift, Amazon Greengrass, Amazon Lumberyard, Amazon Sumerian. Let's read the question again. This cross-platform video game development engine that supports PC, Xbox, PlayStation, iOS, and Android platforms allows developers to build and host their games on Amazon servers. The answer is Amazon Lumberyard. This Lumberyard is an free AAA gaming engine deeply integrated with AWS and Twitch with full source. This Lumberyard provides a growing set of tools that helps you create an highest game quality applications, and they connect to a lot of games and vast compute and storage in the cloud. So it's that service they are referring to. Let's look at this question. You are the project manager of your company's cloud architect team. You are required to visualize, understand, and manage your AWS cost and usage over time. Which of the following service will be the best fit for this? We have AWS Budgets, we have AWS Cost Explorer, we have Amazon Workmail, we have Amazon Connect. And the answer is going to be Cost Explorer. Now, Cost Explorer is an option in the Amazon console that helps you to visualize and understand and even manage the AWS cost over time. Who's spending more? Who's spending less? And what is the trend? What is the projected cost for the coming month? All these can be visualized in AWS Cost Explorer. Let's look at this question. You are a chief cloud architect architect at your company, and how can you automatically monitor and adjust computer resources to ensure maximum performance and efficiency of all scalable resources? So we have a CloudFormation as a service, we have AWS Aurora as a solution, we have AWS Autoscaling, and Amazon API Gateway. Let's read the question again. You're the chief cloud architect at your company. How can you automatically monitor and adjust computer resources? How can you automatically monitor and adjust computer resources to ensure maximum performance and efficiency of all scalable resources? This is an easy question to answer. The answer is autoscaling. Right? That's a basic service and solution architect course, is it? Autoscaling is the service that helps us to easily adjust, monitor, and ensure the maximum performance and efficiency of all scalable resources. It does that by automatically scaling the environment to handle the inputs. Let's look at this question. As a database administrator, you will use a service that is used to set up and manage databases such as MySQL, MariaDB, and PostgreSQL. Which service are we referring to? Amazon Aurora, Amazon Elastic Cache, AWS RDS, AWS Database Migration Service. Amazon Aurora is Amazon's flavor of the RDS service, and Elastic Cache is the caching service provided by Amazon. They are not full-fledged database. And database migration service, just like the name says, it helps to migrate the database from on-premises to the cloud and from one database flavor to another database flavor. Amazon RDS is the service, is the console, is the service, is the umbrella service that helps us to set up, manage databases like MySQL, MariaDB, and PostgreSQL. It's Amazon RDS. Let's look at this last question. A part of your marketing work requires you to push messages onto Google, Facebook, Windows, and Apple through APIs or AWS Management Console. You will use the following service. So the options are AWS CloudTrail, AWS Config, Amazon Chime, AWS Simple Notification Service. All right, it says a part of your marketing work requires you to push messages. It's dealing with pushing messages to Google, Facebook, Windows, and Apple through APIs or AWS Management Console. You will use the following service. It's Simple Notification Service. Simple Notification Service is a message pushing service. Right? SQS is pulling. Similarly, SNS is pushing. Right? Here it talks about a pushing system that pushes messages to Google, Facebook, Windows, and Apple through API, and it's going to be a simple notification system or a simple notification.
Hello everyone. In today's session, we are going to talk about AWS best practices. So this is the agenda for today. We will talk about billing best practices. We will have a look at best practices for EC2, which is the Amazon Elastic Computer Cloud. We will walk through best practices for IAM, which is Identity and Access Management. Then we will walk through the best practices for S3, which is Simple Storage Service. And then we will have a general look at the security best practices from the Amazon account perspective, as well as from the general Amazon Web Services perspective. Now let's start with billing best practices. So billing essentially is the core of every company. Every company wants to keep billing to the minimum and cost to the lower side. So one of the best things about Amazon is that it gives you a good way of controlling your costs. So from the billing specific side, from the billing console side, there are a lot of things you can do as a best practice and also reduce cost. So Amazon gives you something called billing budgets. Now this is interesting. So they give you an option to actually create a budget kind of thing wherein you specify you want X amount of dollars for the next budget. Now, whenever you hit that budget, let's say it's $200, you get an email notification. Now, these budgets can be service specific. They can be specific to some service like EC2. So if you want to have a billing alert when the EC2 instances of the account hit almost $200, you can create that. One of the other best practices from Amazon billing side is to give limited access to IAM account users to billing. So, by default, Amazon does not allow billing access to IAM users. But you can specifically allow them if you have got some users who look at the billing perspective of your account. Now, if you have a bill which crosses $10 to $15, and it's not possible to pay using a single credit card or debit card, Amazon gives you an option to pay using multiple credit cards. So as a best practice, if your bill has crossed a big amount and you are not able to pay using a single credit card, if you are a good enterprise, it's always good to have 2 or 3 credit cards added to your account. so that even in the case when your one card can't fulfill the bill, you can have another account which automatically lets you pay the bill. So that way you don't risk your infrastructure. Your infrastructure is always safe. Now, one of the other best practices is to have regional taxation enabled in your account. For every country, there's a different taxation regime, and the tax methodology and tax rates are different. So instead of getting a notice from your income tax department, or to avoid being non-compliant to taxes, it's the best practice to have the billing number. So every country has the specific unique billing number, which you can put into the Amazon account, and then it automatically charges that or files taxes from Amazon's behalf on that number. So at the end of the year, when you are doing tax filing, you can easily show that you have paid X amount of money from Amazon. So you don't have to repay that, or if in your country the tax is collected at the end of the year in a consolidated way, you are more compliant. Now let's say that an enterprise which has got multiple accounts in Amazon Web Services. So let's say for Project A you have a different account. For Project B you have a different account. So you can consolidate the billing of those if you don't want to have a headache of having multiple account billing. You don't want to have to separate credit cards for every account. So what you can do is you can consolidate the billing of each and every account into a single account. That would essentially give you a single consolidated bill. So you can also consolidate your taxes there. In that case, you can have a single cooperate credit card, which can have a lot of limit. There are credit cards which give you no limit virtually, so you can use those kind of credit cards. Now, coming to EC2 best practices. One of the best practices from EC2 side is AMI hardening. So Amazon gives you Amazon machine images, which are exact snapshots of servers. Now, these machine images are used to spin up new machines. So these are like seat files for new servers. Now you just can't have a stock OS image and use that as a base for your entire infrastructure. You need to have a hardened AMI. Now when I say a hardened AMI, what I exactly mean is to have an AMI which has got all the security practices implemented into it. Now as far as the Linux OS is concerned, an AMI which is hardened would have the SSH port changed, SSH password-based logins disabled, security enhanced Linux set to enabled if it's CentOS. If it's Ubuntu, maybe you can enable the firewall and only allow port 22. The next thing is VPC port lockdown. So apart from the instant level firewall port lockdown, you should also lock down ports specifically to IP addresses. If not possible to IP addresses, then at least you should make sure that in your VPC, all the security groups have got only the specific ports which are required by that server or application open to specific IP addresses. If you have to open something up to the entire world, make sure that you have got adequate checks PPP inside your application, so you don't have a malware user trying to do DDoS service attack. Although Amazon has got a required hardware in place to check the DDoS attack. But yes, there can be still valid amounts of attacks that go into your application if you don't plan the application correctly. One of the other things you should take care when you are running instances on EC2 is that you have private subnets for everything other than the load balancer or the web application tier. Now this is important because you don't want anyone to be directly able to access your Rediff, CCC, your database, or your internal backend systems. Because most of these systems, for example, let's say Rediff, don't have authentication built into them. So if you have the port exposed, anyone can go in and pull all the keys. Now, from an application division perspective, you should make sure that the application is divided into small microservices. So it used to be known as Service-Oriented Architecture, SOA. Now the term has changed and people call it microservice architecture. So the basic idea behind microservice architecture is that big monolithic applications are divided into small chunks of application, which are exposed over as a service to the internet to the end users. Now this helps you to scale them individually, and one of the best advantages you get out of such a microservice architecture is that even if one of the applications is down, the others can actually still function without affecting this one. Now, this is very important because in today's e-commerce world, a single minute of downtime can cost millions of dollars of loss. So when you have microservice architecture, you can scale vertically or horizontally each microservice without worrying about downtime. you should take care while designing microservice architecture so that the microservice architecture is independent at every level. One of the mistakes which happens is that you have a microservice architecture at the web server or the application server layer, but then you have a common database. So how is it going to affect the microservice architecture in any way? I understand that it's very difficult to have independent database microservice architecture. But yes, there are companies who do sync-ups of databases just to make sure they have totally independent microservices. Now, in such a scenario, even if the back-end database of a particular microservice is down, the other functionality can work. Take an example. Let's say there is login functionality which talks to the back-end database and gets to data from there. Let's say there is another functionality which lets you buy stuff. Both of them should have independent databases, and there should be a sync-up every minute. Or there should be push-based mechanism where there is sync-up only when they're in one of the DBs. Now, if you have both these microservices having independent databases, your logins will still work even if your payments are down, or your payments will still work if your login functionality is experiencing some degraded performance. You have stock images on Amazon, that Amazon provides you environment-based key or keys which are there for every instance. So every machine you launch on Amazon has got a key. You can't just use the username and password to log in. Now the advantage of key is that you don't have to provide clear text passwords, but you have to make sure that for every environment, so let's say you got a production environment QA test environment, make sure every environment has got a different key. The reason is if you have a single key across all the environments, and let's say you give a developer access to one of the environments, he can automatically gain access to each and every environment. So that's not a good thing, right? You don't want developers to access production environments. Now, if you have 100 EC2 instances and you have users to manage, let's say you should make 10 users are there on every machine, which are 10 members of your dev team. So it's very difficult to create manually. Let's say you also want to do password expiry and a lot of intelligent stuff on these users. You can actually use something called LDAP. This LDAP is basically centralized authentication system, which lets you authenticate users across machines. So you can change the password for a user on one LDAP server, and it's reflected across all the machines. So let's have a look at IAM best practices. So IAM is Identity and Access Management Service of Amazon, and it allows you to have fine-grained controls over the access. Now, as a best practice for your teams, you should have various roles defined. Each of those roles should be specific to what each member is doing. Let's say you have a read-only dev role assigned to your developers. You can also have DevOps Engineer role, which you assign to your DevOps Engineering team members. You can assign roles to the finance team, which has billing access. Now this gives you the flexibility to easily assign policies or attach policies to various users without having to manually do them. This is useful in a scenario wherein you have a custom role, wherein you have a reporting engineer which needs access to billing to create reports of CPU utilization. Now, you can give them a specific access by assigning specific policies. You can have new joinees or freshers who have joined your team have a read-only access, so that way they don't mess up the account, and they also have got full access to the account. So they can go and they can see what the environment's like. They can read, but they can't change anything. So that way, you safeguard your account by any accidental mistakes by those freshers or new joinees. You can have service-specific access. So let's say you have an EC2 instance, which requires access to S3 buckets, so you actually create a role in IAM and assign that specific role to EC2 instances. You can also have special service-specific roles. Now, these service-specific roles have got access to specific service of Amazon. And you can use this, let's say, in case you want to give some developer access to some dev environment of Elastic Beanstalk. So you can create a role which has the access and the policies attached for Elastic Beanstalk read-only access to that specific region. So that way, you can control a specific service and specific action. Now let's have a look at S3 best practices. S3 is Simple Storage Service, and it's one of Amazon's most important services. It's one of the most used services as well. Now, in case of S3, you should make sure that you have context-specific names. Now, these names can be the type of function that S3 bucket is performing. So let's say images, and then -dev, and then -region, and then -top-level domain. So you have a unique name. So Amazon has a policy wherein they have a single namespace for all the S3 buckets of the world, which in other words means that if you have a name which is already chosen by someone in the world of an S3 bucket, you will not get that name. So obviously you will have to have long names since all shorter names would have been taken. In order to make that long name meaningful, make sure you break that into a specific context so that when you look at that bucket, you already know this is what this bucket is doing. You should make sure you have bucket policies for buckets, which are accessible by other users. These policies can be generated in the policy generator, or you can create fine-grained self-made policies. For buckets which are very much live and large and have got tons of data, you should archive them to Glacier, because Glacier gives you very cheap storage, although there is a retrieval time associated with that. But yes, you should make sure to archive the buckets. So if you've got some critical objects in a bucket, you should make sure that you also save a version of your object, because you can go back to a previous version of that same object. Now in this case, you don't actually lose any version of that file. You always have the important version of that object. From security best practices, never share your root account details with anyone. Because if someone has got root account details of your account, you can actually do anything. Make sure people who leave your organization, you remove their access, and you don't keep them as stale accounts. You should also enable two-factor authentication, either with Google Authenticator or some hardware device access token, which flashes a 6 or 4-digit random number, so that it can be added as an added layer of security. You also should enable IAM login. Don't give root access to even trusted users. So in IAM, you have a name and an ID, which shows you that this guy did this at this time.
And with that, we have come to the end of this video on AWS full course. I hope you found it useful and entertaining. Please ask away any questions about the topics covered in this video in the comments box below. Our experts will assist you in addressing your problems. Thank you for watching, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.